不思議な音 who is that? Okay, good morning, everybody. I have the honor to open the second day. I would like to give you a little bit of a wrap-up from yesterday, which was already on a very high level. So in the evening, that we were really, really happy about the good start. Already in the morning, yesterday morning, that we have plenty of side events with a lot of interactions, especially the Hungarian User Day, as well as also the National Collaboration Program, and then on the side with very, very engaging participants and discussions, which is rolling out now into the plenary session here in the GA. This is just to remind you, kind of the logic of our narrative, that we are still in the first block, the authoritative climate knowledge. That we are continuing today in this session with the first block, and then moving forward into method, tools, and capacity. We already had that yesterday a little bit with that, and then also from climate information to decision and impact. And that was also already kind of an ingredient of the recipe from yesterday, but it is going to grow now when we are now continuing in that logic. We clearly have seen. Let me see my notes here. We clearly have seen that the C3S is a trusted provider of this authoritative climate knowledge, and that we were rolling out the different aspects from satellite and in situ observations. Of course, we have been talking about reanalysis, what's coming up in RS6, and that very exciting news, and that we were deep diving into the regional analysis, and that Cara 1, Cara 2, and that what is going to be expected here. We had been deep diving into the ECVs, and so a lot of knowledge production that is being done in C3S. We were talking further about the predictions, of course, and that it is not only about the past and present, but also about the future, and got the insights, and that the climate atlas, and that which is today also being on the menu again. We started with an opening session, and that very, very strongly, with two perspectives. And that one is the national one from Hungary, as well as then complementary to the perspective from the European level. And that is also now being passed through today as well as and tomorrow. And then by the end of the day, we had a very strong talk, again from a Hungarian representative, Barbara Vassan, about the importance of policy, which is then being an aspect also today as well as especially tomorrow. And if you're still staying for tomorrow afternoon, you are all welcome to join the workshop on the future of climate services. There were a couple of questions. If it is open, you are all welcome to join. And yeah, I would like to welcome you to do so. So for not eating up too much time, that was an issue yesterday as well, and that too much to talk, I will give the floor to Maciej. Yes, I learned that yesterday, the right pronunciation. And I'm very, very happy that he is joining us with a perspective of DG Klima, Directive General of the Climate Action from the European Commission. Maciej, the floor is yours.
Okay, thank you for the invitation. Good morning. I must say, for the policy area, the bar yesterday presentation of our Hungarian host was set pretty high, so I'll try, maybe not too much, but at least to go into the direction of good policy background. And in this yesterday's presentation, of Dr. Vassen on actionable climate information, she mentioned the need of building the bridges between the policymakers and the climatologists. I hope my intervention would go into this direction. Let me first give you some background on the changing landscape of EU climate policies. While their main pillar, EU climate law, does not change, other policies undergo changes and evolutions. And just to remind you, on the climate law baselines, we are aiming at 55% of emission reduction from 1990 levels until 2030, and 90% reduction until 2040. The way to achieve the 2040 goal is now undergoing significant changes. I will mention that later in my presentation. Barely 2 years ago, EU has welcomed 2 reports on the state of European competitiveness and the ways to improve it, the Letta and the Draghi reports. Triggered by these reports, EU began to introduce a set of policies driving its competitiveness while maintaining the climate targets. It appeared that almost all these policies require climate science and climate projection support. For instance, from the new policies, Net Zero Industry Act foresees promoting in EU solar on and offshore wind power, and as well as other energy policies, extensive development of electricity grid. It is followed by Industrial Accelerator Act, which is supporting a rollout of such clean energy and clean tech development in selected EU areas. From the old instruments, the Innovation Fund, finance from the emission trading system revenues is still supporting innovation in all clean tech and clean energy sectors. These new policies for renewable energy require more and more precise multi-year climate projections to well select EU areas, ensuring acceptable return of investment. At the same time, these investments are becoming EU critical infrastructure, avoiding our overdependence from the fossil fuels, especially in currently geopolitically unstable times. To protect this critical infrastructure, as well as other societal and economic activities of European citizens against accelerating impacts of climate change in Europe, we are introducing European Integrated Framework for Climate Resilience, an adaptation policy toolset based on comprehensive climate risk assessment. It's called EUCRA. The previous speakers have already mentioned very high level of magnitude of climate and weather-related extremes, causing losses in Europe of 822 billion euro over the last 40 years, with a quarter of these losses occurring only over the last 4 years. So at the level of the climate risks identified by EUCRA, several are already at the critical levels. With these facts in mind, we need the transformational change to make Europe significantly better prepared for and more resilient to climate impacts. We need to build resilience by design. We need to clearly define risk owners. What is especially relevant for this audience, we need to establish a reference global warming trajectory, providing a common understanding of the level of global warming for the coming decades. So in this context, we see the importance of C3S multi-decadal projections. Such trajectory will be the reference point for climate resilience planning and investments in Europe. The key enabler for the implementation of the framework will be the European Climate Viewer, an interactive web map for exploring current and projected information across EU, such as climate hazards indicators, exposed assets, vulnerable population, and sectoral impacts. With this tool, we are hoping to give non-climate experts, such as European and national policy and decision makers, access or easy access to reliable information on climate risks and their impacts across Europe. In the viewers implementation, we see climate change service playing a central role with, so far, a highly productive collaboration. With this collaboration, we also appreciate C3S coordination with European Investment Bank Taxonomy Hazard Tool, which coordination will provide consistency for all the European users of both tools. Not only for the climate viewer, but also across all C3S tools like reanalysis, state of the climate report, CDS projections, are we counting of climate change service to provide and maintain the authoritative climate evidence base. Such solid base which ensure DG Climate and other Commission directorates with harmonized, credible basis for regulatory decisions, climate risk assessments and adaptation measures. With following, at the end of this year, a publication of the framework, we would anticipate even more demand for C3S applications to support European sectoral policies to become climate resilient. Therefore, we encourage C3S seizing this opportunity and building on the main sectoral projects in the areas such as water, agriculture, health, and already mentioned critical infrastructure. Towards the end, I would also like to underline the importance of global projections and land and biomass assessments. This is due to planned inclusion of international carbon credits in EU 2040 climate goal and our need on their independent verification. In the international climate action, we will continue European efforts encouraging collective actions after Paris Agreement to limit emissions based on recognized IPCC scenarios. Here we also welcome C3S contribution to the panel's publication. Equally, in the international domain, we will also encourage climate change services and its member states for bilateral climate assessments based on C3S and Copernicus products for non-EU developing countries, which EU could also support from cooperation funding. DG Climate will facilitate such initiatives within our bilateral climate diplomacy and agreements. I could probably continue speaking about further synergies in our policies and C3S initiatives and tools for a longer time. Still, we will continue our efforts to intensify DG Climate cooperation with Copernicus Climate Change Service for undertaking even more policy and scientific challenges. From EU climate policy side, let me wish C3S and all these partners and collaborators another year of fruitful cooperation. Thank you.
Thanks a lot, Maciek, for this very nice talk, and that it was also touching on content that we listened yesterday, as well as also that we were going to roll out tomorrow. Are there any questions to Maciek? Well, if this is not the case, then that we can directly continue with Samantha. That I welcome you on stage. You're most likely very well known that she's the deputy director of rolling out the activities on climate intelligence on ECMWF, and I'm looking forward to hear more about that.
So thank you, everyone. I'm not very good at standing still, so please let me know if you can't hear me at the back of the room. I'm up here on stage, but ultimately the presentation that I'll be sharing today is very much a team effort. We heard from the ECV part of the team yesterday, and so much of that data goes into the climate monitoring. And yeah, the team is quite large now. It's something that ECMWF and C3S have invested in enormously over the phase of COP2. And I think hopefully you'll all agree in the room, because this is one of the highlights for us, being able to engage with you directly and talk about what we're doing and what else we could be doing, could or should be doing with time and capacity. But yeah, we'll do a whistle-stop tour of the status of the climate. We've heard from Marche and from the speakers yesterday about the future climate risk, but ultimately we can't prepare for any future climate risk unless we understand our present climate reality. And our present climate reality is that the world has changed and we are already living in a warmed world. We work with a very dedicated team of scientists, and we have a data visualizer, and this is one of my favorite graphics that we've produced this year. So this is the daily average annual temperature, and the bar graph, the bell curve shows how our climate has changed according to Era 5, so in the record of our reanalysis. And this figure really went viral at the beginning of the year. And that's always one of the great things when we see not only people sharing our information, but other scientists leveraging this as a touch point to show how clearly our world has changed. And one of the really... That was very unexpected, but thank you. And one of the things that I really like this is 2025 was the first year that every single day that year was above the climatological average. So this really brings it home to people how much of a changed world we are living in. So what does this mean for policy? What does this mean for the Paris Agreement? So right now, the Paris Agreement is 11 years old. And we are not where we should be, where we expected to be. So right now, we're at about 1.35 to 1.4 degrees of warming, and 1.5 is just around the corner. So when we look at when we expect to hit the long-term average of 1.5, we've already had 3 years above that rate. It's later this decade. When the Paris Agreement was signed, it was 2042. So we have lost that time through inaction. So the more we can communicate more clearly on how important it is to manage our emissions and manage our adaptation to make the world a better place, not only for people, but for the rest of the planet as well, it's really critical. So I've already mentioned 2025 was the third warmest year on record. The climate intelligence team have a number of products that are released throughout the year. So the biggest one is the Global Climate Highlights, in terms of media impact. So that's released in mid-January. We coincide the timing of this product release with all the other data producing centers around the world. So this year, our press release embargo lifted at the same time as the UK Met Office, NOAA, NASA, and Berkeley Earth. The WMO then came after us to provide an aggregated data set using all those 7 international data sets. And what we can see for the last 3 years is we've already had 3 years above that 1.5 degrees. This doesn't mean anything in isolation, but it's not a good sign. So the more we can talk about our current risk, hopefully the more we will get better action and better understanding of the true implications of climate change. So this is another favorite graphic of mine. I'm probably biased because of the climate stripes history, but one of the things that I really like about this figure is the last 3 years really stand out, and every single monthly record for the 12 months of the year has been broken over the last 3 years. And you can still see that September 2023, where one climate scientist called the anomaly gobsmackingly bananas, which is a phrase that will always stay with me, that really stands out. And in 2025, we had a record-breaking January. So last year, we only had one monthly record broken, but we're living in a changed world. We know that in 23 and 24, we had the El Nino event. We're facing another El Nino event. We still, as mentioned yesterday, don't know how intense it will be, but we're in a world where the ocean is already incredibly warm. So the impacts that will come from combined high global mean temperature and the El Nino event are not good news for many, many people. So the other major production that we released in April is the European State of the Climate Report. This year was the 9th edition. We've partnered with the WMO, so the European report is one of the official reports with the WMO for Region 6. So we work very closely with the RCC for Europe as well, which is really fantastic. We've got some of those members in the room. And this year, every year with the WMO, we have a policy and action section, and this year we focused on biodiversity. So again, our data visualizer got very creative with the average annual temperature anomalies for Europe. And so this organic form that looks like a tree is data of the European climate trend. So we can see that the individual leaves, if you will, or trees are the annual anomaly. And the last 3 years really stand out. So the green ones are cooler than average. And again, you can see from this graphic that it's been a long time since we've had a year cooler than average. And the last 11 years have been the 11 warmest on record. So the European State of the Climate Report is an enormous production. We work with over 100 scientists across Europe and globally. We use 45 data sets. This is a graphical representation of the 142 data visualizations that are included both in the report, and we have a number of other products as well. So we've got a interactive key events map that, again, we pull directly from the National Met Services and the WMO information. We have a summary that Carlo talked about yesterday. We've got a full report that's available, downloadable as a PDF. And we've tried to shrink the product rather than grow it. So we also have a supportive graphics gallery. So within each section, there's only 2 or 3 figures, but then there's a lot more supporting figures in the graphics gallery that is all free and open for people to reuse. So now into the data of what we showed last year. And for me, the key questions that kept coming out again and again from the interviews that took place with journalists after the launch of the report was, why is Europe warming at twice the global average rate? And what does this mean? What are the report covers 21 different indicators. It's something like 30,000 words. So it's really hard to digest the amount of information that's included in the report. So working with data visualizations and working with this team of scientists, we really try and synthesize this. So here we've used a couple of different infographics to try and showcase how different Europe is from the rest of the world. And you can see the rate of warming is not equal, both across the world and across Europe. The Arctic is obviously warming at 3 times the global average rate. So the global average rate for the last couple of decades is 0.27 degrees. Europe is over double that at 0.56 degrees, and the Arctic is obviously 3 times faster. When we go to looking at the diversity across Europe, where we're standing right now is one of the warmest, fastest warming regions, but as is Svalbard. So we've got Europe between the southeast that is warming quicker than the European average, but then of course the northern European Arctic, which is also warming incredibly quickly. And why is this? So it really comes down to geography and changes in reflectivity. So if we go to geography first, land is obviously warming up faster than the ocean, and the northern hemisphere has a lot more land than the southern hemisphere. We also have changing weather patterns that particularly impact us in the summer months. So this favors more heat waves. We've also done a lot of policy improvements to improve our air quality, and this is great news for people's health, but it does mean we have clearer skies, which means we have less cloud cover bouncing that sun back into space. Of course, we have a lot less sea ice and a lot less snow and ice covering Europe as well during the season, so that's reduced reflectivity as well. Don't know why it's stuck. Can anyone move it on for me? Okay, great. So with these annual average temperatures, we also get more heat stress and less cold stress. So obviously, at the back of the room, these small multiples may be hard to unpack, but what you can see is on the left-hand side of the maps, you can see there's more orange and purple, and so there's more days of heat stress, and there's less dark blue, so there's less cold stress happening, and there's more heat stress happening. A heat stress for 2025 was one of the really interesting outcomes because we saw heat waves from the Mediterranean right through to the Arctic. So one of the spotlight sections was focusing on the record heat wave in subarctic Fennoscandia, and this was Europe's second most intense heat wave. And it was exceptional for a number of reasons. So we saw temperatures up to 34 degrees in and around the Arctic Circle. The intensity of the heat wave went on for 3 weeks, and there was over 2 weeks of heat stress in a region that normally only sees 1 to 2 days of heat stress. We also saw over 2 weeks of tropical nights, which in that region is really, really exceptional. Because of this growing interest on heat stress, we have a new application that we launched at the end of last summer. So we talked about the development of it at the last GA. It's now live, and so it's called Thermal Trace, and it looks at not only heat stress but also cold stress. So you can really go in and explore. Again, it's using ERA 5 heat as a product. So our UTCI index is derived from ERA 5 to really understand the changing heat stress. And this is the heat wave that impacted Europe a couple of weeks ago, and you can see that, where we are right now, including where I was a couple of weeks ago in the UK, was already receiving strong heat stress in May. So certainly from a UK context, we exceeded the May record. Parts of the UK also exceeded the June record. So we're seeing the summers grow in time. They're coming earlier, they're lasting longer, and they're much more intense, which obviously has huge health implications. Wildfires was another really critical issue for 2025. So we had the record burnt areas of over 1 million hectares and record amount of emissions, predominantly from the fires that were in the Iberian Peninsula. And we kind of had the perfect storm last year that the spring was particularly wet in the Iberian Peninsula, so there was a lot of vegetation growth. Then when the season changed, all of that fuel dried out and led to these record burnt area and record emissions for the year. This was also in the context of a warmer ocean. So and sea surface temperature, monitoring sea surface temperature is an increasingly important part of our products as well. And 86% of the European ocean suffered marine heat waves last year, but you can see that, suffered strong marine heat waves last year, and all of the Mediterranean has suffered marine heat waves across the whole basin for the last 4 years, and that's continuing to increase year on year. Why does this matter? Not only does it matter for fisheries and aquaculture, but it matters for biodiversity. So I mentioned that we focused on biodiversity for the policy and action section. This was one of the case studies looking at the seagrass species that's one of the keystone species in the Mediterranean. And we can see here that there's a huge number of sites across the Mediterranean, and there's already been a decline of about 30% of this species of Posidonia seagrass. And not all of that is through climate change, but it becomes more and more vulnerable. And seagrass is an extraordinary source of blue carbon, so it stores more carbon than tropical rainforest by like a factor of 30. It's a nursery ground for fish species, so the density of organisms in a square kilometre of seagrass is in the order of tens of thousands, so it's a really important part of our ocean habitat, and where that is threatened by climate change. So through this partnership with the WMO, we're able to go beyond the purely climatological signal and really talk about why it matters. Obviously, the flip side of this is not only focusing on the warming, but also focusing on the other end of the spectrum and what's happening in winter. So the snow area for 2025 was significantly less than average. I think it was something like 30% less than average by the end of the season. And this was about the combined area of Italy, Switzerland, Austria, and France, I think, combined. So a huge part of Europe is seeing a lot less snow by the end of the season. This has implications for the water cycle. It also has implications for recreational tourism in those months. And obviously, Greenland is also declining rapidly. So we had a new Greenland section this year, which was incredibly exciting to highlight the loss of ice in the glacier in Greenland as well. Okay, going on to hydrological conditions. One of the key takeaways for me was how different 2025 was to 2024. 2024 was an exceptionally wet year. We had all those storms impacting Europe, and we saw a huge amount of flooding, and that was really one of the key signals of the report. Whereas last year, it was the inverse. So we saw river flow below average for 70% of rivers across Europe, and 11 months of the year, rivers were below average. At the start of the growing season in May last year, it was one of the lowest soil moistures in the record going back to 1992. So, these implications are enormous for agriculture as well. So we saw extreme drought in 30% of Europe for May 2025, which really failed to set up the agricultural community for an effective season last year. So being able to report on these and forecast on these is incredibly important for people to be able to manage their risk. One of the other changes that we covered in the global climate highlights was, this warmer atmosphere. We all know it holds more moisture. And for 2024, we saw a record amount of water vapor in the atmosphere. So we produced this in January 2024. And then this was also verified through the BAM State of the Climate report that was published later that year. This has huge implications for extreme events. So here's a case study that we showed in the February monthly bulletin, where the combination of incredibly high sea surface temperatures across the central Atlantic impacted the atmospheric rivers that were dumping very intense rain on the Iberian Peninsula yet again. So and the Iberian Peninsula is already much wetter than average for the time of year, so it's not good news for this year's fire season either. Okay, and then we do try and not end with doom and gloom. So one of the touch points and the highlights for the report is focusing on energy generation from renewable energy, and we really saw these highlights we've overtaken fossil fuels for the last 3 years for renewable energy generation between solar and wind. And last year was a record year for solar. Okay, Niels is standing up, and this is my final slide. We saw some of these costs yesterday in the final presentation, and Masho talked about the Environment Agency's UCRA report, but ultimately, extreme events and climate is already costing the EU a huge amount of money, 45 billion annually, and that's only predicted to grow if we don't adapt and mitigate climate change. So I'll end it there. Thank you very much.
Please stay on stage. Oh, Samantha, very, very good talk on that, and no doubt we are talking about climate knowledge. And I also like the intervention that was coming from the audience, because one of the words in the slogan of this GA is interaction and interactive. So feel welcome to do so. That if you would like to have a question immediately, that you can stand up and that I would like to talk about that. So this is very, very welcome. I'm sure there are a couple of questions in the audience. Yes, please.
Thank you for that excellent presentation. And I totally agree with the need to present this climate information. I do have a concern. I wonder if you share it. It seems to me that presenting the information hasn't worked as much as we as the scientific community would maybe expect on a rational basis. And I also wonder that presenting such information seems to be more effective in motivating adaptation than mitigation. I wonder if you share that concern and why you think that is.
Yeah, so great question, and I agree 100%. And, you know, as much as most people in this room are very empirically driven, all of the social science agrees that facts and figures do not change people's minds. So for me, it's this catch-22 of we have to state our present climate reality, and I think we have to do that in the most visually interesting way possible to capture people's attention. But then that, you know, that's step one, right? And then people need to decide if it's an important issue to them, then, you know, they vote accordingly, they have conversations accordingly, and they scale that up within their individual communities of how they can change their behavior. So for me, it's very much the first step. And it's slow, it's really slow. The positive side of things that we have is, you know, we get more requests all the time for additional interviews. So the resonance within the international media that they want to cover this, which is not the status where we were 5 years ago. So that's rewarding. And then the second part of your question, I agree. Mitigation's really, it's a much more challenging issue because it requires investment in the energy transition. For me, the narrative that's much more effective is adaptation and climate-friendly cities are nicer places to live. There's more parks, there's more trees, there's more cool spaces, you know, there's more biodiversity. So that benefits our mental health, that benefits our health services. So that, for me, is a much lower lift. We all agree that if we have green spaces around us, it's a nicer place to be. So that is less challenging for people to deal with than, you know, buying a new EV or installing a heat pump or, you know, not flying 30 times a year to have their extreme days out.
Yes, there's a second question, and then a third one.
So thank you for a brilliant presentation. In connection with this last question, I think it's really useful for the services because although all the information and the data is there, there's still a sector, small sector, but very noisy of society that is still denying the situation, trying to throw misinformation. So all this information and visual graphics are really useful for the NMHSs to try to explain clearly the situation to the population. But I believe that one of the reasons that there's still this sector very persistent is because an economical reason. So for me, having this final picture, averaging the losses causes already for climate change is really important. The question is how possible, there will be a lot of uncertainty, but how possible would be in this trying to provide information to try to use economical models and estimate the losses and relate the losses with the taking or not certain decisions. Because if you put it in numbers, at least part of this denial sector, I believe that will possibly change their mind. And the investment you need to tackle and to go for mitigation and even for adaptation, it sounds more like an investment and not an expense if you put it against the mitigation on losses. So it's I don't know how much work and how possible it is to try to work into that direction.
Yeah, great question, and we'll definitely touch on that a lot more tomorrow morning with the presentations tomorrow. I think, you know, we all know economics is a model, and, you know, as much as the economists would like to give us confidence in their predictions, they're still predictions. But I think where we can ground ourselves in evidence is the losses that we've had already and the projection that these will only grow in a warmer world. So for me, that's where, there's papers coming out all the time. So the additional heat stress that Europe sees leads to, between 50 and 60,000 extra deaths per annum. So the loss of life, the implications on health infrastructure, the implications for our grandparents' generation is enormous. And I think awareness of that is growing more and more. And it's up to us to draw those connections. And I think, last year we saw the real challenge with, Valencia was incredibly well forecast, but the decision makers didn't do anything with that data. So for me, it's really important that we talk about the quality of the science and we don't talk about the decisions that come from that, because ultimately management of the severe event is out of our hands. But what we can give confidence is the scientists predicted it, then it's out in the public domain. And that's why, for me, it's such a privilege to work at C3S, where everything is free and open. And if I speak to a denier, it's like, well, go plot it yourself and come back and chat to me. And that's really reassuring.
Thank you very much.
Thanks a lot. Thanks a lot. And this is also kind of leading. There's one more question in the room that we're going to do that, and then we need to move forward. As much as I like these interactions here, but we will have more time also to interact with it.
Yeah, thank you for the fantastic presentation. Karl Baumann from the Institute for the Development of a Global Democratic Republic. I have only one brief question. You mentioned also the increase of the water vapor in the atmosphere. Do I get that right, that we have a self-reinforcing cycle here in the system? So the planet is heating, more water vapor in the atmosphere, planet is heating more. And if yes, you're obviously agreeing. Do we have that in our climate models already reflected? Thank you.
Yes, very much so. So it's called I always forget the first word, so the Clausian-Clapeyron. Anyway, the physics is very well known, and for every degree of warming in the atmosphere holds 7% more water. So given that we're at 1.4 degrees of warming, every rain event is potentially dropping 7 to 10% more rain. And we see that when we look at the details of the precipitation, that low rainfall days, so drizzly days, are becoming less frequent, and more intense rain days are becoming more frequent. So there's not a strong signal in rainfall, and it varies very much in space and time. So it's really hard to, unpack for Europe when we've got very different climatologies. But yeah, this is very well understood, and it's covered in all the global climate models, because it's just following the basic laws of physics.
Thanks a lot. I'm afraid we need to move forward, but we are still around, so there's plenty of opportunities to continue to talk. I'm welcoming Chris now on the stage, and probably a couple of questions which are still there might be answered by your presentation. He is a where is that? Here. He's a senior research scholar at the IESA, if I'm pronouncing that right, and specialized in the climate modeling and the emission scenarios, as well also a co-developer of the climate, the global climate indicators, and that is what you're talking about now.
Yes, thanks very much, everybody. Good morning. So I'm going to present the indicators of global climate change 2025. So we've recently partnered with Copernicus to develop these indicators. And there'll be a paper published next week in ESSD, and it'll be the fourth year that we have done the indicators of global climate change. So we started back in 2023, and as a group of predominantly IPCC authors from the sixth assessment report, we recognized the community need to produce the assessments of the key global climate change indicators every year. One of the drawbacks of the IPCC cycle, despite them being the best available science and the most rigorously reviewed climate information available, is that these reports only come along every 7 years or so. And we were hearing that the policymakers, decision makers, governments, scientists need more up-to-date climate information. So we produced the Indicators of Global Climate Change with the explicit aim of updating the IPCC physical climate assessments on an annual basis. And as I say, this is the fourth year in which we've done this. And we publish the paper in May or June every year to coincide with the UNFCCC meeting at Bonn. So I'll be there next week at the SBSTA meeting, also presenting this work. So what we see from the key indicators of global climate change since 2019, when the IPCC assessment report had its most recent year of data, is that all of the key indicators have gone in the wrong direction. So we're seeing increases in greenhouse gas concentrations, increases in greenhouse gas emissions, increases in radiative forcing, a large increase in the Earth's energy imbalance. So those, particularly those who are expert in observations and satellite data will know very well that this increase in the energy imbalance is a key concern at the moment and something that we're definitely trying to explain. We've seen from Sam and previous presentations the increase in the global mean surface temperature. We can also attribute that warming to human activities and natural factors. We can explain that pretty much 100% of the climate change that we've seen is due to anthropogenic influence. We also have indicators for heat extremes, for precipitation, for sea level rise. And this year, for the first time, we've had an indicator for marine heat waves. And this has increased significantly since the IPCC assessment report. And as Sam already showed in her presentation, this is a very sort of key area for concern for marine biodiversity and the state of the global climate. The only indicator that's come down is the remaining carbon budget to 1.5 degrees, which of course is also in the wrong direction. So we think it's important to sort of keep these numbers in the minds of policymakers, decision makers, in these global negotiations when they're making decisions that affect the lives of billions of people around the world. So just summarizing these key indicators into a single table, you can see that some of the changes are quite profound in terms of the percentage differences between the 2019 IPCC 6th assessment and the 2025 most recent value that we estimate in the indicators. And I'll talk about each of these in a little bit more detail. But as I say, one of the most kind of striking indicator is this change in the Earth's energy imbalance, and this has more than doubled in recent decades. So this is critical because it's a bit of a forecast of the climate change we might expect to see in the coming years. Due to the relationship between energy imbalance and surface temperature through radiative forcing and climate feedbacks, this could be an indicator that we may see an acceleration in the rate of warming in the coming years. So I think it's critically important to continue to monitor this energy imbalance. We see that the global warming continues to increase at a rate of 0.27 degrees per decade. That's the same number that Sam showed in her presentation. We can produce an assessment of the human-induced warming for the last decade of 1.24 degrees for 2016 to 2025 relative to 1850 to 1900. And we can also provide a single-year estimate of 1.37 degrees in 2025, which we can compare to the all-warming, all-forcing assessment of 1.39 degrees. As I say, almost all of the warming that we've seen is due to human influences. And we see that all this heat is driving changes in every component of the climate system. So sea level rise, marine heat waves, permafrost thawing, and all of the climate impacts that we are really wanting to avoid as a society. So we see from the changing global greenhouse gas emissions, we're still continuing to increase the rate of greenhouse gas input into the atmosphere in terms of CO2 equivalent. One small piece of good news is the rate of increase has slowed down. So during the 2010s, we were increasing emissions somewhere between 1% and 3% per year. Now the rate of increase is more like 0.5% per year. So we're still increasing. We haven't reached peak greenhouse gas emissions yet, but we're getting closer and closer to that moment where we can say we're starting to turn a corner on emissions. And as with all of the indicators, this is important to continue to monitor progress towards Paris Agreement goals. In terms of greenhouse gas concentrations, these have also continued to accumulate in the atmosphere. We take data from NOAA and A-Gauge, synthesizing based on the methods that was done in the 6th assessment report, and we've continued to see increases in the main greenhouse gases: carbon dioxide, methane, nitrous oxide, as well as many of the fluorinated species that individually have very large radiative impacts for their concentration. What we do see is that concentrations of Montreal Protocol gases, such as the CFCs, are slowly coming down, also demonstrating the impact of coordinated global climate policy, such as on ozone-depleting substances. We update the effective radiative forcing. This bar chart has been in existence in various forms throughout IPCC assessment cycles. We take the AR6 methodology and apply updated data, and that radiative forcing has increased by about 14% since 2019. And this has been mostly a combination of increasing greenhouse gas concentrations and a reduction in aerosol forcing. So this reduction in global air pollution has had obviously a very good impact on people's health, but a consequential negative impact on climate in the sense that it's a net contributor to radiative forcing and warming. The Earth's energy balance, this has also increased substantially, as I've mentioned before. So we take a combination of Earth observation data sets, such as from CIRES, and ocean heat content observational data sets to reconcile the Earth's energy imbalance. The global mean surface temperature, we take 4 data sets, such as we've done in the IPCC report. So ERA 5 is not one of these 4. Of course, as we move into the 7th assessment cycle, we have the opportunity to reassess the lines of evidence that we use for things such as the global mean surface temperature assessment. But of course, we see that we have this continual warming that started around about 1970. We are still not certain if there's an acceleration in this warming rate, but it's something to keep an eye on as we see these extremely warm years, particularly the developing El Nino and where this could take us over the next 2 or 3 years. The human-induced global warming has also increased. So we do this by attributing the different forces that we assess in the radiative forcing assessment, using a number of different attribution methods to determine the human contribution to this warming. So we see 1.37 degrees in 2025, relative to pre-industrial, compared to 1 degree in 2017. The remaining carbon budget has reduced to around about 3 years of current emissions. So this is the point at which we have effectively committed ourselves to exceeding 1.5 degrees. If we look at the scenario-based evidence that are produced by economists and social modelers, we do not find any scenarios that have a total emissions budget of 130 gigatons or less. So this means all of the scenarios that we use in our climate assessments are going to take us over 1.5 degrees. So that kind of socioeconomic commitment to exceeding 1.5 is already baked in to the climate projections. We look at extremes on land. So this is a sort of a mean of extreme temperatures. Again, this has increased since the IPCC assessment. The marine heat waves has increased a large amount since we started recording this data. The number of marine heat waves has more than tripled since the 1990s, and has increased substantially since the IPCC assessment of around the middle of the last decade. And precipitation, so again, coming to the discussion that we just heard on Sam's presentation, we see in the climate data records this increasing precipitation, although with lots of variability. So precipitation is much more variable than surface temperature. So we see even we have an increasing precipitation in 2025 due to the La Nina. So we have these large-scale cycles can affect these year-to-year variabilities in precipitation. Sea level rise continues to increase. We are sort of monitoring this annually as well. So we're now at about 30 centimeters above sort of 1901 in terms of global mean sea level rise. But this is not distributed evenly across the world. So some coastal regions are experiencing faster sea level rise than others. And again, this is something that really feeds into the adaptation question. The quicker we can act on mitigation and slow down the rate of climate change, the more time and less costly we have to adapt to these climate changes. We produce this information in an infographic. The paper will be published next Thursday in Earth System Science Data. And we produce several graphics such as this. We have a public-facing dashboard that will also be released next week that we're developing in coordination with C3S. And I'll move on to my last slide because I have 30 seconds left. So just to conclude, while these changes are unprecedented in terms of the whole historical and paleo record, they're not surprising based on the scientific knowledge and the physics that we've been assessing for decades now. So we've long predicted the effects of these human-caused emissions, and our results affirm how far and how fast the climate system is changing due to human activity. So thank you very much, and happy to have a discussion.
Great. Thanks a lot, Chris. Excellent talk. Very nicely building upon what Sam was already rolling out here. And then the questions to the audience. Is there anything here? Yes, there's one. I would have another one as well.
Thank you for the interesting presentation. The accelerating warming might be related also to the decreasing concentrations of anthropogenic aerosols since the 1980s. If you agree, would you like to comment upon what this may mean for the next next few decades, considering the projections?
Yeah, that's a very, very good question. So as I showed, we have this reduction in aerosol forcing that could be contributing to a potential increase in the rate of global mean surface temperature change. There's also a number of other factors that we're trying to decompose, particularly over the last few years. So potentially the role of, again, this is related to aerosols, the 2020 IMO shipping legislation that limited the amount of sulfur in shipping fuel. That's expected to have a fairly sizable impact on the change in, or the reduction in aerosol forcing. We've also had this very interesting volcanic eruption in 2022 that emitted a lot of water vapor into the stratosphere. We've had faster than expected reductions in air pollution in places like China that have contributed to this trend. So we would expect that there could be an acceleration in the warming rate due to the combined effects of continuing greenhouse gas emissions and reduction in aerosol. What we know from our scientific research is if you phase out fossil fuel use, you reduce the aerosol component, but you also reduce the greenhouse gas component. And we find that reducing fossil fuels does not lead to an increase in the rate of warming. What we're finding at the moment is not a reduction in fossil fuels, it's more of a move towards clean combustion. So you're reducing the aerosol component, but you're not reducing the greenhouse gas component. With that expectation, then we might see an increase in the rate of warming.
Yes, another question in the back.
Thank you for the fantastic presentation once again here. We are seeing a rise in greenhouse gas emissions, unfortunately, still, yeah. And yeah, we see a rise in global warming. And everybody who ever thought about system dynamics and about the climate system hopefully understands that we do have a kind of a time lag between greenhouse gas emissions and global warming. Can you give me a number? How big is that time lag between the emissions of the greenhouse gases and the global warming? How inert is the climate system? Thank you.
That's a really good question, and it's something that we don't have a precise answer for. It's one of the real benefits of using climate models for climate projections. One thing why I say that the energy imbalance is such a critical indicator is because it's a bit of a predictor about what we might expect. Because the energy imbalance is a bit like the warming in the pipeline. We might expect that imbalance is going to balance itself out in the manifestation of an increase in global mean surface temperature. There's still things we can do to bring down the energy imbalance. We can reduce greenhouse gas emissions, reduce the radiative forcing of the climate system. So the short answer is it's uncertain. The slightly longer answer I need more than a few minutes to discuss, but it's uncertain, but we are pretty sure that there is going to be this inertia caused by the energy imbalance that's in the system as we see it.
Excellent. Thanks a lot. And there will be much more time to discuss, but now we should move on. And I'm welcoming I welcome Mark McCarthy on the stage. He is from the Met Office, UK Met Office, and is a senior manager working on climate attribution. So now we are entering another chapter. The floor is yours.
Okay, thank you. Yeah, we've heard some fantastic summaries of the state of global climate and the monitoring of that. And so in the next 15 minutes, I'm going to make that a little bit more colloquial and local in terms of some of the acute impacts from our changing climate through extreme events, and introduce some of the concepts that are being developed for the operational extreme event monitoring and attribution service within Copernicus. And for time, I will inevitably skip over detail, but we do also have a poster number 34, and please do find me over the course of the next couple of days to discuss anything further. But I'll just begin by bringing things down to something quite local. So we have recently experienced a very significant heat wave affecting many parts of Western Europe. And just to make the point, these are some of the headline statistics from the UK Met Office relating to this event. So when I started my career in climate science, 35 degrees was actually quite a rare event in the UK, even in the height of summer. And now we've experienced temperatures above that threshold in the climatological spring season in May. But these headline figures also kind of can help illustrate that for any of these extreme events, there are multiple dimensions that different stakeholders or different users might be particularly interested in understanding. So for the media headline, this 35.1 in the UK is very significant. For stakeholders who are impacted by accruing costs through an extreme event, they may be more focused on the consecutive days that we were seeing temperatures above 30 degrees, and what does that mean for their accrued costs. Or the health sector, moving further down the line, they may be particularly interested in the extreme overnight temperatures that were being experienced and what implications that has. And for the first responders and the response managers, trying to understand how to best mobilize resources in events. They want to know how widespread was it, where were the concurrent extremes occurring, and where might they be having to juggle co-occurring impacts at the same time. So within any of these extremes, when we want to provide the climatological context, it is useful to bear in mind that there are these multiple dimensions, and when we're communicating that, these results will be quite contingent with how we're carving up the study. So the challenge for climate change attribution is really to insert the role of climate change into the narrative around our changing risk of extreme events and what that means for society and infrastructure in trying to manage a rapidly changing climate. So as we've heard yesterday and today, we have a wealth of data at our fingertips within climate studies, and some of this available in a very timely manner, so we can really start to pull out some of the key aspects. So these are some plots of the temperature anomalies across Europe for daily maximum temperatures over the last couple of weeks at the end of May, showing the development of the heat wave as it impacted Portugal, Spain, France, UK, and Ireland particularly. So we can draw out the sort of key features of describing how that event developed, where it developed it, and what its impacts were. The operational attribution is being able to put that climate intelligence following extreme events in a timely fashion. So while these events are high on the agendas of those that need to make relevant decisions and understand the context of extreme events in our changing climate. So the purpose of the activities in the operational attribution space is to help inform policy development, to understand risks, so it's really feeding into that understanding climate risk and managing risk, and promoting the development of new applications to support National Met Services, climate consultancies, to develop new applications and ways of providing access to this wealth of data that we have on our changing climate. And just for context, the time series on the right here is showing the 3-day averaged daily maximum temperature across the UK and France. And this event that we experienced really is exceptional. And this is also actually highlighting that we can't rely on the historical observation data sets alone, even where we have many decades of observations to really be able to characterize and understand these changing risks. So this is another example of one of these record-shattering events that has occurred. So the extreme event attribution is asking that question of how has climate change affected the likelihood or severity of extreme events. As a result, globally, there's a growing range of service providers in this space. And a diversity of how this question is framed and the methodologies that underpin the statements that are being associated with that. So within this space, for C3S, really has the potential to play an important role in providing an authoritative voice based on trusted and reliable data sets, using mature, established science foundations and drawing together multiple lines of evidence. But this sits within a wider international context. So I'm just going to briefly reference what's also happening within the context of the World Climate Research Programme around extreme event attribution, and how the C3S is going to be able to both inform that activity and be informed by it, so that collectively our global endeavour in this space can improve and develop. So I'm just going to highlight that actually 3 recent working group activities that have come up under the RIF's core programme for Regional Information Society, and also the Explaining and Predicting Earth System Change programme under one of the Lighthouse activities. There's a working group under the Global Extremes platform on event attribution, which has a particular remit to focus on developing best practice guidance in the development of operational extreme event attribution, and also to help increase capacity across the Global South and underrepresented regions of the world. So the map on the right from a review by Carbon Brief on attribution studies, showing the sort of strong bias towards the northern hemisphere mid-latitudes in terms of event attribution studies. A sister group to that is a working group on the annual assessment of weather and climate extremes, which has recently formed and is tasked with producing annual reports looking at the retrospective analysis of extreme events over the previous year. And within EPESC, a more methodologically driven effort is the Common Event Attribution and Assessment Project. So trying to coordinate this diversity of methodologies through systematic assessments of common events to try to better understand how we can utilise and communicate our capabilities in this space. So with regards to C3S, the operational service is in this space of rapidly growing international capabilities and providers. But the remit of this contract is specifically developing historical extreme event web applications to allow that interface for users to explore past historical events, an operational attribution office, and the development of counterfactual data sets. So as I mentioned, please do come and visit Poster 34 for a bit more detail about exactly how we're going to achieve these things. So one component of that will be another web application. So this is in the context of communicating and providing users with an interface for exploring, in this case particularly, Era 5 data sets through the prism of discrete identified clusters of extreme heat waves and cold waves from the past. And so this is to build that interface for users to connect to how current events fit in the context of our historical climate change. There's an operational attribution workflow which is currently being developed and tested. And I should say that while I'm representing this program here today, this is the work across ECMWF, 4 National Met Services, 2 universities, and 2 other agencies to build this sort of distributed office capability. And that is a workflow that looks at both how we're triggering and deciding which events will be analysed and assessed, how we're making the decisions within that process, how can we make that as objective as possible, and crucially, how are we informing the primary users of this service, so through National Met Services, through media, so that people are aware that a study is underway and information will become available. So we're monitoring extreme events globally to produce this sort of objective trigger for deciding which events we're going to assess and analyse. This is a snapshot from earlier this week. So we've got heat events, particularly across South Sudan and Central Africa. The Western Europe event is still showing in the past. So the remit is that we're combining multiple lines of evidence with this through combining probabilistic attribution studies, looking at classes of past events, circulation analogues, so can we condition this on particular circulation regimes and how they've changed, and in the future, storylines, so how can we provide some explicit narratives around transporting actual extreme events into warmer and cooler climates. But this also has to sit on the bedrock of our existing and established knowledge. Communication of these results is paramount, and so we're also building that sort of hierarchy of communication material and how we're liaising across the science teams, the technical teams, and the communication teams to make sure that information is useful and used. The work now spinning up for the future then is exploring some of these emerging methodologies for how we can better utilize storyline attribution methods, so making use of Destination Earth, some counterfactual reanalyses activities being led by University of Reading, and large ensemble climate model simulations. So this is about how we're building the pathway for current research and future research, how that can lead into future developments of an operational attribution workflow. So I'll just conclude there that our challenge here and our remit is providing this timely climate intelligence around extreme events for this purpose. So thank you for your attention.
Mark, so much. Thanks so much for your nice presentation and also the forward-looking into the future that perspective that you are giving at the end. Are there any questions here? Voila, directly. Rutger.
Yes, thanks, Mark. It's really nice work. A lot of what you presented is about attribution of events after they have happened. But for better preparedness, maybe you would sometimes want to map these changing risks before something happens. Is that something that's in scope or something that would be possible with your workflow as well?
Yeah, that's a great question. So within the current plans of the workflow is we using existing capabilities and tying that event definition to the observed event, so what actually happened. However, within components of the system, for example, the trigger and the monitoring, we are looking at both the sort of recent past and the forecast information so that we can inform that we're expecting an event to come and we can plan for the fact that we're going to undertake a study for a particular event. So at the moment, we're not planning to build in forecast attribution events, but certainly we would hope that the workflow that we're producing would potentially enable that capability in the future if that became a priority.
Are there further questions? You can also ask another question, probably also to the previous talks, if you have the Anka.
This is a comment that's just come to my mind on hearing this interest in having extreme events forecast at this scale, and wonder at which point do we start to tread on the authority of National Met Services to issue weather warnings on which people have to make decisions. I mean, it's related to a comment that was made earlier. People are tuning out of warnings that sound the same and that seem to be alarmist. So I think we need to be careful there, and I'm sure that Mark, working for a National Met Service, would be one of the best placed people here to take care of that. But just to be aware, you know, putting out weather warnings has serious implications for society and for government, so it needs to be done carefully.
No, I fully, wholeheartedly agree with that comment, so thank you, Anka. And as I sort of said in reply to the previous one, that would be very much a decision about what the primary users of this service want from it, as to whether that became a priority activity or not. Speaking from a UK Met Office perspective, there can be value in having climate context material available during the weather warning phase, so particularly where extremes are beyond past experience, to emphasize the point that these risks may be outside past experience of the society. But you're absolutely right that any statements in that context would have to be managed very carefully within the context of sort of weather warning services. Yeah.
Well, thanks a lot. Is there another question that otherwise than that I would like also to kind of bring the people, this is accepted, their question, of course, but I would like that the presenters of the booth are getting ready because they are going to present afterwards. Carlo, of course.
No, it's good. I mean, time is important. And I feel it's another commenting on the comment, which possibly can become part of a discussion that we can have over coffee. But the point of the connection with national med services, I think, is fundamental and is not limited to attribution. And in that sense, I just wanted to take the floor to state the obvious. These flags that you see there of ECNWF are not just a beautiful decoration, are really who we are. And the connection with national med services is important. And also for that, actually having HumanNet yesterday at the opening was really a signal, the fact that we are not in competition with national med services. We are building upon the expertise that exists in the National Med Service, and we serve first and foremost the National Med Services. So the tension that may exist actually is a tension that we feel as a community in Europe that we need to work on attribution as it is on climate projection and many other topics. But it's a strength that we have and we need to capitalize upon.
Yeah, excellent. You want, yeah. Okay, so then with that, we are moving forward to another format that we have also here in place. That we have the poster sessions. That please vote. There is a poster award tomorrow, and then within these posters, you are seeing also the booth, what we call it. It's nothing more than a table and a screen, but and then we said there's also the walk-in sessions. And I would like to please the people from the booth coming on the stage, giving a short presentation of introduction of what you can see at the booth, and there is a presentation also. Yes. Okay. I don't know.
So good morning, everyone. Well, our booth is actually more a portal to the administration department of ECNWF. So if you have any question or comment about your contract, or indeed questions about our administrative procedures and processes, or you would like to have some updates about those or any upcoming procurement or grant opportunities, you can find us there. Thank you.
Very important one.
Yeah, hello. I hope I'm not going to disappoint you because I'm not presenting a web application, but I'm actually presenting two web applications. So the first one is Weather Replay, which was developed and created by my colleague Matt Menery and published about a month ago with great success. And it allows you to replay past historical weather conditions and in a very nice, interactive, engaging way. And the second application is the Copernicus Data Store Interactive Explorer, which has not yet been published and released. So you really have the chance today to get a sneak preview of this application. And it allows you to explore in an interactive way many of the data sets that we have in the Climate Data Store or in the Copernicus data stores in general. To organize a bit, I will present we are going to look at the Weather Replay in the morning coffee break, and in the afternoon coffee break, we're looking at the second Interactive Explorer application. Looking forward to see you.
Thanks a lot. Thanks a lot, Niklas.
Hi, hi. Good morning. This is related to the Atlas, to the C3S Atlas. And the good news is that we just published a new version of the Atlas with up-to-date information for the reanalysis family, the ERA 5 and the others. And the improved design, facilitating the navigation and the selection of products. And just to mention a few new things, you can check in full detail in the booth. You can now compare side by side different data sets for the same indexes and products over around 50 different indexes. We included extreme characteristics. This is 1 in 20 years climatologies, for instance, extreme events. And also highly prominent is the provenance. So we included full provenance, in particular for the ensembles, CMIP, Cordex, with details, specific details on model components, DOIs, and so on and so forth. So the data is fully traceable, and users can understand what is behind the many products. Thank you.
Excellent.
Hello, my name is Nikos. Today I will not be presenting an application necessarily because we do have a web application, but it's mostly for internal use. I'm part of the user intelligence team. I'm more on the software side, but we have a strong team which collects the user needs and feedbacks, and we want to make sure that all of the services in the Copernicus projects are actually driven by the needs of the users. So yeah, we have a booth in my right, your left, next to the coffee corner. So please come and tell us any of the feedback you have about the services, which we then take and we disseminate using our internal application and make sure it reaches the right people in the Copernicus project. Thank you very much.
Excellent. Excellent, Nikos. We continue.
Good morning, everyone. And directly opposite user intelligence is the evaluation and quality control booth. And we would absolutely love to talk to you about that. If you have no experience with it, come and say hello. There's a session this afternoon that gives a bit more detail. But in the meantime, if you have been involved with it over the last 10 years or so, we would really love to know how EQC has helped you and likewise how it could be improved. There's obviously QR codes there to do it online. If you want to talk to us, that's fine. There's also, controversially, pens and paper, and you can actually physically write down your answers as well. Also, we're doing some usability testing here as well. We have our colleague from Obsidian, Helen, who would love to talk to you and interview about your experiences. And if you'd be interested in taking part in any future user research to do with quality, the pink barcode there. Thanks.
Thanks a lot. And then the last one.
Save the best to last. Yeah, we will have a booth for the various Jupyter notebooks that have been produced by many people in the audience. We will also be demonstrating how to log in and use our Jupyter Hub compute service. So we can get you logged in. You can run some of our notebooks. We also have some notebooks that make use of our brand new shiny ARCO data sets, and this is the data that's underpinning the applications that Nicolas will be demonstrating. So we can get you going with those. What was the last bullet point? Oh yeah, and you can run it in the Jupyter Hub. And some bonus material, I will also be answering questions about EarthKit, which is due to be released later this month as version 1.0. EarthKit is the open source software library that ECMWF have been producing for the last 2 years, and we hope to go live with version 1. Me and Beatrice will be at the stall. I think we're on the left-hand side. I look forward to seeing you there. Cool.
Excellent. Thanks a lot, San. And the booths are there. They're down by the coffee, by the posters. Take part of the poster evaluation for the award. That talk to the people and also the content that what you can see at the booths are always being waved into the presentations. We have seen that yesterday, and they will pop up, not surprisingly, today and tomorrow again. I would like to show you another slide at the end, because tonight there is going to be a networking dinner, and this is a 20-30 minute walk up to the restaurant from here. That there is the QR code for the venue, that if you would like to see that. You can also find that in the agenda, that where you can get it there, that there is written down, and there is a link embedded, so there are many ways of getting there. And with that, I would like to have a very warm applause for all the speakers here and the very, very nice and high-level discussion that we have. Thanks a lot. Coffee is being served one floor down by the coffee corner.
Making that big face.
with explosives. Yeah, yeah. Maybe we should explore the world.
you work already. Hello, everybody. Would you please like to take your seats so we can start? Ooh, spotlight. The second session of the morning today is an exciting one about tools, and we're going to start to go very much into the territory of machine learning, artificial intelligence development. We will start the session by a view into the look into the preparation stages of such methodology. We have with us Laia Romero as the first speaker. She is one of the co-founding directors of Lobelia, a company that has been working with C3S for quite a few months, years now, in trying to prepare data sets for machine learning applications. And I'm stuttering and looking around because oh, she's there. She's just sitting down quietly. Please, Laia, take the floor.
Thank you. So I'm going to speak about the features that are enabled by ZAR and by ARCO. ARCO is a new, I think we can say it's a new technology that the CDS is implementing. And, well, I will show you a little bit what this means and how it works. ARCO means analysis ready and cloud optimized. When we say analysis ready, we mean that it allows easy access and exploration, so more than access in time and space, of any given product and data set, but also all of the products and data sets at the same time. And cloud optimized means that it's in a ZAR format, a data cube, and that it uses a stack metadata that lives in a cloud, so cloud optimized. We use two optimization. One is for the spatial analysis, what Hans said yesterday, lasagna. We also call it lasagna. And the other one is the temporal analysis, the spaghetti that we say. This dual chunking allows for the best performance in the data exploration. These data cubes are where all the data from the CDS, now not all the data, we have a few, well, I will show you then the full list, but many data sets, ERA5, ECVs, many data sets already in this format and counting and growing, and they both are optimized in these two ways. This works for dense data like ERA5 and also for sparse data like water lakes, for instance. And the fact that the chunks are so small means that a user can access a time series over an entire period that can be 80 years in 5 to 10 chunks, and this is 1 second. So you get a time series for a full period on one location and surrounding locations on 1 second. And all of the other data is not used. Unnecessary data is not used. This means that efficiently wise, this is very smart. Environmentally wise, very smart. This is the ARCO system. We have the data providers, the ARCO data metadata producer. This is the ingestion, so the ARCO intelligence is here. The data lake, where those data cubes live, and then the access for the users. And I want to stop here. There is a serverless or almost data access. Serverless means no server. It's a very thin layer. There's no APIs. The user accesses the data directly. And when we say almost, it's because there's the personal access token layer on top. So the same personal access token that a user checks in when accessing through the CDS that is associated to login credentials is used by ARCO. So ARCO is checking all the tokens of the users that are requesting data and is also preventing abuse at the same time. So a full monitoring takes place. And then there's another server full access, which is for WMTS, that is for QGIS or other applications that need another type of access, okay? one example, ERA5 hourly. This is serverless. So a viewer can access the data and render the maps on the viewer side. And the data is accessed directly in Arco. This video is not accelerated. The data is not cached. This is real time. You can see here the seasonal, Anka. The seasonal trends. You can zoom in the data. You can actually do many things in real time, and this is accessing Arco continuously. You can pin in different places, and this is accessing Arco and showing you the results. And this is only the wanted data that you are accessing. Another example, we implemented an agent very close to the viewer. And this AI agent is asking Arco different things. So a user can say, what is the warmest place on Earth? What happened when, I don't know, in this particular point in time? So in this case, we showed we told the agent how to interact with the viewer in terms of you can put pins in the viewer and get results, and the agent alone is deriving the full analysis. And how good this is, we will know, but this was done very, very quickly. So Arco is optimal for agentic AI. And the temporal exploration, which is extremely difficult, is enabled by this technology. Another one, notebooks or programmatic access. This programmatic access is accessing ERA5, ERA5 Land, and Cortex at the same time, and in a very fast way. All of these three, as you all know, are very different data sets that are fully interoperable with this technology. And this is my favorite. This is the performance right now, today. So this is what it takes to access one chunk of data, 136 milliseconds, and the availability of the infrastructure. The infrastructure is ECMWF-owned cloud, which is in Bologna, Italy, sovereign cloud in Europe, made by Europeans, run by Europeans, environmentally very efficient. This performance is better than any performance of access to ERA5 by Google, by anybody. And it's free, and it's made in Europe. I don't know how to say it more clear. We need to communicate openly. Okay, thank you. This is monitored continuously also, and so we can keep track of what users do. We can prevent abuse, as I said. We can be more efficient. So this is. Another example is Wikio. This would be a server full access. So Wikio, it could be QGIS or something else. Like imagine a viewer that is not able to render maps. For Wikio, Wikio will be able to render maps directly from Arco very soon. But in this case, it's the WMTS. So it accesses the WMTS, and you see the same. It's another way. So users that work with different programs can still access Arco. All of these data sets are in operational state right now. If you go to the CDS, Eddie explained it earlier, but I think Angel, Joaquin, different people at ECMWF are allowing more and more analysis-ready access, and you will see a tab directly in the CDS that says Analysis Ready. There you will access Arco directly. All of this is there, and coming up, more ECVs, the data for the Atlas, CARRET2, and more. We're talking every day about more data sets. Last but not least, the operational data and the ingestion. When I said the Arco intelligence, we have multiple sources. The fact that we do sparse and also dense, gridded, entails some complexity that it is solved and that the ingesters are dealing with every hour. The updates are done daily in this case, but could be done every minute. When there is a big update for a data set, that means a multi-year, we will update the last 3 years. This is done immediately. The latency from the time the new data is available for such an update and the data set to be updated is 3 hours. So from the moment that these 3 years of data are available, you will get the data set updated. And then the delta updates are done immediately, so with every acquisition. The reprocessing workflow, as I said, reprocessing means we are putting everything on a homogeneous format. In this case, is long-lat. It can be original grids. In this case, it's long-lat, and it shows very good interoperability, but this is a design choice, not a technology limitation. And also these continuous updates. And finally, inside the factory, this is what you see inside the ARCO factory. So the full monitoring of everything that is happening, from the providers to the users, to the transformations, the types of access. And these are all applications enabled by ARCO. We just learned about a new one, the Interactive Atlas, that, not Atlas, the Interactive Explorer that James is working on, that is in one of the booths. The weather replay, the time series in the CDS, that was one of the first ones. The Era 5 Explorer, and many more. So ARCO is a technology that enables agentic AI, that enables visualization, that also enables processing of data sets, you name it, and I hope you will all use it. Thank you so much.
If you don't mind staying there for a moment, because I hope, I think there might be questions, and I hope there are. Yes, please. We start here.
Thank you. This is super impressive and almost like magic to me. Being a data producer of Cara 2, I know what it takes to have petabyte scale data storage issues and struggling with Mars tape archives. How do you do it? And not least, because you say that you store you slice it 2 different ways. Does that mean that you duplicate it because you have to store the same thing twice? Yeah. And how do we solve this for Cara 2 in the pipeline process?
It is duplicated. And as I said, this is also a design choice because we could imagine only duplicating certain variables or applying like some intelligent logic to the efficient use of resources, keeping the performance. But we've already worked with petabyte worth data sets, and it works very well. So yeah, we started doing this at Lobelia because we wanted to make viewers that were very impressive. And for that, we needed a backend that could serve these viewers. And then in the end, we started from the web perspective and requirements, and then we developed the technology behind. So. And also, I'm a physical oceanographer, and I understand your point of view perfectly. So
I think I'm going to go to Carlo next. Maybe he wants to react to this. And then...
well, if you want to impress us, you did impress us. It was really amazing. Thank you, Laia.
You tell me so.
Yeah, very well done. I guess it's so addictive as a technology that we are picking up and displaying so much of the data through ARCO, to a point that now there is a proliferation of ARCO. Yeah. So from your point of view, how should we deal with ARCO in the long run, and how should we change the catalog, as well as the EQC function that we heard about yesterday? Because in a sense, this is altering access to the data, it's altering representation of the data. Mm-hmm. So how do you see this from your perspective?
The way I see it is that the same way we worked many years ago, I've been working for some years now, with CDS, with NetCDF, with conventions, with standards, like the same work we did many years ago, even GRIB, NetCDF, now it's ARCO. ARCO allows this performance and is more efficient. So we will be I think we should be adapting the change to this technology. And Lobelia should not be the only one doing this. This is a technology. We have the certain intelligence because we started early on and we know the field of, we have this field of expertise. But ARCO comes from, I think, cardiology and, medical devices. So it's just one more step.
I think you still have your questions. So.
Thank you very much and congratulations. Absolutely jaw-dropping for me. We have been working with huge chunks of data when trying to establish operational procedures for post-processing seasonal and projections data, and for me this is an absolute game changer. Two questions. You said that the spatial selection was by latitude longitude, and this applies to any type of grid, but for example for Terra has been a challenge because you couldn't properly select. So I imagine that there will be some on the pipeline, some tutorials, examples, trainings to try to get the most out of it, so we can prepare our workflows or adapt our workflows to work with this.
Yes, right now the way it works is that we receive the request of start converting Sarah into Arco, and then we take these demands. But I think this, as you say, it is a new logic for managing the data, and slowly there will be capacity building and documentation so that everybody can use it. At Lobelia, we use it internally also for our own viewers that do not rely on the CDS, for instance. It would apply the same. Yeah.
Okay, thank you. We will be really looking forward to
right
it.
Now,
Thanks.
if you work in the C3S and you're working with data and you think this would be useful, ask officers, can we have it in Arco so that we will get this demand?
Okay, perfect. Thanks.
We will take one more question because Laia has allowed for the time. So the question was there, wherever the microphone is. Thank you.
Thank you so much. Yeah, thanks. I was wondering, is this a strategy for ECMWF that this will be authoritative data distribution formats in Arco, or is it still more like an optimization for specific applications and maybe for the high-value data sets or something?
This is not me to answer, but from what it takes from my side, Arco is based on ZAR. ZAR is an open standard, and many of the current geospatial data operational applications, including satellites, are moving to ZAR. And then on Arco, I let Carlo to respond.
Well, the two things are not necessarily incompatible, right? So we are reactive to a technology that is happening now because it makes the life of our user better. But given that it's so transformative, as we have seen, then it makes sense to have a long-term plan on how to deal with that, and we are working on that long-term plan. So it's indeed a bit of both. First of all, reacting to a technology we haven't had to start with, but also implementing in a more programmatic way.
So when we started, we were following OGC standards and what was happening, and when ZAR and STAC became open standards, it was like, yes, because this means the way to the authoritative access is here, and so it's possible.
But I do believe that the definitive archived, curated, long-term held data copy is not this. There will always be the usual. But Eddie can probably tell us a bit more, and we need to wrap it up very quickly.
Hello, yeah, so there are activities to unify the kind of core ECMWF Mars data. So if you get data from the Destiny project, that's using Polytope. In the back end, that's using something called GribJump. That's now being used in something they're calling ZFDB. So that's ZAR FDB, so it's a ZAR interface on top of FDB. It's very similar to what you see with Arco, but it's using the on-disk version of Grib data. We don't have the unified metadata access. Handling the metadata is still a problem, but our core distribution of ERA 6 and ERA 5 on FTP is moving in a similar direction.
Thank you. I'm sure we can continue this conversation afterwards in a coffee break. Now we want to move on to Eivind Stoiland from Norway. Thank you for helping me with this. Eivind works in NWP on development and production of operational systems, but in the context of C3S, he coordinates the work on regional reanalysis updates close to real time.
Thank you so much, and thank you for having me here. Fellow physical oceanographer by training, glad to be able to present inside a whale. So yes, for those of you who were here yesterday. But I will try to speak quickly because I think the previous presentation was more interesting to all of you, but still. We have talked about regional reanalysis yesterday, and now on behalf of myself and our team, and help from people involved in both Kara and Sera and machine learning, we'll talk about timely updates based on machine learning. So, as we talked about yesterday in Harald's presentation, regional reanalysis has been going on for several years. I've been involved in production of both Kara 1 and Kara 2. So you can see here there's different domains. You have the Sera domain on 5.5 kilometer. It seems that a lot of you are familiar with it from the posters downstairs. I see a lot of applications, which is great. I hope some of you also will take interest in the Arctic regional reanalysis, but maybe you are waiting for the second generation one. So yes, as I said, the various products here, and we have in the Copernicus phase 2, there's been extensions of these. The Sera one was extending back in time, and also both Sera and Kara extending forward in time so that you can have near real time appending on the data sets. Because as we learned yesterday, you need access to information rapidly and preferably before 5 days. I'm not quite sure we can get before 5 days, but we'll do our best. So, but what we do is 3 months delay in the current near real-time scope. And well, 3 months is better than nothing, but of course we want to have it better. And this has been a case for the negotiations also. Can't you deliver this quicker? What can we do? And but why is it so much delayed? We're talking about physical models. We are talking about a lot of extra local observations, as Harald talked about yesterday. This takes time from each national institute. They need to collect observations, quality assure them, and give them to us. And sometimes there is some satellite channel have some issue. You need to do some blacklisting. We need to do reruns. And also, the model itself has a throughput of 4 to 7 days per day. So there's a physical limitation on how fast it can be produced. And we deliver with monthly batches, meaning that the first and last day of months comes at the same time. So altogether, this means that there will be a 3 months delay, unfortunately. But can we do it better than this? And this is what the ECMWF or Copernicus thought that, well, there should be a way. And it's in this day and age of machine learning, we see rapid progress in a lot of places with the AIFS from ECMWF, in Norway with the BREEZE model that we're actively developing in collaboration with ECMWF and others. So there was this invitation to tender where the goal was to have quick, timely updates for the regional reanalysis. And how to do it? Well, to use machine learning. So we decided, well, we need to try and tackle this challenge. So we went alongside our colleagues in Meteo France and Danish Meteorological Institute. So we have been collaborating with these guys in the physical reanalysis also. We know each other well, both in physical and machine learning activities. So this was a nice opportunity for us to try to tackle this. So how to do it? Well, in physical production, what you do is you take the boundaries from the global reanalysis, the ERA 5, and you add in the data simulation local observations, and then provide a physically based regional reanalysis. We want to do something similar, but not include the observations because you don't have time. So you take the ERA 5, or rather the preliminary version, the so-called ERA 5T, which is available quite soon. The proper ERA 5 is available later. But we need to take the ERA 5T and then assume that we don't need observations and use machine learning magic to provide something in short time span. And in theory and technologically, we should be able to go from 3 months delay to if we do updates every day, to have just some days delay or a week maybe. So the possibility is there. So now I'm not a machine learning person by training myself, so excuse my language, but I will try my best. I have colleagues who have been doing the actual training, but there are various ways that you can tackle this with how to do it, but we are running a diffusion model with a graph transformer backbone, so this is similar to what you do in image training. So you add diffusion with a forward noising process, and then another algorithm to try to understand the most significant features to get what you need. You develop this using the Anemoy environment from ECNWF, and also in close collaboration with people at ECNWF. So quickly about the training. So we use, when you train, we use ERA5 as input, alongside the static parameters from Caracera, because of course you want to be able to use the land sea mask and the orography. We would also like to have other static parameters, but yes, those details, so you can come and talk to me later if you want. But, and of course the Caracera physical model as the target. We train for 30 years and then have a test period later, because of course you cannot test on the data that you have been using as part of training. And the nice thing with machine learning is, of course, that, well, it's still computationally. You need a lot of resources, but you don't need them in real time. You can do it beforehand. So you do the training. So we've done this on Lumi using 128 GPUs. And there's a scope, so you need to, really for each parameter, you need to try to do your best. And we have a max in our system for 16 parameters, but the requirement is at least to have 2 meter temperature and total precipitation. But outside of those, we, as best efforts, so we try to include as much as we can. Now to just show you some preliminary results, and unfortunately I also will show you figures of temperature, which you have seen many times here already. But yeah, so this is just an example just to show you that, well, it is possible and it's not perfect. These are preliminary results because the final training has not been completed yet. But what you see on the left here, a day in Scandinavia in 2022, cold day. The Serra on the left shows you some regional features. On the right, you see the ERA5 with a lower resolution. You expect less local details and also less absolute minimum temperatures. And in the middle is the suggestion by the machine learning model, which, if you look at it, you can see that there are some similarities to the Serra. It doesn't manage to replicate it perfectly, but at least you can have some local features. But then we need to see, well, what other things can we do? So first I can show you an example for another parameter, the 10-meter wind speed. It's a bit hand-wavy for me right now. I will show you some more verification-like things later, but here for wind speed, you can see on the left from Serra some nice details. ERA5 on the right, lower details. And the machine learning in the middle, it has similar amounts of details, so to speak, as the Serra. But, well, is it good or not? Well, one thing that we need to consider when evaluating the quality is to have the relation between the parameters. So when you take the correlation between temperature and wind, if you look on the left, this is the case for Serra for the month of January, meaning that it shows you in which regions the temperature and wind are correlated. In this case, in northern Norway, when you can have low temperatures and low wind speeds, high correlation, you show it here. You see similar over Greenland, you see something also in Northern Africa. Well, the machine learning output shows you similar signals at the same place. So this is one indication that the relation between parameters is, in this case, a good one. But we need some more objective criteria, and this is, again, work in progress, but we try to define some metrics that you can use. So these are the 5 here. You can read them yourself. I will go through some of them. First is maybe the easiest to understand, so the systematic error, so the bias. So what you see on the left is the bias of machine learning compared to the physical Serra. And on the right is in the middle is the same for ERA5. So what you see is that machine learning in terms of bias is quite close to Sera. So in the colors, so blue means that it's near zero, and more red or green means that there's larger than zero, basically. On the right, you see a graph, of course, but the blue line is the bias compared to ERA 5. The red line, so x-axis, is the same as the blue line. That's why it's a diagonal. And this means that if the red line is lower than the blue one, that means that machine learning is doing better. And the further you go to the right, the larger are the values in the bias. So what this graph shows is that if the biases are small, we are not doing very much better. So machine learning and ERA 5 model have similar quality of bias when the magnitude of bias is small. But when it's large, we get improvements. So this is just an indication that we are doing good things in terms of bias. And now quickly I will go through the other ones. So another one is the standard deviation of, the standard deviation of the error. So this is the chaotic or random error. You see similar features, but here you need to go further to the right before we are better. So the lower values we are similar to ERA 5. An important part when evaluating machine learning is in the activity. It's easy for algorithm to smooth things out, to remove sharp fronts, to be able to predict extremes, etc. Activity is an important measure in this regard. So, and I will not go into definition, but just to show you that we are considering the activity and we have decent scores, especially when the difference is large. And tackling extremes, again, some of these metrics are going in the same direction or are related to each other, but still it's important to highlight them. So extreme case here for 2-meter temperature for a low, so the low tail, so the cold tails. So what we show here is that we are better at predicting the low temperatures. And finally, fine scale features. So here you can look at the energy at different local scales. So some of you are familiar with this type of plot. If not, well, look at the black curve. That's ERA 5. The further to the right you go, the higher resolution features you have. So ERA 5, it stops because it has coarse resolution, but the Sera, it runs much further to the right, and you keep energies at the lower scales. And you see these other lines have different versions of the machine learning model is able to keep energy at high scales. So I will jump over this one, but you have this climate pulse and you can see, but I will skip it in terms of time. So finally, what's the next steps for us? Well, the final training is ongoing right now, so stay tuned for that. Which parameters to include? I showed you temperature. The total precipitation figures are not as nice, but they are better. I got a message today that things are getting there, so that's good. We plan to start production in autumn 2026, and we will publish on the Copernicus Datastar when time is right. This is supposed to be handed over to ECMWF and be part of their portfolio, but we will need to see proper good results first. And we have also ensemble members for uncertainty. And I didn't say, but of course, it would be better to have an autoregressive algorithm so that you can prevent skips when you go from time step to time step, because that's one of the challenges with the method that we do. But yeah, it's an exciting time to be learning about machine learning, and thank you.
We have time for a question or two. I will start with Hans.
Hello, my name is Hans Hesbach, ECMWF. So it's really amazing work. So my question is, a lot of users, they're interested in anomalies, you know, that's why you have the last 3 months and they relate it to what happened in the last 30 years, whether it's extreme or not. So now you have this machine learning based last 3 months compared to a physics based 30 years. Are there systematic differences between the two small enough in order to have confidence in your anomalies, or maybe would you need also to have generated 30-year climatology with the machine learning model to be consistent?
Thank you. So, of course, the challenge here is that we use the 30 years to train. So, but we will we do have statistics. I don't have them myself, but we do produce. What we will do as part of the final evaluation is to consider the first 5 years and the last 5 years, and to provide data for those, including the uncertainties in terms of ensembles, and to try to see if we can capture the signals or the difference between 30 years ago and today. But again, it's challenging because you need to reuse the data that you already used for training.
Any more urgent questions?
Thank you, really impressive. You said that it's being developed in close collaboration with NMOI branch framework, and we are really looking forward to the downscaling branch from NMOI. In other meetings I've been, there was discussion about how these models may improve if you add additional data sets for fine-tuning. There are another reanalysis data sets being developed over parts of the third domain. I don't know if for a next step, once everything is operational, is something that is being considered as a possibility to include higher resolution reanalysis, for example, like the one is shown in the poster by Meteo France, yes. Or is something that is on the roadmap somehow? Or?
So in terms of roadmap, I invite Copernicus and ECMWF to give us opportunities to work more on this. Then we'll be glad to tackle the challenge, both including the French kilometer scale reanalysis and other data sources, and also the autoregressive algorithm, of course. But we will see. Thank you.
Thank you very much. I think we need to move on. Next speaker is Jon Christiansen. The director of the Development Center for Weather Forecasting at Met Norway, with great experience in research and operations in weather forecasting, climate services, and polar prediction areas.
Yes, here we go. Thank you very much. I'm not quite sure why I was invited to give this presentation. But I think it's, it's not very many answers here. I'm not a super expert either. But for those of you who were in Valencia last year and paid attention when Carlo was speaking, I think this is a bit of continuation with the discussion you started, speculating about the next phases of reanalysis in this time of data-driven modeling and direct observation prediction. So take this more as like a scoping the landscape, and if you're provoked or think that this doesn't make sense, it probably doesn't. But I think this, to follow up what Carlos said last time, this is going to be a continued discussion. But first we go back in time. I always like this, not because William Berknes was Norwegian and he saw the problem of weather forecasting more than 100 years ago. It's a picture from him when he was young and in Stockholm. But this has been the foundation for us for a long time. Combining observations with numerical equations from the laws of physics and mechanics. And William Berknes was inspired by a number of things you see from medical science. So he used the terms diagnosis and prognosis. At that time, they didn't know so much about the chaotic system, but still he meant that the weather forecast that he developed or had the idea for could, with reasonable accuracy, give a comprehensive prediction and description of the Earth system for actually quite a long time into the future. In the beginning, this is not supposed to be a historical lecture, but in the beginning, they had very much emphasis on observations. So this resonates with analysis, right, with Copernicus. A lot of emphasis observations. The thinking was that if we can observe the Earth system more or less completely, then we can forecast the weather more or less forever. Of course, Ed Lawrence proved that wasn't really the case. But observations was at the heart what they were doing in the Bergen School. So they very much defined modern weather forecasting. So the Bergen School from 1917 to 1940 had a lot of emphasis, as I said, on observations. And we talk about this physical-based this and physical-based not, and statistical and so on. I don't think we should sort of end up in these silos. I use this because I think it makes sense to think of understanding of physics that more than just writing Fortran equations. So this illustrates what they did there. This concept of fronts, in 1917, inspired by the end of the First World War. This conceptual understanding of the physical system, I think that is what we should put our emphasis on. A number of great discoveries in the past have been not because of equations, but because of the understanding of the physical system. So let's keep that. But establishing an observer network and challenging complementing the observations with the concept of these fronts really brought all this forward. So I would say that this way of working is modern, was modern then, but even also today. This research operations, value cycle, science for services, very much what Copernicus is about. So move on to the next slide, but the last point is that William Bjerknes, he put his son, Jakob Bjerknes, which is also a very good scientist, as head of the forecasting office in Bergen. And William would often come up to the forecasting office in the evenings and ask, are there any new discoveries today? So let's take this with us and not dwell too much about what is physical or not. This you know very much from before, that reanalysis is very much one of these, perhaps the most used geophysical data sets. This slide is before machine learning, I used before. But I think this fills in areas and physical quantities where they're not directly observed. It's also where machine learning can play a role. I know that's been used in the analysis and the method with data simulation, but it can be improved further. Like a sort of side note on machine learning is that I predict, and I think we've seen already, that machine learning is also driving growing use by non-traditional users of reanalysis and other Copernicus data. This has a huge opportunity in that it will create more feedback. Some of this feedback might be hidden in agent and LLMs and so on, but we can find methods to receive that feedback and also generate even new innovation. So Carlo will have a lot to do also in the future years. This is super important. We would have been nowhere where we are today in terms of machine learning, weather forecasting without reanalysis. This has been one of the most important components. I think these numbers you saw yesterday, was it 10 billion? So it's greatly underestimated. It's much, much more. I mean, we are global. It's much more value of reanalysis. So the examples of machine learning models, one is called Breeze. It's Norwegian for light wind. It's like a breeze. So what we do and others have done is to train the model in stages. So the first stage is using, for us, ERA5. In this example, 500,000 grid points. And then we fine-tune on diagnosis or analysis, as we call it now. We have used some 5 years of MEPS or IFS, quadrupling the number of grid points. We have not masked out the area of the Nordics. It's just much more grid points because we're taking this stretch grid approach where we go for focusing, where we have a global to regional forecasting system in one to have more, say, fluid information across the boundaries. Cara 2, Eivind mentioned that nicely. We're downloading that, so it's a shitload of data. So we have cheated the system, but we are downloading data and we'll use that in the next fine-tuning. So that will be decades of data and we anticipate even further improvements. Our aim, I'm not saying that machine learning will replace everything that we do today, but it's nice to have some aims. And we aim to use our Breeze model for the public forecasting of YR. Great app, by the way. Government agency, private sector, and so on. For this, there's a few requirements. Probabilistic forecasts. We run Breeze 8 times a day with 16 ensemble members in 20 minutes. It's not bad. High spatial resolution is important. Temporal resolution. Working on that. I think we solved it to some degree. Broad set of forecast variables. We're not close to the amount of forecast variables that's available for the current operational models. And we are quite ambitious. We would like to continue to have the 21-day forecast in one go with one forecast model. Now, don't have time for this. It's quite a complicated adventure to produce 21-day forecast. But if in the Nordics, look at the 21-day forecast, it's really good. And another thing that we are interested in the Arctic, forecast risk model stabilities in addition to the Nordics. And by having this graph structure, we can actually combine two different models or domains into one. I'm not saying this is the final shape. I just like the shape. It's a bit odd because we are used to thinking in squares. But now with the data models, we can also challenge that approach. Anemoy, not going to go into the details, but Anemoy is basically our platform, and it's shared. If you look at this map, there's at least 3 different model consortia included, and we're now working together in one common framework. Europe was mentioned in the first presentation. This is also something we really need to emphasize in Europe, working together in one common framework. We share the code, are in individual national models, but we all work together in Anemoy. And a great thank you to ISNWF for investing and sharing this with us. And a key component, also co-leading, there is the ISNWF machine learning pilot project. Also said that, mentioned there that we're also working on subscale model systems, but for something else. Interest of time, I'll do this quickly. The first point on this slide is that when we do NWP, machine learning-based weather forecast today, we start with an analysis which is based on NWP, just to be clear. But there are potentials to complement these initial conditions with observations. Like in C2, you see a map of NetAtmo. We tested it, works. Radars, we could use radar precipitation from the onset. There's satellite information that might not be assimilated directly, like cloud cover. These can be combined in initial conditions and using this multi-encoder, and we can represent this in latent space and hope they talk together during the inference. It sort of works, but it's not 100% perfect yet. This also means that we can introduce different resolutions into the initial conditions and get different resolutions depending on the field in the output. But also introduce new output fields like wind gust, some aviation parameters. We did lightning, precipitation phases also on the way. So there's some opportunities there to get even more out of the nice observations that we have. So basically, environmental prediction is changing rapidly. There's increasing volume, but also it's increasing from an already high amount of Earth data. Just showed an example there from NetAtmo. We've been using this operationally for weather forecasts, I think it's 10 years now. It's more than quadrupled, I think, in amount of data. So as you can see, the density is very high, and there's other examples as well. The data-driven modeling are reaching operational skill. Here is an example for Norway, 1 year. Sorry, it's the two-day forecast. The x-axis has lost its numbers there. Lower, the better. Let's see, black is our operational weather forecasting system, MEPS. In blue is the IFS ensemble, and in green is our breeze ensemble. So we're quite happy that we're better than the operational system and also with IFS. But the devil's in the details. That doesn't mean that we are outperforming for every grid point in Norway. So there are some surprises when we start comparing in details. And then on DOP, so this is emerging very quickly. So basically, it's not super difficult to explain, but basically you take a lot of different, it's sort of a data assimilation function that takes a lot of different observations, integrate them into latent space and make a prediction. And then sort of the output is using some of observation operators to map these observations into map the latent space into observations again. It's better explained by this. So you can put satellites, upper air, surface, for instance, have an encoder, processor, and then decode. What you can see in the pictures here with the satellites, you see on the left, where you have observations, there are some gaps. But you can use this DOP to fill in the gaps. So it's perhaps more visible with upper air, where there's some parts of the world, there's not that much. But based on this DOP concept, you can also fill in these areas. And thanks for Tony for the slide. I'm not sure he knows about it because I got it from Matt. But thank you anyway, Tony. Another examples, we go higher up in the atmosphere, where it's the Evers-Sperser observation network or WINDS. You can basically get a global coverage using this DOP framework. So the first on the left is observations, on the right is prediction on the grid. So can we use this for further reanalysis? So this is a question, and there's a project called Sherry that is led by Pete Weston at ECNWF that is starting this autumn. So this is a Horizon project. This is building the next generation of ERA. And one of the work packages, it's actually two, but that's a detail, is working on DOP. So some of the things that needs to be answered is the exploitation of much larger observational streams, how to handle this flexible integration of heterogeneous observations. Learning is an important part, complex relationships directly from observations, a lot to be done there. Perhaps there's no need for observation operators anymore. Many will be glad for that, some won't. And it's a potential to be many orders faster and cheaper. But there also, we think, increased need for data curation, metadata, nicely presented in the first presentation, pre-processing, monitoring, and also compression and accessibility. I think the current NWP system uses like 5% of the observations, reanalysis probably more, but if you go to the full 100%, it's a lot of data. I heard about that yesterday. Yeah, there's also, I would argue, a role for regional systems in this to bridge the global and the local. This nice slide is just an example where we also introduced information about the physiography, the land surface, into the training. If you look very carefully, you see some big blue spots over the big cities, because if you don't give the machine learning information about where the big cities are, it doesn't really recognize them. And according to machine learning, Oslo is not a big city, so Copenhagen and Stockholm are still bigger than us. So just in time, these are some of the questions that we'll probably discuss a bit further in the panel afterwards, if we have time. But there are some questions how clean the observations should be. Should we clean them a lot? Could we use raw data? Physical consistency, should it be enforced? And if yes, how? The third one, I think, is super important. It's a really scientific challenge. If you can use AI DOP to produce stable and also trustworthy long-term climate analysis. And also how robust the systems are for extremes. I showed some nice examples where you fill in the gaps, but we need to test if you do it properly, both in terms of variables and regions. So yeah, I'll stop there, otherwise Anka will kick me out. Thank you.
If there is any quick question about methodology or clarification of the slides, please go ahead. But if not, we will continue the discussion on this last slide's worth of questions and more after the following presentation. Okay, the following presentation then, we are going now to the world of... We go now to the world of climate projections, and we have with us Jose Manuel Gutierrez, one of the co-chairs of Codex Scientific Advisory Team, leads a project contract for C3S in creating machine learning climate projection information, and is one of IPCC's coordinating lead authors in a past assessment report who put together the climate atlas that you've heard so much said about in this event. Jose Manuel.
Yeah, thank you, Anka. Yeah, thank you very much. So the aim, the main goal of this contract, of this work, is to establish a systematic approach to use machine learning emulators. I will define what is that. In the context of regional climate projections. So it's a different context. It's not the reanalysis context that was described before. It's a bit more challenging in a number of dimensions that I will try to highlight in the presentation. But the thing is try to apply that new approach in the framework of Cortex CMIP6 is the new cycle of regional climate projections coming out from the Cortex initiative. Cortex stands for Coordinated Regional Downscaling Experiment, and is the sister project initiative of CMIP, the global projections. So we drive our models by CMIP output and produce more regional results. So the consortium is formed by 8 partners, and half of us are providing the projections for Cortex are using physical-based models, the RCMs, to do the job. So the idea is that we are also we are developing the physics phase and on the top the machine learning new methodologies. So what is the motivation? So Cortex is a well-established data set for regional climate change projections. In particular, in the CDS, there is a catalog with the information coming from Cortex CMI 5, the latest available set of ensemble of regional projections. And from there, you can get a global vision of this Cortex core is called, where the projections in different domains are put together in a kind of global mosaic where you can see regional climate change projections globally. So now Cortex CMIP 6 is ongoing, so it will be ready by the end of this year, going to a 11 kilometer resolution globally in the Cortex core. And this is particularly the framework in which we want to use emulators, that temporal scale, that the spatial scale, and the full ensemble. So what is the problem? That producing the simulations for all the domains, what you see on the left are the domains where the regional climate models run, the physics-based models. So those in columns are coupled with different GCMs, the driving GCMs in rows, and at the end we have a matrix that we need to fill in order to sample uncertainty coming from the regional, the global models, also the scenarios for all the regions. So the problem is that the matrix is very sparse, so we don't properly sample, fully sample uncertainty. So the idea is to use emulators to fill the gaps. So train the emulators with the green existing information, and then fill the gaps. Use them to project across GCMs, scenarios, and possibly regions. The problem is that we need one emulator per RCM, in principle, and domain, and that means around 30 different emulators. So we need to develop some affordable solution which can be trained massively. So we cannot spend 128 GPUs to do the training 30 times for all those regions. So we need a cheaper approach. So, and then what is an emulator? So we are not using the emulators in the sense that many of you may know. These autoregressive models that predict one step ahead in time from the current conditions. So GCM emulators or LAM, limited area models, or RCM emulators, where you can roll out the predictions to have time series evolving dynamics. So this is well established in the weather context, but is open research in progress for climate. So this is not well established yet for climate applications. So alternatives. So we can use different emulators. So the static emulators. So here what we have is the 3D, the full conditions coming from the GCM or from the coupled RCM, the blue in the top and middle. And the ground truth for us is the RCM output corresponding to those driving at surface. So temperature, precipitation, all the standard variables are our ground truths, and we need to, we want to predict them, to emulate what the RCM does, using as predictor the 3D global or regional input data. So this is the basis for the emulators that we are using. And there is some literature that we produce, the team, the consortium, on that line, so the precursor of the activity that we are undertaking. So once we have the emulator trained, the idea is that we can apply to new GCM data to produce the emulated RCM output. And that's the idea. The idea is that we need to transfer from the model learned with RCM or GCM, RCM would be perfect, or GCM imperfect predictor, to apply it with GCM imperfect predictor in the future. So for that, we develop a work plan, and the core, the central part is working the 2 and 3 work packages, where the emulators will be developed, starting from the models already developed by the consortium. So there are different models, so we are not using a single approach. We are including convolutional, traditional, deterministic, and stochastic models. We are also using graph neural networks, like anemoi. It's not anemoi, but it's the same approach. Diffusion models as the standard or the popular one, but the idea is that in the contract we will do some further development along the spatiotemporal structure, extremes, and intervariable links that we need to provide to develop methods that can provide actionable information, actionable at least to be tested. So the validation framework is a central part, and this is done in coordination with the Cortex. In Cortex, there is a task force, task team now on machine learning, and we are fully aligned with that. Actually, our contract support some of the activities that are being done there. So what we develop will be aligned with the standards that are done in Cortex. So we are contributing together with other institutions, not in this contract or neither in Europe, but in general worldwide, to this kind of endeavor. So this is the first results. So in Cortex, we set up the first benchmark across different domains. So there's a domain in Europe in the Alps, there's a domain in South Africa, and one domain in New Zealand, for which we provide the same set of predictors and predictants that the community can use to train models and to test the models in the same, exactly the same experimental framework with the validation tools that are provided in the link below, that include a number of categories for extremes, temporal coherence, multivariate coherence, also the climate change signal, because it's important for us, and this is work in progress, and it's evolving, now branching in the current contract, where we will extend all that according to the particular interest of this particular contract. So the idea is that we test not only cross-validation, which is the standard, so you train and test in the historical period and test in a particular validation period that you have not used for training, but we also test transferability. That means using data in the future, data for which you haven't, data that you haven't used to train your models, data coming from a different GCM, and so on and so forth. So this is what is, in general, described as transferability. Soft, if you are within the same GCM conditions, or hard, if you jump across GCMs. So that is critical in order to fill the matrix. So you can train with one model, one particular cell, and then apply across rows, across GCMs, in that particular case, or scenarios. So those are some results for, so the one particular important thing is that the training is done with data in the historical and future period. This is what makes this emulator different from standard downscaling, observation-based downscaling approaches, where you don't have the future, you only have the historical, so you need to extrapolate. So just to give you a few images, a few results, preliminary results, this is a typical cross-validation in a test period in the present. For Europe, so on the top you have the ground truth. This is a particular day with intense precipitation over 80 millimeters for this particular day in some regions in the Alps. And what you have in the 6 panels are different flavors, versions of 3 models out of the sample of models that we are using for the contract, including deep convolutional networks, the first 2, with and without orography, flow matching, which is a expansion or generalization of the idea of diffusion, and also a diffusion method, which is the latest one. And you can see that they do pretty much good job in general terms. So they pick the spatial pattern, they pick the intensities, but this is just one region. What happens if we move to a different region? This is New Zealand. The situation is different. So this is why it's so important to test the models, to have some benchmark across regions, because otherwise you don't get the full picture of what is going on at a regional level. So this is at the backbone of Cortex activities. So there you see that the non-generative models don't pick the right spatial pattern because it's not by construction, but it's not surprising. But you start having some images that can confirm later with the scores, with the metrics. So you start understanding for which different families of methods could be relevant or not. So, but one step further is when we, and this is my last slide, so the ground truth again is on the top. On the left is what we get, and this is for the future. For this, we are interpolating, transferring to a period in the middle of the century where we haven't trained. We haven't trained at the beginning, at the end, the historical end of the century, but not in the middle. So this is, the ground truth is a particular day. On the left is what we get with predictors coming from the RCM. So this is the perfect configuration. But what happens with we plug in the predictors from the GCM? So what we see is a similar picture. So this is the same GCM used for training. It's the particular subtle differences, but there is some consistency across the different machine learning methods applied in the same conditions. So if this is done with hard transferability, so the GCM that is driving the simulation here is a different one that was not used for training. So we are training with a particular cell in the matrix and applying to a different cell to fill a gap. So we have the GCM, but we don't have the RCM. So we do for this test. So when we do that, we see that in the perfect, we mimic what is in the ground truth, but in the imperfect from the GCM, you see that there are subtle differences, not subtle, there are differences, regional differences. For instance, in the Balkans, you have higher intensity, but this is picked by all RCM. So what we are doing is downscaling a different reality, the reality given by the GCM, which is not exactly the same as the RCM, but is consistent. So we are emulating the downscaling function of the RCMs, and this is precisely what is the assumption of the process that we are undertaking. So similar things with temperature, and we see problems, funny things for particular trainings, for particular methods, at the bottom left. So this is the first results, which are very encouraging and promising. So the idea is to start the final validation in parallel with the production around this summer, later this summer, and one milestone, key milestone for us is trying to have some data set, at least some preliminary data set that can be used for testing, aligned with the IPCC cutoff date, which is around October 2027, sorry. So we can use some comparisons, some of the guidance provided in the contract as part of the literature to be assessed in the process. And that's all. Thank you.
Thank you, Jose Manuel. Questions? We want a microphone to Esteban and, well, and another one to the back of the room afterwards.
Thank you, Jose Manuel, for the interesting presentation on the roadmap you have. You show us results for the soft transferability. Have you made some tests or preliminary tests already trying to change to a different GCM? Because in the literature, it seems that that should be the main challenge.
That was the latest slide. The last slide was hard transferability.
But that was from RCM to train with the same GCM, or so it was a different one? Then my mistake. Sorry,
yeah,
if
so
that was the case.
Too fast. Sorry. So we test both soft and hard, and the hard part is where you see a different pattern, slightly different, but it is consistent across the different machine learning methods. So there we have some confidence that the RCM downscaling emulator is working properly because it's emulating the downscaling function. So from the GCM, even if it is not the same as the RCM because the dynamic changes, so you get some consistent downscale results which align with what you would expect. So there is some promising results even for hard transferability.
So it's then for a different GCM as the one you, okay.
Yeah.
Okay, then we will be looking forward to the full results. Thanks.
Thank you. We have another question here.
Thank you for the most impressive presentations. I'm referring to both of you. I understood that you're both into climate prediction. Yeah, I'm talking to policymakers, and policymaker might now ask you a question, which is a bit like: imagine a planet with 6.5 degrees global average warming. Okay. Can you predict how many people are still able to live on that planet?
Yeah, this is not part of the emulation predictance that we have, unfortunately. Yeah, sorry. So what I think with this contract, because there is a very growing field in particular in downscaling, you can find so many downscale products using machine learning, artificial intelligence that are available, directly available to the users, to the end users. And there is an ethical problem there because we don't know yet if what we deliver from machine learning, which looks nice, is really nice. So part of the activities in this contract, and this is why we push and we prioritize this line of research is because of ethical reasons. We need to develop something using state-of-the-art methods that can be validated on equal footing with the RCMs, and this is why we want to be aligned with Cordex, because at the end in Cordex we are doing extensive physics-based and process-based, regional process-based evaluation of things. So we want to have something which can be compared with the Cordex physics-based standard simulations, so we can pick details. We can understand if the regional processes behind the machine learning training are there or are not there. So, but if we put this data set available, so if we develop the data set and give it to the people doing the evaluation in the Cordex in IPCC, so we could have at least some first evaluation, comprehensive evaluation of why, what are the reasons or what are the problems, the limitations to use this in the real arena, so in climate services. So it's not just, so if maybe that was not clear in my talk, we are not trying to produce something which will be in equal footing with the RCMs. We're trying to produce something that could be evaluated following the same process as is done with the RCMs, and then we will deliver something if there is something useful for the users to be delivered in that terms. We hope this is the case, but we will be very conscious that this is an ethical problem.
Thank you. I think, as you said, this is primarily about enhancing the sample with which we work. In current practices, the question that came is about different type of questions and different type of approaches and different type of investigations that we need to do, and possibly that's what will come next. Sorry, but because of time, we will need to stop here with the presentation. Let us thank José Manuel again. At least I learned. As you would have noticed, what follows is a panel session trying to answer the question, do we need reanalysis in the days of direct observation prediction? For that, I will invite to the podium three panelists, the last two speakers, and somebody who hasn't yet spoken to us today. Before we do that, though, I need to let everybody know, give you early warning, that we will have a group photo afterwards, so please do not leave. Please be prepared to come to the podium as soon as we finish the panel. We have till about 1:45 to discuss. At that point, the streaming will end, and only people in the room will be part of the photo. No further ado, please, Jose Manuel and Jorn, come to the podium, take up one of the seats with a microphone on them. I also invite Dick D, who currently works as a contractor for C3S, whom most of you, if not all of you, know already from his days at ECMWF, where he was one of the people who started the concept of the current C3S program, and before that had a reputation in the reanalysis field based on his data assimilation background. I will join you on the podium.
This work? Yeah.
The work behind the scenes is spectacular, and if I could dip the lights a little bit, it would be even better. Thank you. Okay. Given that Jorn and Jose Manuel have had a chance to say some part of the story, although Jose Manuel has been talking about something completely different, I may start with Dick. And I think we should be trying to address some of the questions that we saw in Jorn's presentation. We don't have them up anymore. Maybe we can put them up for a later discussion. We won't have any other slides now. But I want to start with giving the two speakers two panelists who haven't spoken about reanalysis yet, the chance to have, in about 5 minutes each, to share their first thoughts on a question as formulated in the program. Dick, we'll start here.
Okay. Very quickly, yes, of course, we need reanalysis. I mean, I think everybody knows that. The question is really, or the interesting part of the question is, what does it look like and how is it produced? And what will it offer to users? And, you know, we just heard about DOP. It was a very nice presentation and touched all the important points. There are lots of opinions about DOP within ECMWF. I talked to a lot of people who are working with it and people who are working on the IFS, the current IFS, and improving data simulation, using ML where possible, and there are all kinds of ideas, and I'm sure that a lot of that work, or if not all of it, will succeed, and we will find out soon in the Cherry project, which is a wonderful project because it covers pretty much all of that work, and will sort of systematically assess all these ideas and develop lots of answers to some of these questions. But just to keep things a little bit short from my side anyway, let me just say a few things about DOP and how I feel about that. It's, of course, just a wonderful idea. It's a question of what can it produce, and again, we don't know, obviously, how progress will proceed, but we can say that progress has been really fast recently. I've seen some results that are just amazing, and also reanalysis results. I mean, it's pretty easy once the observations are in place to do a DOP reanalysis. It's very quick, and so it's easy to experiment, which will help to address some of the issues. The potential is very big and very useful, I think, especially for C3S. What is sometimes seen as a limitation of DOP is that it can only produce estimates of observed variables, whereas physics-based reanalysis, of course, produces much more, lots of model information. For C3S, we're mainly interested in ECVs. ECVs, by definition, are observable, otherwise they shouldn't be dedicated or indicated as ECVs. So potentially, in the future, it's a way to combine all observing data records from observations and produce ECVs from them, which would be very interesting. It's the first place. The second thing I want to quickly touch on is the question of, well, can you do without a physical model, and how do you make sure that that there is physical consistency? This is something that in reanalysis, I personally have worked on reanalysis and have always said the role of the model is to enforce physical consistency on the data, and that makes it so valuable. But if you think about it, all the problems in reanalysis, current reanalysis, have to do with actually inconsistent representations in the models. Of course, also for observations, there are lots of problems with observations. But there are lots of problems with models that actually prevent you from using many observations that could be used in DOP. Physical models are very limited in how the coupled system works, for example. So this idea you can't do without models because you need physical consistency, that I don't think that's a good argument. On the other hand, if you think about DOP, well, you have to think about what you mean by consistency, but the data that go in there are all observations of the physical Earth system. And to me, that means that by construction, you create physical consistency. Of course, the question is, how do you have enough observations, enough of types of observations? But all the observations that are known can be used. So physical consistency, actually, I think, could be an advantage of DOP. So I'm very pessimistic about this. I don't think if DOP does very well and produces interesting and high quality estimates of ECVs, it doesn't mean that we shouldn't also have a type of IFS-based reanalysis in the future. We know how useful it is and how valuable it is. But just think quickly about the timeline. If we are going to do an Area 7 on a future version of the IFS, that's not going to be until 8 years from now, perhaps. I mean, that's at least what we know now, that how long it takes to develop a new reanalysis. That was the case for Area 5 and Area 6. Area 6 will be completed by 2028 if everything goes well, which it has never done before. So more likely 2029, 2030. You don't start producing the next one immediately. So we're talking about very, very late in COP3 if it is still a good value proposition to do, and I think it will be most likely. So yeah, that's. I should stop here because
I'm sure there will be questions that will return us to some of these topics, but I would like to give Jose the opportunity to remind people, or in fact tell some people here who may not be familiar with how the climate modeling and climate projections community use reanalysis, and from that perspective, how he sees the value of reanalysis in a sense of traditional reanalysis or indeed modern and future versions of it.
It's tricky because it's like it's arguably that machine learning has shown the power because of reanalysis, because we had Era 5 to train the models, so we could do a fantastic job and show very quickly how powerful and cheap could be the new tools developed from machine learning. So the thing is now we are in a position where with the DOP, with DOP, the son can kill the father, basically. So it's the question on, do we need physics-based new reanalysis, or we can just trust on the machine learning and observations and do the job? So I think this is a question which at least I cannot answer. So the improvement in machine learning and the power and expectations are very high, and continue growing and growing, like the market stock of the IT companies producing GPUs and all that is like picking and picking and picking. There is no ramp down. But is in terms of what was said before, the timeline now is difficult because it's not like we cannot kill the father now because we are not in the position, but we are starting, finalizing one reanalysis with a plan to start a new one, and in 2 years' time, nobody knows what can happen. So we need physics-based reanalysis for now, and until there is a clear indication that there is an alternative. But for us, physical consistency is critical because we do the same with our models. So if we are in the same family, so we need our father alive for the coming years. So that's my view. So I don't know what will happen in a couple of years' time in the future. But for now, we need to keep the family together because otherwise we are risking the whole endeavor. This would be my take. And yeah, we have the clock with the until lunch break timing, so I will stop because it's 10 minutes. And we need to
yes, the threat is over our heads. Jorn, do you want to add anything to this, or shall we open to questions, specific questions from the audience?
Perhaps one small point. I said it, the advantage is the analysis. It's much better than the forecast when you do the training. Because, as you said, the model has some biases. So I would like to emphasize this is the analysis step that is super important and what makes the value at the moment. And it's it uses this sort of the first guess from a model, but it could be changed. So what's probably sort of we should next talk about the next few years. I think the community is pointing towards some sort of a hybrid machine learning NWP type of system. But I think it will go in step. But I agree with Dick, it's also good to have a perspective of the next, say, 10 years.
Please. I see Carlos' hand. I suggest that if you do have questions and I don't see you, you stand up because the light is still too bright in our eyes. Carlo, you start, please. Microphone at the front, please. Probably standing up would help the person with the microphone see where you are better. Anyway.
Okay. Well, first of all, I thank you all very much. They were a brilliant presentation, really interesting. And I like the analogy of father and son. I mean, yesterday we heard about Jonah in the whale. I think it's about Zeus and Uranus, or Kronos rather, and in killing their own father. So there is a mythological connection there too. But actually my question was probably more to Jorn, and also looking at tomorrow, part of the program where we'll hear also from the upstream and the satellite. Because there is one element, one of your many questions there, was about observations. And I think actually it was Stefano last year mentioning that this switch to machine learning may actually change the requirement of what is useful to observe and how and where. So I was wondering whether you have any reflection that we can consider in the evolution of the program going forward on what would be the requirement for observations in the world of AI.
That's a big question. My thinking in the moment is that there's a lot of observations available already. And one point I forgot, Dick pointed to this physical consistency and observations. One thing we haven't talked so much about is campaigns. So I still think there's a lot of potential to use more of these, research campaigns where you have a lot of different instruments, and you do that to understand the physical processes better. They're scattered around in time and space. I think this method we're looking at can also reveal some interesting features by this. So perhaps the answer is more, Carlo, is to try to gather what is out there, also from the research community. And one of those questions is when the data volume becomes much larger, how to handle all these large volumes, observations in an efficient way. We had a very great presentation to begin this session that gives some promise in how to access data, so there's some light there. Beyond that, I think this is still a bit of an open question.
Give people time to think a bit for a better answer. We'll leave it there for now. I've seen a question there to the my left in the middle of the row on the side. Yes, please.
Thank you. Quick question. The change to machine learning methods also meant that private industry players are playing a much bigger role now in producing data sets. I suppose, at least that's my impression. What role do you see private players play in providing these type of services in the future?
It's a good question. I don't know, I can start, or do you want to start? No. Well, I see it both as a challenge, as an opportunity. Of course, it's obviously challenging where sort of we were alone at some point. The same as the opportunity to move forward faster. I mean, C3S, climate change, had some very interesting and perhaps scary presentations earlier. We have to move faster. I'll have another argument. I mean, COVID sort of ruined it, but before COVID there was and still is this challenge of the access to the traditional way of doing computing, more slow, not really being applicable. So we're sort of facing a plateau already in our ability to do more detailed and more simulation to tackle climate change. So I think there's an opportunity also to use machine learning to push the science and the services forward. I mean, there's been a long talk about private-public partnerships. I'm optimistic. I think there's an opportunity to grow this together. We are all in the same boat. So we have a lot to thank to the private industry for where we are now with machine learning. I think there will be opportunities to find good collaborations going forward. Just a short anecdote. In 2007, we went for an open data policy. And then there was StormGeo in Norway that was really sort of arguing to political level, no, Norway should not do this. It will take our business segment out. We will lose money. We will go bankrupt and so on. Well, instead of competing on losing money by providing forecasts for newspapers, we went an open data policy and they grew. StormGeo is one of the biggest companies in the maritime sector now. So they found different business opportunities. Sort of perhaps a naive example, but I think this will happen also. We will find ways to work together and not compete just for the competition's sake. I think we can be better together. That's my sort of optimistic take on that.
We like optimistic views. I think we'll go to Dick, but then Jose wanted to say something as well. So.
Yeah, just very briefly, I think there's also a lesson in the development of the AIFS and what ECMWF did right in the beginning, just basically embraced what was happening in the private sector and actually being very open and collaborative with them, and that's been very successful, obviously. So we should continue that as much as possible.
Jose.
Nothing to add. Just collaboration is mandatory, so there's no way to move forward alone. So the ITs, the big ITs, are basically paving the way for machine learning with the technology, with the frameworks. So we need to combine science and technology. So we cannot split.
Is there still a point to be made about access to observations which are currently not freely available, which maybe private companies still hold or indeed will continue to collect?
There's not the aspect also. I mean, there was talk about the National Met Services. I think they still have a role to play because they, like it or not, probably like it, but there are different cultures around Europe. And be able to sit on the lap of sort of the users in the respective countries have a user advantage. And private companies won't do that for specific areas, for some, but not all. So there's a huge potential for Met Services in the future. Our experience is also that private companies are quite eager to share data, as long as their competition doesn't get access to the data. So we have used data from a lot of private companies. It's not sort of machine learning, NWP machine learning per se, but it's more statistical methods. So being cooperating then and developing improved statistical methods, we have used that in improving the public forecasts. But the data themselves are hidden, but the results are available to all. And then by collaborating with the private, they can go home and fine-tune and do stuff on top of what is also public available for their purpose. So I think there's opportunities also have with the technology they have that we can share data without exposing all the data for all.
Thank you. I can see one more hand there and another in the middle. So through the, yes. Andras, keep your hands up, please, so the lady can see you.
Okay, thank you for this interesting discussion. I just want to add one aspect to this debate, that I think there is a planning issue here for C3S. So we are planning, I think, for 7 years of budget of the EU for Copernicus 3. So I guess the content of Copernicus 3 should be defined in the coming year or so, maybe more, I don't know.
Months.
And we don't know what will happen with the fast progress of machine learning. So we don't know what will be the role, all of this discussion, what will be the role of the machine learning models, how we go ahead. So I am wondering how this planning can be done, how to plan what products will C3S develop, what resources C3S will need, because there are a lot of unknowns. So I'm really wondering how this planning can be based and how this can be made, maybe it's more question to the EU, to make the planning more flexible or dynamic, or in a way that to readjust the plans in the light of the developments of the coming few years. So I think there is an issue here, in my opinion. I'm curious to know what is your opinion or answer on that. Maybe I don't have enough knowledge on the planning process, but I think it's an important aspect. Thank you.
I can help you there. My suggestion is we postpone this for one of the sessions tomorrow, maybe, given that we are already in the red with the time. And I think I've seen one more hand. So if the hand that was up there, it's about the panel present here rather than for C3S people who will be working on a planning, please put your hand up again so that, okay, I see Hans's hand up now. He wasn't that, but let's just go to Hans for a parting word.
Hello. So today in the CDS we have dedicated ECV products. And we have reanalysis, which also produces estimates for ECVs, but they're different. So the dedicated ECVs, they're very high resolution, but they're based on a limited amount of observations, and they have problems with gap filling because typically satellites, they don't cover the whole globe every time step. On the other hand, we have the reanalysis, which has maps without gaps, and we make use of all the observations that we can, but there's a lot of observations that our physical models, the information is there, but we don't know how to exploit them. So we like Earth radiation budgets, we have precipitation, and there's other examples as well. Now machine learning is very efficient in extracting information. That's the strength of machine learning, getting every little bit of information out of the observations, and we're not limited by the physical models. Don't you think that in the future maybe the gap between the ECV products that we have now and the ECVs from reanalysis, that they become smaller and maybe, disappear?
Somebody want to take this?
I mean, that's what I was trying to say earlier, that that's sort of the long-term goal of this, or, you know, if DOP really delivers what we hope, then that would happen. But when, nobody knows, of course, and there may be other reasons why not, but I think that should be the aim, to make to use DOP to unify what we have today.
I see Carlo wants to say something. I want, while the microphone makes its way to Carlo, I want to add something. Maybe we need to rethink about what we mean by reanalysis. I know that terminology can have a definition, but I think we have now used the word reanalysis so strongly for such a precise thing. Maybe that's one of it. Even Hans said ECVs from reanalysis, although here we're talking about doing reanalysis with machine learning techniques. Carlo.
Just very briefly, I want to go to the previous question because I think your idea is great. Tomorrow we have a session about Copernicus evolution where we can tackle that, and it's a hell of a job trying to design the program for the next 7 years in the moment where literature of 2 months ago is old literature in terms of science, right? So it's really a challenge. But in that respect, we are working with scenarios and big concept. And we were asked by the Commission to write a non-paper That's the terminology. And in that non-paper, one of the messages that we have is that we would like to fill the full list of ECVs, so the 50 plus ECVs that we have, using a combination of reanalysis and observation. So in a sense, which is exactly what Hans and Dick were discussing now. So in a sense, I think the direction of travel is correct. How to get there and how to dotting the I's and crossing the T's is a matter that needs to be defined, and we will discuss tomorrow. Thank you.
Thank you, Carlo. Thank you for staying and answering questions. Let us all thank the panelists for their on-the-spot thoughts on the matter. And please, the rest of the room, join us on stage or in front of the stage for the photo. I think somebody is going to come and tell us exactly where to stand and what to do. I invite the organizers to do so.
Hi, thanks for the patience. So we're going to take the picture now. If everyone could please smile. Thank you.
One question, can everyone see him? If not, please change your place.
I come home, she lifted up her wings. I guess that this must be the place. I can't tell one from the other. Did I find you or you find me? There was a time before we were born. If someone asked, this is where I'll be, where I'll be. Oh, we drifted in our
Got a new nigga, now we can't be found. Coming and they know my name. Got a new girl riding and I hope she game. In these streets we got no shame. All my niggas who think they real. If you know how I feel, never mess with explosives. Yeah, yeah.
Hi, Carlo.
I would be able to stay for the first two, possibly three presentations, but then I need to head off because I had a presentation to an MEP.
Ah, okay,
Just to let you know.
It's okay. Yes.
Excuse
No worries. No, it's fine. Okay, so we're getting started shortly. Please find your seats. Okay, so welcome back, everyone. It's time to kick off the first afternoon session, which will be an interesting journey across different topics. We start with EQC. We'll listen to some interesting stuff about LLMs, and then we will touch upon a couple of sectoral activities in the area of water, energy, and agriculture. So we start with an EQC LLM block, which I will briefly introduce. And then our first speaker in this block will be Joanne, followed by Jonas. Okay. A few words on the EQC program of C3S. 2 years ago, roughly, we have been publishing our vision for the EQC program in a BUMPS paper that was called Are Our Climate Data Fit for Your Purpose? So it was pushing the EQC program in a kind of user-oriented direction. In the beginning of this paper, we had put a fictional dialogue between a user and a chat C3S kind of chatbot. And this is now becoming a reality, and we will have a presentation by Jonas about this in a couple of minutes. We also kind of presented the EQC framework in a conceptual way with the 3 pillars that you have heard about already, with the quality assurance, like the technical quality, the quality assessments, looking at the scientific quality, and then the fitness for purpose, which is the kind of guidance for users how to find the best data sets for their purpose. So, and this has also become already a reality. We have implemented this framework, and we have published lots of interesting material across the CDS. So the quality assurance is the component that users might see first when they go through the catalog with the quality assurance label there. And when they go to the data set, you see some checklists where users can learn about what kind of technical requirements have been met, which criteria have been met, and why they have not been met, etc., or not fully met. Then the other element is the fitness for purpose. This is something users will see first when they go to the quality tab, which is associated with many data sets. And there they will see kind of the strengths and limitations of the data, as we have heard yesterday, some example applications, further recommendations. So this is rather lightweight information, simple information, synthesized from a lot of quality assessments, literature, everything we know about the data, and kind of presented in a fact sheet-like way. And then, arguably, the heart of EQC, let's say, because this is the scientific evaluation, where lots of work is going in, where we look at different quality attributes like uncertainty, like consistency, trend, suitability, all sorts of things. And this information is very much user-centric. So we look at use cases, we look what users are doing with the data, and what quality-related questions they have. And based on that, our contractors, our evaluators, develop Jupyter notebooks. They are being collected in an EQC Jupyter book. We have almost reached 100 quality assessments already there. And this is a standalone resource. So you can access this via a link. You can browse through the different assessments. But they are also linked back to the actual catalog, so to the data sets. And this is growing and also the user base for this is growing. Talking about the users, so we have done a couple of user satisfaction studies. Yesterday, Ali already told you about the ECVs. It looks very similar across the different data sets. So we have looked at all data set categories. We also have looked at all the different EQC components. User satisfaction is relatively, or actually very high across the different areas. We also look, of course, at the negatives, at the criticism, and will further evolve the function. It's not only the users, which are relatively happy, let's say. It's also for me important that the providers have given very good feedback. Some of you are in the room, and also many thanks for your kind of feedback. You have been reviewing lots of the material. And last but not least, also internally at ECMWF level, the technical officers for the data sets, etc., they have also have been very positive about it. And you can see EQC popping up here and there in the talks. And this is exactly what we had in mind, that it will become kind of an integral part of the data, user data journey. Looking ahead, so that was mainly about EQC for data sets. Now we are taking this to the next level. We look at EQC for applications, for indicators and learning resources. And Joanne Nightingale will talk about this in a minute. And the other big development that we had teased already in this paper 2 years ago is this new LLM-based generative AI assistant, which will do different things. So it's not just a conversational kind of interface or chatbot. It's looking at data discovery. It's looking at quality evaluation. So we try to do some experimental EQC based on AI. And a user support offering, of course. So Jonas Holstein will talk more about this. So I stop here. And I get to my last slide, just a very brief outlook. So, well, the key message really here is that the user uptake has increased, the visibility has arguably increased across the CDS, and EQC has now become an integral part of the user journey, which is great. And I would say, and I firmly believe, that it contributes to making C3S a trusted source of climate information. The next steps now, or the next vision, if you wish, is to evolve this EQC further into an interactive guidance layer for users inside the CDS user journey that will be fully integrated or interfaced with the new CDS AI assistant. And I stop there. Thank you. Now, I would like to ask Joanne Nightingale on the stage. We'll continue talking about EQC. Joanne is the principal scientist at the National Physical Laboratory in the UK, and she's the service manager for our EQC for Applications, Indicators, Learning Resources contract. Please.
Exactly. Thank you very much. Excellent. Well, good afternoon, everybody. Great introduction from Andre. So I'm here to talk about our contract 521, which is extending EQC beyond data sets, as we said before, the observations from satellites and in situ. I added this slide in this morning, and sorry, Andre, you haven't seen this, based on a conversation I had yesterday afternoon, where someone came up to me and said, so what is EQC? What does it do? What is it meant to be? And I realized potentially there are people in the audience who are very well versed with it and people in the audience who've never heard of it before. So the evaluation and quality control function for the Copernicus Climate Change Service, I like to think of as essentially its quality management system. All right, so every reputable organization has one. Formally, it's an ISO 9000 standard. But it's essentially a set of policies, processes, procedures to ensure that products or services consistently meet customer expectations and regulatory requirements. So essentially, that's what we're trying to do here for C3S. We take this further with evaluation. So that's provision of tangible, evidence-based information about C3S data sets, applications in relation to their strengths, their limitations, their intended use, and that's all based on scientific assessments. And then we make that information accessible. So being able to present it in a way that it can be interpreted appropriately by a range of C3S users. That's everyone who's never even touched a climate data set before, all the way through to people who are making these data sets and they're firmly entrenched in their production and all of the warts and all that these things have. So that's what I would say we're doing in a nutshell. In our current contract, which has been going for about a year, I introduced it last year, we'd been going for about a month. We are looking at the C3S applications. So the interactive applications that bring Copernicus data to life, which you've seen a few examples so far. They're in the format of simple data viewers that take existing data sets and show them, all the way through to interactive dashboards that do some analytics with the data sets. We're looking at indicators and derived data sets, which are essentially sectoral information that's been further processed from core data sets, so from core observations, reanalysis, projections, forecasts, etc. And that further processing can be things like downscaling, aggregation, bias adjustment, modeling, etc. And then we're also looking into the EQC of learning resources, whether they're e-learning modules or events or webinars, etc. So in an evolving EQC function scenario, there's two things that we want to do. One is maintain a robust quality management system for C3S, and secondly, maximize the benefit of that information and that process to the C3S users. So Andre showed this before. There's currently three sort of areas that we look into: assurance, assessments, summarizing this in fitness for purpose statements. But we really need to get to the nub of what do the users expect of C3S? What aspects of the evaluation quality control information do users interact with the most? And how do we communicate all aspects of quality of the data sets and applications, etc., to users effectively? So as with all C3S contracts, we've been through our own set of user requirement surveys. We've done some surveys for some data sets, some applications. We've had a fairly decent response rate. We've done a few online workshops with what we call cool audiences, so people that really are less experienced with data, all the way through to warm, we can't call them hot, more experienced users. We've had very, very valuable interaction with the application and indicators and derived data set developers so far, and that's really helped us hone in on what we're trying to do. And here at the C3S so far, we've been at the NCP workshop yesterday, and we've done 2 usability test interviews so far, and we'd really love to do more. So if you're out there, you've interacted with EQC data, we really, really would love to talk to you. And okay, so in terms of the responses, we've had a couple of really interesting findings. Well, the main interesting finding we saw is that there are a lot of users out there that interact with C3S in a language other than English. And the way we found this out was we invited people to workshops. They came online and they didn't speak English, and they quickly disconnected. So how do we then make all this wonderful information about the data and the quality of the data accessible globally? Some key observations from users so far. Users look for data applicability first. What's the coverage? What's the granularity? What's the temporal frequency? They're the key things. That's great. They want to understand the data limitations. What are the gaps in the data? What have other people come across that might make that data not suitable for the use they want to use it for? They look at, they assess the reliability of the data provider. So for C3S, the trust is very high, and hence there's an assumption that the quality of the data will be high. And there's a need to communicate the data source and quality to their clients. So people that are using these data then need to say, well, we got this data from a trusted source. And they appreciate various use cases showing the feasibility and ground truthing and validation data sets, etc. And then we've got some warmer audience and cooler audience observations there as well. So we are looking at this now as EQC for developers in terms of the quality assurance. So this is the internal quality control. It enables iterative improvement of the information going into the CDS, and it's based on criteria adapted from previous contracts for the applications, indicators, derived data sets and learning resources, based on a set of checklists. And that enables us to have consistency across the information we're providing. What we have found is there really is a need for documentation templates to make this happen, as you'll see with the horse. What we think we're producing versus what we see when we evaluate can be two very different things. And as I said, we've had very good early favourable interaction with developers so far to make this process a lot more streamlined. So essentially, this data, you would have seen this presented in various places, provides a trust or confidence, essentially the seal of quality for users, but we really need to determine now what users want to see of this versus what is more of an internal piece. The key entry point of EQC is the fitness for purpose. As I said, it's a place you go to look at the key strengths, highlights the utility of the resource, provides guidance on its intended use, the key limitations, where caution should be taken, example use cases, and then further recommendations. And that looks something like this at the moment, where they're just sort of text pages with text underneath the main points here, which is really nice to look through if you're just wanting to get a feel for the data set. In terms of quality assessments, we look at evaluating the suitability of the resource for specific use cases based on quality attributes such as completeness, consistency, coverage, reproducibility, etc., etc. And I've just got a few examples here. This is the ERA 5 dataset consistency with ERA 5 land. We're looking at here the reproducibility of this C3S Atlas application, reproducibility from its underpinning dataset. And in terms of uncertainty, we've also had a look at some uncertainty assessments for the ERA 5 drought, using the dataset for parametric insurance examples. And what we're doing here is not doing the uncertainties, we're taking the uncertainties that are provided with the data and then working through the process of how suitable are those uncertainties for answering the question or the use case that's been proposed. So as I said, we want to hear from you. We'd really love to talk to you. Visit us at the booth. Please provide us with some honest, constructive feedback, because that then feeds back to how you work with us. As I said, there's a QR code there. And thank you very much.
Thank you very much, Jan. Please stay on stage, because we may have one or two questions for you. Let's see, please. There is one from Dick, please. A microphone to the front, please.
How do you think it can be improved?
The EQC function? Oh, we're doing it right now, as I said. Wow. So I think looking at more of as a quality management system, so you bring a lot of the background work into the development phase with the developers, getting that feedback for iterative improvement. And then you know right off the bat you've got a good set of criteria from which to move forward. A lot more user interaction, so we're not sort of pulling examples of quality assessments from our own heads, but actually having users say, we're using this data for these applications and we're seeing these issues. How can we address them? So I think that user interaction is hugely important. And of course the LLM, but I won't take the.
Great. Another question from the audience? Can't see anyone. Ah, yes. Daniel, please.
Hi, thank you. I wanted to know how you measure usage of the EQC documentation. If you're able to track how it's used and how much, and if you already have insights on this and how you do that.
I think the previous contract does have a little bit more in terms of the use statistics, but we've not had much ability to do that at the moment. But it would be really good to get mouse trackers on the EQC website, see where people are clicking, pointing. But yeah, that's something we'd love to look into.
Yep. Yes, thanks. We have the metrics indeed and are looking into this. Yeah. So thanks for the question. And is anyone else? No. Then, Joanne, thanks a lot. Yes, so may I ask Jonas Solfstein on the stage then? Jonas is a product manager, right, at Development Seed, a new contractor for us. So Jonas is the service manager for the new contract he will be talking about now. And please, the floor is yours.
Thank you. Thank you all. Yeah, so we had some good warm-up from the previous speaker, so I hope you're all excited to hear a bit more about our project that we just started. So this is an effort led by Development Seed and with contributions from Alfred Wegener Institute and Mais Atlantic. Michaela and Andre are the technical officers. So you already saw this title here. Basically, this is how the inception of this project happened 2 years ago or more. The LLM technologies were just on the rise, and there were ideas of how this could fit into what CDS does. And I think it's fair to say that how it's been going since is a takeoff of LLM technologies that really exceeded all expectations. So this is now really embraced in all kinds of professional workflows, as you all know, and also using these tools for data analysis and also coding is already becoming a commodity, and people are probably right now doing climate data analysis with Cloud Code and ChatGPT and all these type of tools. And while this is all happening, my view is that the role of C3S as a trusted provider of trusted information is even more important, because you can generate all kinds of stuff now. Now is the time to really step in with authoritative information. And how we want to do that? So we just started. We just had our kickoff 2 weeks ago on this project, and the main challenge we want to address is that even with all the very nicely curated EQC and information that CDS provides, there is a gap for end users to understand what metrics are important for my use case. When do I need to care about trend analysis? Or maybe they don't even know that word, and so on, right? So to bridge that gap, we are basically working on using LLM technology. And I want to get a bit more into how we intend to do that, a few technical details, because there's a lot of hype and myths around large language models, and also show a bit of prior art from Alfred Wegener Institute and Development Seed on the topic. So basically, where we're at with LLM technology, we all know the times when everyone was hitting LLMs with questions and shaking their heads about the answers. This is still a challenge, that model memory is flaky, hard to control. It's also really hard to train, actually. So these big models are what they are, and they're getting good at a lot of stuff, but their memory is not always ideal. So hallucination continues to be a problem. The second tier is that you can pair that with just using them to ingest and digest a lot of original content, and then also surfacing that content with references. That's this retrieval augmented generation, RAG type of system. So that improves some aspects. And the new thing, the latest developments that everyone's been so excited about this year is basically all about the third tier here, which means these LLMs have become a lot better to plan and build their context, and then operate specific tools and tasks, and also course correct. And this is basically this agentic skill that these models now have is something we want to leverage in our contract. And basically in two ways. First of all, we have basically two main work packages under this contract, which will run for 2 years. The first one, developing a CDS assistant. I'll get into both in detail. That's basically a conversational agent that helps you in a session that's live. And the second one, which is experimental, is to see, can we also use these LLMs to do deeper research, semi-autonomous, and help EQC like populate and expand the body of EQC material. Of course, not fully automated. This is not content wheel, but I'll get to that. I'm getting ahead of myself. So on the first one, basically for these agentic tools, there's two main pieces of technology that we combine. The first one is tools. This is the boring part, actually, the more or less technical part, but of course super important. In our case, that's going to be a tool to find a point of interest. You know, it can be very simple like that, but it can also be to operate the CDS API. You will probably get Cloud Code to do that decently, but we can do better than that if we build a dedicated tool for that. And also all the great CDS applications that were presented already and will be presented, they can become tools that the system knows and can refer the user to and knows how to operate. And the second part is really the expert knowledge of how do people approach problems in climate data analysis. For example, and I saw some of these in the National Program Workshop where we had an interactive session mapping out how do you approach dataset discovery was actually the prompt to all the audience, and these things came up basically. So yeah, you need to find your dataset, and there can be some guidance, like the user will prefer a reanalysis if they're looking at past climate, but not if they're looking at radiation budgets. And these are things, maybe they're in the model knowledge somewhere, but you wouldn't count on it. So we better provide that as expert guidance. Same thing on parameter finding and accessibility. So for example, ARCO data for specific use cases, we want to recommend those, for others not, and that should be guidance we give. And the new thing here that we want to introduce is to really make this system understanding quality information very well. And that means, yeah, when do we decide that a use case that is adjacent to something that the user asked is still applicable? For example, how do we judge whether data sets are similar? And all these kind of things. These are basically ideas from our proposal phase, and we have a very intense discovery phase now and also here to really understand what these criteria are we need to be sure of. Yes, and finally, how we envision that this will be integrated into CDS is that we will probably develop a standalone application, especially in the beginning, to try things out. We think that probably the knowledge duck may evolve, so a live assistant on the CDS website, and we also think that all these tools should be available where people do this analysis in their own workspaces, because a lot of people are using LLMs on their machines, or maybe we could have it in the CDS Jupyter Hub environment, so not a predefined interface. And the nice thing about these tools is they are so modular, you can plug them into your agent somewhere else, and it will then gain the skills that CDS provides in their case, basically, in their workflow. And the second work package I just wanted to give you some details on. So, like I mentioned, this should be a tool for EQC, for scientists who are producing EQC reports. So we're not thinking we'll replace that expert knowledge, of course, but support it. And how this works, if you focus on the middle of the diagram first, basically we mostly build systems where we have a supervisor agent. So that is one LLM agent that has access to a number of different tools and instructions, and that makes sure that all these tools are operated in the right sequence, and it reacts to the things it gains, the knowledge it gains from calling tools, and which would then draft EQC reports, for example, that go into review, and this is an iterative loop of refinement and improvement. And these are some of the sub-agents or subsystems that we consider that this supervisor will orchestrate. And one is, of course, retrieving the data from CDS. That is already an outcome of the first work package. Also literature analysis. This is actually a very expensive part because there's a lot of text to process. yeah, and then if we want to pull in new sources for validation, then that is also a specific skill. And the really powerful thing that we're seeing used a lot nowadays is of course, that agents can write and execute code in a controlled environment, because that really opens up for a lot of flexible use cases. For example, pulling specific statistics from a data set, or producing plots and all these kind of things. So yeah, this is a drafting tool, not a production tool. And now for a few examples from previous work. So both Alpha Wegener Institute and Development Seed have been engaged in the Destination Earth program as well, delivering 2 large language model applications, and I'll briefly show both of them. So Development Seed has been working on the Digital Twin Assistant, which is a dataset discovery application for the digital twin data. And that's a standalone application currently. And how that works is the status of this is it's about to be, it's very close to be released in beta publicly. And then for users of the Destination Earth platform, will be available. And this is mainly an agent to help users break the first barrier of access to the digital twin data, to discover the different fields in the catalog, and to construct a polytope request for requesting the data. And then and on top of that, it can also retrieve data for users who are authorized and make some simple plots of extracts of the data. And now that the digital twins are also launching monthly mean data, that'll be even more meaningful. In the past, we had cases where people would plot the future weather in 2040, which is of course not what this can provide. And the ClimSite project by Alpha Wegener Institute is the research type of agent that I also, or system that I also presented. Which is a lot more a system where a user constructs a query in the beginning by selecting a location and submitting a request from a specific sectoral question, and the agent and the system then goes off and does a lot of literature research and code execution to give a good answer, a very solid answer, and produce a comprehensive report with all the sources and all the plots and all these things. So this is a system that in some deep research mode can take hours or even days, right? But you are confident that you will get an answer that you understand, not just 42. So it's worth investing. And we'll use the same pattern in the CDS work. The third one I just wanted to mention, Pangea GPT is also work by Alpha Wegener Institute, also for dataset discovery and analysis in the Pangea catalog. Thank you.
Perfect. Thank you very much, Jonas. I really enjoyed that, and I'm excited about this development. I hope you too. And I guess there might be 1 or 2 questions for you. Chiara, please.
Thank you very much. Now I'm very curious to see the output. A quick question. So when we developed our applications, our data sets in the CDS, we were not thinking that, for example, the documentation associated would have been used by tools like the one you are building. Do you think that we should rethink of our documentation, the way we produce it, cleaning it up, avoiding redundancy? So can you say something about that?
Well, yes. I think we should. I think there's a lot of very valuable guidance in documentation, and making that accessible. Sometimes it can be an offline processing step. So we've also considered harvesting insights from the Jira support tickets, but of course there wouldn't be a source that the agent sources live, but it would be a research to do, and then to synthesize some guidance to the agent. And that we could also do with documentation when it's sparse. And actually, LLMs are great at sourcing information from various sources. But the more is available in a structured and consistent way, the better.
Thank you. We go to Jörg first, then Carlo. Okay.
Yeah, very, very nice talk. Impressive work, I can say. But the question I have is, if the user starts the journey on a general agent prompt, like in Copilot or so, would they automatically have a path to your internal agent that has all the tools? Is that regulated somewhere?
Yes, so there are basically plug-in interfaces for connecting third-party systems like ours into a commercial agent. So the user would actively need to connect the CDS system into theirs, but it's a few lines of code or a few clicks. You can also expose these in catalogs for ChatGPT, and then it's just ticking it on. And then the main agent that the user interacts with will be guided to know when to consult this particular source for expert guidance.
Thank you. Okay, now we have Carlo.
Yeah, thank you for the talk. Really, really interesting. I guess my question is complementary to the one of Jörg, because if so far the main entry point for data has been the catalog, so user coming to the CDS and finding the data. But clearly, a system like this may become the entry point. So in that sense, how do you expect the user experience to change in discovering data sets because of these new technology?
Yeah, I was really blown away in our kickoff by the presentation of Michaela, I think, and others, of how much usage the CDS website gets. So it seems like it's working the way, and it's not only because it's the only way, but because users really find this a nice entry point. So I would assume that it remains like that for a good segment of users for quite a while, and that an assistant that guides around the website and guides around the resources that are advertised there could be the first tier, at least, for integration. And when the user experience, how it will change from there on, yeah, good question.
Thank you. I would like to take one question from the online audience. Matt Minari is talking about C3S as an authoritative and trusted source, but arguing that many people's experience of LLM bots is kind of poor. And he's asking what guardrails will there be to stop LLM answers eroding trust?
Thank you. Yeah, very important for C3S to consider. So what we are doing in these other applications is that we usually use the agent to surface original information. So we connect dots and sometimes summarize, but we don't give the final answer just from LLM-generated content. So I think usually we would always link to the original sources, and whenever possible, data would be displayed directly from databases and so on, and not passed even through a digestion step. Mm-hmm. So that's one of the steps. There's, of course, measures we have considered that will always check the system on consistency and all these things, but it's correct that this can't be fully avoided, so we just have to keep it out of the loop wherever possible.
Thank you. Yeah, we need to move on from here. Thank you very much, Jonas. And with that, we close the kind of EQC LLM block and move towards the sectoral activities. I think we will start with water. Katie Facer-Childs, please, on stage. Katie. So Katie is a senior hydrologist at the UK Centre for Ecology and Hydrology, and she will be talking about the user needs for the operational C3S water service. Please.
Hi, thank you everyone, and thank you for inviting me to speak at this conference. I'm talking to you today about the Copernicus Climate Change Service water service, so the water sector, and how we're meeting the user needs with this service. So there are lots of different timescales that people need, and it's not just exclusively the ones that we're delivering, but generally people are needing an understanding of what are the current conditions of water resources around the world, what's going to be happening over the next 6 months, and what does the future hold. Now, as I say, there's a few gaps in the middle, but these are the things we're focusing on with the water service at the moment, and we're delivering those via a few lots within our contract. Lot 1 is led by Stefan Tober at UFZ, and he's delivering seasonal forecasts, which also give an understanding of what's going on right now with the modelled initial conditions. Lot 2 is led by Peter Berg at SMHI, and that's looking at the climate projections timescale. And then across the time steps, UKCEH, myself and Lucy Barker are leading Lot 3, looking at delivering these user elements, really quantifying what people need and how to deliver those to the best of our ability. We have a couple of subcontractors, Wageningen University and Utrecht University, working with us as well on this contract. So what are we doing? So you might think that there's some of these things already exist. We have global modelled seasonal forecasts and projections in various forms, and we do. There's existing systems at ECMWF and CHEMS through ECLand and ListFlood, particularly GLOFAS and EFAS. There are existing European seasonal forecasts and projections delivered with the EHYPE and the VIC models. And there are existing global seasonal forecasting systems with MHM, PCR Glob and JULES that are not publicly available but are running at the moment. But these are all disparate services, disparate models, and what we're doing is we're bringing those together into one consistent system using the same input data set that's being commonly bias adjusted and downscaled so that we can run it all through the same hydrological models to deliver a centralized system both for the seasonal forecasting time step and the projections. And that's being delivered over 5 kilometres over Europe and 0.05 degrees for the globe. We're also integrating ListFlood there. It's not using the same input data, but we're integrating it into the same output so it can be visualized and used in the same way. So the outputs of this centralized system are, we have some consistent output variables, hydrological variables and meteorological variables. We're deriving impact indicators to make sure that people have things that they need to know about specifically. We're building 2 interactive web applications, and we're also delivering a series of demonstration use cases. And all of this is being wrapped up with a lot of user guidance materials in as many different shapes and forms as we can to provide that information at various levels according to our different range of users. So we've got user requirements really being delivered at the heart of this service. The user needs assessments are being reviewed and quantified through, we've done a global survey of user needs for people's data outputs, access and uses, and we've also been conducting key informant interviews that are more detailed discussions on the needs and applications. We are delivering, as I said, some interactive data applications, and those are being co-developed with some super users who are really giving us direct feedback on what is the functionality they need of those web applications, how they look, how things are visualized, and what guidance they need on those. We're delivering use cases, so these are really accessible examples of how people can use the water service to really inspire others to come and do the same. And yeah, lots of different ways of providing the user guidance too. So we have, at the moment, 3 different use cases, and the more people I talk to at the General Assembly, the more that is growing. Lots of people want to use the water service, and that's brilliant. But the first one we've got is from the Sava River Basin Commission. They are working on a project in terms of their climate change adaptation strategy. And we originally approached them. They were interested in climate change projections, but they are also interested in the seasonal forecasting side of it. They're not using seasonal forecasts in their region much at the moment, so this is a new area for them, and we're working with them to see how we can help them, particularly in navigation planning, drought planning, and dredging and things like that. So we had a workshop with them actually just last week, and we conducted some interviews and surveys with them. We are building our use case definitions this month, and we'll be having another workshop with them in the autumn before we deliver our final use cases next summer. The second use case we have is with the World Meteorological Organization. I work very closely with them on the hydrological status and outlooks system. And this is a system where they're trying to bring together hydrological monitoring data and seasonal forecasts, but really situate them in terms of what is normal and what's above normal, below normal for that particular space and that particular time. And what they're trying to do is build a lot of capacity around the world from the bottom up to deliver, bring people new products and help people develop new products. But there is also obviously a lot of places in the world where that's not possible. There's just not the data available. And so the C3S water service provides a brilliant use case for that global backdrop of that service to provide information where there isn't information already available And it's also going to enable us to overlay local products on top of that global system so that we can start to get feedback of where we're doing well and where we're not doing so well with our global models. Our third use case is with Save the Children. They have lots of projects under their Green Climate Fund looking at adaptation and resilience. We are still developing this use case with them in negotiation, but they also are very keen looking at seasonal forecasting system, particularly with the upcoming El Nino event and how that might impact people in Ethiopia and whether there's any anticipatory action they can take to mitigate some of those outcomes. So my next few slides will go through how we've gathered the user requirements and what we're doing to deliver them. So as I said, we've done some interviews with the Sava River Basin. We've had 9 interviews with people in various countries across that transboundary river basin, and they come from the various sectors, water management, navigation, and water policy in particular. We also conducted a Mentimeter survey with them last week to just add a bit more information to what we've gathered. There's a global survey. It's currently still open, so if you would like to open it up and have a look, it's also on our website if you want to go and have a look at that and click through it that way. This survey's had 112 respondents so far from more than 16 countries. Not all of, some of those were anonymous, so it could have gone a lot further than we realised, but we covered a lot of different types of users, including people who are producing the data, hydroclimate data sets, as well as people who act as intermediaries and those who are really policy making and using that information as well. So we think we've got quite a breadth of people that have fed us some information in terms of what their user requirements are. Over the next few slides, the graphs on your right tell you a bit about what the results from the survey were, and then the words on the left are more from what we got from the interviews and the Mentimeter survey from the people in the Sava River Basin Commission. And in terms of hydrological indicators, we asked people what indicators they were particularly interested in, and interestingly, actually, precipitation and temperature, the meteorological variables, came out top. So we're going to make sure that we include that element of the water cycle in this hydrological system, but also, as you would expect, people looking for river discharge and runoff. Snow came up quite interestingly as well. Lots of people very interested in ice conditions and drought-related indicators. There are a few indicators that came up that are not within the remit of our contract, so things like groundwater, sedimentation, and water quality, for example. But there are a couple that did come up, such as turbidity and water temperature, that we can possibly deliver from some of our hydrological models. So we're going to look into that and see whether we can meet those needs. So the key output variables we have from the hydrological models are evapotranspiration, root zone soil wetness, runoff, river discharge, and snow. But as I said, we'll also be delivering temperature and precipitation. In terms of the climate projections, we're also producing lots of derived indicators to make sure that people can understand what's happening to the water cycle in the future under climate projection scenarios. Things like what are those changes in mean, maximum, and minimum of all of those variables, as well as some more specific things like the number of days below the minimum discharge or frost days and tropical nights, for example. In terms of seasonal forecasts, we're also providing the data as categorized variables. So as I mentioned with HydroSOS, and I'll show you another slide on that in a minute, really situating what's going on in terms of what's normal, above normal, and below normal for that time and place. So for the seasonal forecast, we're also delivering these as categorized information, and you'll see what that looks like. In terms of resolution, in temporal resolution, people were really keen to have daily data. Again, there were a few requirements that came out that are not within the remit of our contract, so people were requiring hourly data or data on near real-time basis because we're only updating these systems every month. But it's good to know that people would like those in the future and whether we can update the contract in the future to have a look at those things. But generally, people would like things on a daily time step, particularly for the historical data. But for seasonal forecasts and climate projections, people were more willing to have a look at things on a monthly or annual basis. In terms of spatial resolution, the majority of people, again, want very high resolution. They want fine gridded data, although some people are interested in coarse gridded data. And there is quite a lot of requirement as well for spatially aggregated data in polygons, such as geographical polygons like river basins, or administrative polygons as well. And that's something we need to look into as to how we serve that up as efficiently as possible. In terms of data access, a surprising number of people said they wanted things delivered via scientific articles. This may have been because perhaps a lot of academics responded to our survey, but it also does suggest that people perhaps want to see things peer-reviewed, which is good to know. Then secondarily, people were particularly interested in APIs. as well as the web portals and the web applications as well. People wanted really clear and simple data access, ways that they could get through, and things from centralized and trusted systems as well. So delivering these interactive web applications, there are a lot of requirements that we knew were in place and that our suspicions were validated by a lot of the responses. People are particularly keen on very fast and responsive web apps, and we're taking actions to make sure that we can get things as speedy as possible. They want to be able to see things both as maps and plots. They want to be able to choose multimodal selections. They want raw variables and derived indicators, skill and uncertainty information, and simple data downloads. So we're delivering this through a T-tiler backend that enables dynamic queries of multidimensional data, the React front end that's component-based and is highly reusable for dynamic and interactive web apps, and we are already looking at using ZAR files, and we've already successfully tested those for efficient chunking and cloud-friendly data and partial reads, and we're looking forwards into potentially getting things into this ARCO system as well. So the seasonal forecasting web app, this is just a few previews of the web apps. They are live online, but please bear in mind they are under development. The seasonal forecasting web app is further along than the climate change projections one. We haven't got our climate projections data ready yet, so that's just a bit of a placeholder. But the seasonal forecasting app offers lots of different things you can click on that meet the needs of users. It also shows you some time series plots, and you can see the ensemble members compared to the historic values of Q10 and Q90. You can tick different models on and off, and you can see it aggregates those as a multi-model mean on the fly. And then, as I mentioned, you can see this as a categorized forecast as well, so you can see the likelihood of a particular variable going into the extreme or high or low categories. And this is directly compatible with the WMO Hydro SOS use case. As I mentioned, the Climate Projections app is available. The additional things it's not available. Well, it is available, but it's kind of in development. It's the additional things that can do is it gives you the option to choose between different time slices and different warming levels. And then one of the really interesting pieces of feedback we've had from a few people is that they would like to be able to choose this particular baseline. When comparing with lots of other data sets, the baseline period can vary in different data sets, so people want to be able to select which baseline period they're using. For the user guidance, we know that people need things that are simplified, very simplified for non-experts. People are looking at needing video tutorials and use case reports. They're interested in training to be able to integrate these systems into their model workflows, how to interpret the information and handle uncertainty. So we're delivering these through a microsite that gives really high-level information on the service. It gives summary graphics that really synthesize our workflows in a readable way, and flyers as well that we can hand out at engagement events. Click. I'm stuck. There we go. We're also going to be delivering Jupyter notebooks to enable people to access and process the data sets themselves. We're building web app walkthroughs, and we are analyzing people's experience through Google Analytics and Prometheus, so we can do that, see where those people are clicking and how long they're spending on different pages in different parts of the apps. And we'll also be providing detailed user guides, both as PDF manuals and in the C3S knowledge base. I won't go into this in detail, but this is a vague timeline of the project. What the key points are that we are delivering things in a sort of 6-monthly cycle. And that the web applications are being updated continually. So do keep checking back as they are building all the time, and give us feedback on things if you think you have some improvements that we could make. We're delivering workshops with our use cases, and those use cases will be published next summer, and everything's due to be wrapped up by January 2028. So yeah, just to summarize, the C3S water service is providing a consistent, centralized system for decision-making in the water sector now and in the future. Thank you very much.
Thank you very much, Katie. Very great to see this development. And the user requirements bit also nicely connects to the next session. So we will hear more about that. Let's see if there are questions. Anka, please.
Thank you. About the seasonal forecast, I was wondering, I didn't catch how many inputs you have from the meteorology of the seasonal forecast. I saw a lot of hydrological models, but...
Yep. So we are working on developing a multi-model seasonal forecast input to the multi-model hydrological inputs as well. So we're starting off with the CMCC forecasts, and we will be looking at C5, C6 when that comes out. And then we're a bit uncertain as to how many more we will include, but it's something we're discussing at the moment.
So that's still pending the discussion we mean to have about this. I had a look at the website, and all I could see is reference to C6, which actually hasn't even started to be produced, let alone give you any real-time forecast. This would be a big challenge.
The forecasts that are up on the website at the moment are based on the CES5 system, but we're looking into improving that and having a multi-model input for the next data set.
Thank you.
Okay, next question is here in the front.
Thank you. Really interesting. Actually, I was about to ask the same about, as Aska said, about multimodal. My other question, I see for 2027 is activity on producing reforecast information. So are you planning to produce a skill assessment on river discharge? Okay.
Yeah, absolutely. So we'll be looking at skill assessment, and there'll be both the seasonal forecast apps will show both uncertainty in terms of that multi-model ensemble range and the skill of each of the models according to the reference period. And then we're anticipating to have point data available so that you can verify the skill against actual odds as well at certain points in the world.
Okay, great. Looking forward to it. Thank you.
Thank you. Then we have a question here. Jonas?
Thank you. Thanks, Katie. Quick question. When you did the user research, how did you avoid asking, do you want this and do you want that? And everyone's like, everything. Like, how did you avoid that?
The question is, have we avoided that? I'm not sure. Yes, the answer is typically yes, we want everything. Although I have found particularly with the Sava River Basin Commission, we have a lot of really high-level policy-making people that have been engaging with us, and they really don't want everything. They want really simplified information, and they have got quite worried about very complicated data access and making sure they're getting the data in the right way. They don't want to download massive data sets. They want it clipped to a certain area. So there is a range of needs, and we have a lot of users. We will have users at a very high policy level and users like yourselves as well that are scientists who want to get into the nitty-gritty. So it is a real challenge making sure we provide all the guidance and meet the needs of everybody at that broad scale. But yeah, we can chat about it more if you want.
Okay, any other questions? Not the case, then we can... there's one. You have a minute?
I am here for the rest of the week.
Oh, otherwise you can approach Katie in the coffee break.
Okay,
maybe
then
quick one.
Maybe just more like a comment. So very nice to see all these kind of user requirements, and from now on we will see that much more of that. And there is also kind of a contractor standing behind for collecting user requirements. So just as a comment to be aligned with the other contractors.
Yeah, well, I think it's Wageningen are working on it, and they're working with us, so we are very well aligned.
Okay, thank you again, Katie. Then we move from water to energy, and the next speaker is Aaron Zuiker. He's a system model specialist at ENSO-E, the European Network of Transmission System Operators for Electricity, and he's actively driving the broader rollout and adoption of the Pan-European Climate Database developed by C3S across the energy sector. So please tell us more about that.
Yes.
Thanks.
Thank you very much. Just raise this. Thank you for the introduction, and also thank you all for the invite and for being here. So, like André said, my name is Aaron Zuiker, System Modeling Specialist in ENSO-E. And I'm here to present to you today about the next generation data set of climate and energy indicators across Europe, or as some of you might know, the Pan-European Climate Database. So before diving into that, I just want to take a bit of your time to first explain to you who ENSO-E is and what exactly it is that we're doing before I will show you how we are benefiting from one of the C3S products. So ENSO-E stands for the European Network of Transmission System Operators for Electricity. So that's a whole mouthful, even longer abbreviation than ECMWF. And we are essentially a members organization. So the members are what we call the Transmission System Operators for Europe, or in short, the TSOs. And these are the national companies that are responsible for essentially for the power grid of Europe. So making sure the power can flow from A to B, making sure that the demand and the supply of power is in balance at all time to make sure that the light can stay on. At the moment, we have 40 member TSOs from 36 different countries, with the latest member that joined being Ukrainego, which is the TSO of Ukraine, which also joined joined in 2023 after the country was connected to the rest of Europe. So together, it's quite a big power grid to manage. You can see here some figures. So in total, our members, they manage more than about 500,000 kilometers of transmission lines. So these are the sort of the large cables that you see in the large towers when you drive across the highway. Serving all the European citizens. So it's important to know that this is one big interconnected system. So the power doesn't stop at the country borders. Which means that also disruptions in one part of Europe can be felt on the other side. But it also means we can help each other out. When one country has a deficit of power, we can send power to this country. So managing all of this requires a lot of coordination, not just for operating the current day system today, but also requires a lot of planning looking at the future, because we have a large exercise to do. We have to build the net zero system of 2050, which is already ongoing, but a lot more needs to be done. And in order to do so, we need proper coordination on the European level. So the way we do that is by conducting a series of different studies. Might be a bit hard to see the names, but I will take you through them. Let me start with the one in the middle. So the one in the middle is called the European Resource Adequacy Assessment, or in short, the ERA. And the ERA is a sort of power system development study that looks ahead at the next 2 to 10 years ahead. So what we do is we try to, we basically model the entire European power grid, all the assets, all the transmission, all the load of the system. We run plenty of different scenarios, so it's a large computational effort. And what we try to do is we try to identify what we call adequacy risks or adequacy concerns. And an adequacy risk is when the demand of power cannot be met by the supply. So there's a power imbalance, which can ultimately lead to power outages and maybe even system-wide blackouts. So this is obviously something we have to avoid. So the ERA helps to identify these risks, and which will then leave still enough time for intervention to address the issue. We do a similar exercise for the seasonal outlook study. So these are at the bottom. So we have a summer edition and a winter edition. Here it's the same exercise, but we have a bit more certainty because we're looking ahead at the next 6 to 7 months. So we know more about the actual sort of generation fleet of assets that will be there. We know better which large power plants will be under maintenance. And we can also take into account the current geopolitical situation. As you can imagine right now with the energy crisis going on, it's very relevant to have a winter outlook study that looks ahead and see if we can make it through the winter without too many issues. So that's what the seasonal outlooks do. So both of these studies look at what we call adequacy, but we also have a study that looks ahead at the next 10 to 30 years. So this is the 10-year network development plan, or in short, the T1P. And the T1P basically helps us to make decisions on grid infrastructure projects that we have to invest in. So what we do is, again, we try to build the systems for the power system for the year 2030, 2040, 2050, based on our best estimates and from our members as well. And then we take proposed projects from third parties or even the members themselves, and then we model them, we model the power system, and then we see how society benefits from these projects. We also try to identify the needs, so maybe no projects were proposed, but we want to see, okay, where is the biggest need for grid reinforcements. So I don't think I need to tell you the relevance and importance of high quality climate data, but I want to stress that all of these studies, they heavily depend on having the highest quality climate data. As you can imagine, the demand for heating, demand for cooling directly depends on the weather.
the amount of generation that we can expect from renewables as well. But even the functioning of more traditional thermal power plants also directly depend on the ambient conditions. So this is all the case for the current day system, but in the future this is only going to increase as the share of renewables will continue to increase, also driven by the increased electrification of the demand as well. So on top of that, as you all know, climate conditions are not static, so it's also quite difficult to have proper projections for the future. So this is something that we were definitely struggling with within the power sector. Luckily, this is something that C3S excels in. So some years ago, they decided to develop the 4th version of the Pan-European Climate Database. So the Pan-European Climate Database that we're using at the moment, version 4, has been developed and maintained by C3S and has been published 2 years ago. So for already the last 2 years, we are using it for our studies. And it's a sort of coherent database containing both climate and energy indicators for both the historical periods based on ERA 5 reanalysis data and also includes projections all the way to the end of the century for a series of CMIP6 climate models and also for 4 SSP scenarios. So now this data set allows us to sort of model different projections of climate pathways and has really become a critical backbone in the studies that we do. So a very important part of this climate database are the energy variables, and these have been developed by a consortium of climate and energy experts led by ICS of Inside Climate Services in the last 3 years. Maybe that still sounds a bit abstract to some of you, so here's some more technical key figures. As I was saying, it both comprises of historical data and projections. The historical period starts in 1950 all the way up to present values, and also keep on being added with the latest data as well. And the climate projections, they start from 2015, going all the way up to the end of the century. All of this data is available for 6 hand-picked CMIP6 climate models and for 4 SSP scenarios to really have sort of all the probable scenarios in those studies as well. As I said, it contains both climate variables and energy variables. So with energy variables, I mean capacity factors for different wind technologies, for different solar technologies, and also hydro production, so inflows and generation data as well. What's nice is that the entire data set have also been validated by our members, so they have national data with which we could compare the sort of the results. So we know actually that the results are realistic as well. Everything is available on hourly resolution, except for some hydro technologies that are only there on daily and weekly resolution. We have the gridded data, but we are using more different types of spatial aggregations. So we have it on country level, sort of tailored PCD climate zones as well. And most importantly for the energy sector, we have it on bidding zone or study zone level, which is a spatial aggregation term we commonly use. So we are not, ENSWE is not the only one using this data. So you can see here many of the logos of our members, because all the members, they are also conducting their own national studies. So we do it on a European scale, but the members, they model it in more detail for their own countries. So most of the countries in Europe are also now using the PCD for their power system development studies. Another organization I want to highlight is MET-TSO. So you can see there on the right next to ENSWE. So MET-TSO is sort of the ENSWE equivalent of the Mediterranean region. So here it's again a members association of all the Mediterranean TSOs, including TSOs from south of Europe, Northern Africa, and also from the Middle East as well. I just want to say this is just a handful of the logos I could fit on there, but I know many more TSOs are actually using this data as well. So this is my last slide. I just want to say that any good data set is one that keeps on being improved. And therefore, I'm very happy that C3S has decided to continue to work on the Pan-European Climate Database for at least another 3 years. So I'm excited to just briefly highlight some of the new things that we can expect in the next 3 years. So the first one is geographical expansion. I already mentioned MET-TSO and that they're also using it for their own studies as well. So we want to also include the entire Northern Africa region and a large part of Middle East as well. So the entire PCD is going to grow in size as well. We also want to further improve the what we call the energy conversion models. So in particular for hydro, which is now based on a statistical model, we want to expand with having an actual physical hydrological model. And we're very excited that we're also going to collaborate with the C3S water server, so from Katie's presentation. So we're very excited about that. And we already have a sort of a prototype hydrological model developed by ICS, from which there's also a poster outside that I definitely recommend to have a look at. And this hydrological modeling allows for more sophisticated modeling of the more advanced hydro systems that we see in Europe today. Yeah, and also we will be further improving the wind modeling. So at the moment, what we call large-scale wake losses, so the wake losses that occur between wind farms are not yet included. And we know this is actually quite an important factor to take into account. So that will also be added later on. And also we'll be further sort of fine-tuning the solar models to account a little bit more for country-specific differences. We will also be adding more indicators, so we want to add an energy demand indicator. So within NSOE we have our own methods of modeling the demand, but we also want to provide users the ability to have an actual demand indicator coherent with the rest of the data set. Not all the current variables are yet available on gridded level, of a gridded scale, so we will also be adding the remaining indicators as well. And finally, we'll be adding more sort of tools that will help the users to more easily engage with the data as well. So think about new visualization tools, additional Jupyter notebooks, and also a climate year selection tool that will help you or the users to find the climate conditions that they're looking for. So I hope you got a bit of a better understanding of the Pan-European Climate Database and how the power sector is benefiting from it a lot, in particular the TSO community. So thank you very much.
Thank you very much, Aaron. So for those of you who thought ECMWF was a long acronym, just look at NSOE. No, but just kidding. We are very happy about this collaboration that we have with you guys. And it's one of those great examples where climate services can feed into critical decision making. So really good to see that example. Thanks. Other questions for Aaron? Yes. Microphone is coming. Please.
Hello, you mentioned that you used for the climate projections 6 GCM models. I was just curious, working here in the water sector, how did you select those 6 GCMs, or how are you planning to add more, or how does this selection process work?
So very good question. I mean, I was not the expert making the choice in those models, but from what I know is I think they selected them from having a look at all of them. And these were the ones for which the variables were available for the time periods that we're looking at. And also they were sort of different in each in their own way, because what we want is to include some sort of variance in the different scenarios that we take into account. So we looked a bit at the sort of the highest scoring models, but that's the models that still had a very different approach to get that variety in there. But for the actual details, I would need to forward you to the expert that made those decisions. Yeah.
Thank you. Okay, you can find Aaron also in the coffee break for further discussions. We move on to the next presentation. Thank you. So we move then from energy to agriculture, the last sector we will be looking at. The presenter is Santiago Begueria. He is a senior investigator at the Spanish National Research Council, and he will tell us more about the operational agriculture service and how they will build this information system. Thanks a lot. Please, the floor is yours.
Thank you. Okay, so we've heard about water, energy, so I guess moving to food is like the logical choice, right? So for the next minutes, I'm going to present you mostly the plans for this new service, this new Copernicus climate change service for agriculture. As you are well aware of, feeding a population of about 10,000 million people is going to be one of the biggest challenges for humanity for the second half of the 21st century. And of course, you are very well aware of that agriculture, in particular, is one of the sectors mostly affected or reliant on climate and weather. That's not a surprise, right? One of the most important assets for agricultural systems everywhere in the world is climate stability and predictability. And this is precisely one of the things that are mostly challenged in our current scenario. So it's no surprise that everyone in the agri-food sector is usually very well reliant and looking at climate, weather data, climate information, etc. But it's also true that there is a gap, and there are not many tools that are specifically tailored to these actors. And this is precisely the gap that this service wants to close. So the main goal for this service is to establish a new and next generation operational climate service tailored at agriculture. So to translate basic climate and weather data into actionable science-based information that is most relevant for the actors in this sector. And since the project has just started, I don't have any results to show you yet, but I can talk a lot about our plans, and that's what I'm going to do for the next minutes. So this new service is based on 4 legs, on 4 main principles. One, of course, is a strong climate data foundation, but we want to go one step further. So there's a lot of climate data already available, but none of this data is specifically tailored to the agricultural sector. So from the raw climatic and weather data, we want to go to agroclimatic indicators. So the first thing for us is to decide on a set of agroclimatic indicators. I will talk about that more in detail later. So a set of agroclimatic indicators which are based on the best weather and climate data available at different scales. That's our first objective, create this data set. Second objective is to allow users to interact with this data set using different tools and services. There are different users. Each user has their own goals and their own skill sets. So we need to offer them different ways of accessing the data and interacting with the data. And the fourth principle, which is very important for our service, we have heard about that in the previous talks as well, is a co-development. We cannot develop a service for users without having the users in the team. Okay, so co-development since an early stage of the development of the service is a very important core principle for this service. So for the next slides, I'm going to go through all these 4 legs in more detail. And the first one is the climate data. So for us, it's very important that the service covers the different time scales that the climate service requires. Okay, so most important is, of course, near real-time monitoring. This provides the users with information about how well or not well the current season is going for certain crops in different areas. So near real time. So that means operational. Okay, We are, so all the examples that I put here in these yellow tables are tentative because we are still deciding on exactly the data sets and the update cycles that we are going to work with. But so this is a preliminary decision, okay? But having near real time, the closest possible to real time is a key for this sector, and this is a key objective for this service. Of course, in order to determine whether current conditions in certain areas are good or bad, we need to compare with the past, right? So having a good historical data set that allows us to compute climatologies for the different climatic indices is very important to also cover this time scale. And this service needs to have also incorporate seasonal forecasts information. We're still deciding. We want to go multimodal, but of course this is a challenge. We are still deciding which models will go into this component. But seasonal forecast is a key component for most actors to decide on current operations for the next season. Okay, and of course finally client projections is also key for strategic and adaptation planning. So the idea is to cover the whole spectrum of time scales with different data sets, as you can see there. Okay, and this is maybe a difference, a key difference between this service and other current data sets that already exist, such as Agera 5. You're probably aware of this data set. We are intending to focus on a set of agroclimatic indicators. Okay, so these are compound indices which are based on the raw basic climatic and weather variables, and which are agronomically interesting or relevant. Okay, these indicators are usually have a cumulative nature, so they accumulate over the growing cycle of a crop. So they are not crop agnostic; they are crop specific. And this is a huge challenge because each crop has their own crop calendars, which differ by region and even between one year and the next. And also, each crop have different biological thresholds of vulnerability. Okay, but this is the type of information that the sector is demanding. So it's a big challenge to go from crop agnostic to crop specific and phenologically aware indices. And we are studying different ways how to do that. Okay. Also, another challenge is to go from single stress to compound stress, because these type of compound stresses are more and more frequent and more relevant for the sector. Okay. So, as I said before, this set of indicators is a prospective. This is a proposal that we have made, and we are now trying to refine this list in collaboration with the end users. So everything that you see here is just tentative. Okay, I see people taking pictures. That's very nice. But this is tentative, and I would like you to help us complete this picture later. You will see there's a slide for you later. So it's very nice to create a data set with a lot of indicators and so forth, but how we make sure that users engage with this data and uptake this information. So it's key to develop a set of interactive tools that are tailored at different users. So of course we will develop a data processing pipeline. Is the same pipeline we're going to use to process all these data sets. So this same processing pipeline will be available for anyone to use. Of course, there will be a data set incorporated to the C3S, but there will be a web application tailoring a universal target of users, which would allow people to explore the data set and maybe perform basic analysis, like comparing with climatology, comparing current situations with climatology, and so on, so forth. And we will have a zoom-in version of this web application focusing on the Mediterranean, because there are a few more experimental or more extended functionalities that we want to try, and we have to do it in a smaller version because it's impossible to target the whole globe for these experimental things. And for the most advanced user or more technical, we are going to release a series of Jupyter notebooks, similar scheme to previous services we've heard. So the idea of these Jupyter notebooks is to allow people to compute their own user-adapted agroclimatic indicators. For instance, I have a particular crop, and I know that my particular variety of barley, for instance, is more stress tolerant than the average. So I want to use my own heat stress thresholds. I can do it using one of the Jupyter notebooks, for instance. And then the system will also release automatic bulletins, automatic reports, which will which will highlight anomalous conditions which might be raised in certain regions, and who will also give the prospect evolution based on the seasonal forecast in those cases where forecasts have shown some skill, okay? And finally, people would be able to log into the system and create their own custom reports. If I'm just interested in one specific region, or I'm just interested in, I don't know, in vineyards, I can create my custom report by logging into the system. And of course, we will also generate impact stories and, outreach and demonstration material for the different users. And going to the fourth leg of the service is co-development. So for us, it has been, so it's very clear that we cannot build this system without the users. So we are having the users into the development of this service from an early stage. So we are now in the first stage of gathering the requirements in terms of which indicators are most relevant, what time scales, spatial scales, what type of tools, etc. But we also want to have them participating in the interface design and validation of the systems once we have first prototypes. And if time is available, we would like, once the service is released, we would like to get feedback so the system can be improved during this contract or in the future. And for that, we are creating 4 specialized different user panels focusing on different topics. So there's going to be one panel on requirements and indicators. A second panel will focus on functionality, tools, interfaces, and so on. There will be one panel focusing only on in the Mediterranean demonstrator, because the type of questions we want to address with this Mediterranean demonstrator are different. And finally, we want to have a strategic advisory board, or a key users board, I would better call it. So to offer high level guidance. And what is the roadmap? Well, as I said, we just started 6 months ago, so we are in the design phase and requirement gathering, and in upcoming 2 years we will develop. This is just some of our team members are here in this assembly these days, so if we see each of us, you can freely ask any question that you have. And well, I need to finish. Just one question for you. You are free to register. Just scanning this logo, you can register. If you are interested in just joining our user panels or just answering a few questions, so we can collect information and we can hopefully include you in one of our user panels. So thank you.
Thank you, Santiago, for another fantastic presentation. We have time for a quick question before we break for coffee.
30 seconds.
Jonas.
Thank you. Very quick one. So I suppose there's a lot of money in having accurate information for farmers. So why has this not been built yet? Why is this service not available yet?
That is a good question. That is a good question. Maybe it's not for me. But as I said, so we made this review of literature and current systems, and surprisingly, there's no such thing. There are a few things, and mostly national services dealing with it, but there's not a global system. And my impression is that the biggest actors there, which are the biggest, the largest food retailers and agro-food industries, they have their own departments dealing with that. But it's the more grassroots people who really don't have a way. If they don't have the technical ability to get the raw data and process it, they don't have any information there. So I hope that this will fill this gap.
Thank you, Santiago. We have to break for coffee, I'm afraid. Very quick one here, okay?
Thank you very much for the nice presentation. I have just a fast question. Do you consider to create an agriculture warning system from this data? Thank you.
Warning system, okay. Well, since the system is going to be operational and it's going to highlight those situations that are anomalous compared to conditions like the climatic conditions, climatologies, I guess you could call that a warning system. But I would be careful because, as I said, each crop in each region has different crop calendars, and cannot know everything. So on the first step, we're going to use standard crop calendars, but we cannot know exactly what people did that year. So in a sense, yes, I think this would be like a warning system, early warning system, but I'd be cautious.
Okay, thank you, Santiago. That concludes this session. Thank you. So we will break for coffee now and reconvene at 4 p.m. Thank you all very much.
show your color, fly. Fly with the wind, let the wind take you flying high. Fly, butterfly, butterfly, and a butterfly. That's why a butterfly moves its soul. Fly, butterfly, spread your wings, show your color, fly. Fly with the wind, let the wind take you flying high.
Look at all the lonely people. 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 Eleanor Rigby picks up the rice in the church where a wedding has been. Living a dream, what's out the window? Wearing a face that she keeps in a jar by the door. Who is it for? Oh, the lonely people. Where do they all come from? Oh, the lonely people. Where do they all belong? Father Mackenzie, writing the words of a sermon that no one hears. No one comes near, look at him working. Down in the socks in the night where there's nobody there. Why does he care? Oh, the lonely people. Where do they all come from? Oh, the lonely people. Where do they all belong? Look at all the lonely people. Oh, the lonely people. Look at all the lonely people.
Hello. Oh, I'm live. Hello, hello, hello. Welcome back. I'll give you a few minutes to filter in before we make a start. It's there's bright lights in my eyes. I don't know if it's possible to turn it down a little bit. But it's quite good because I can't actually see the audience, so that's fine. Fantastic. I will make a start because having the graveyard shift on after a long day is always quite a challenge anyway. And we want to make sure we finish on time so everyone can get back to their hotels, refresh, and get to the social event this evening. So, excellent. Well, this is the first session of the third block of the agenda. And now we're deep diving into building upon the operational data and bridging the link between climate information produced by C3S and ensuring decisions and impacts are being realized on the ground. In this session, we introduced two core components of the C3S ecosystem: the National Collaboration Programme, the NCP, and the user intelligence activities. And they're the activities that are gathering the needs and requirements from the C3S user community to support C3S evolution. Some housekeeping to a half-empty audience. Firstly, we do have space for discussions at the end, and indeed there's going to be a roundtable discussion. But in the interest of time and making sure that the questions are relevant, we will take one question after each of the presentations. However, I don't want to limit just the discussions to the stage, and I will throw the floor open to anyone on the floor. So please bear in mind that we're going to have a roundtable, and it's going to be about the challenges and bottlenecks in C3S. And we're not just talking about data publication in the CDS, that is obviously a bottleneck, but we're talking about some of the big grand challenges that C3S could face. Right, my slides. I will crack on. I'm the first presenter, and I'm going to introduce you to the I was going to say sectoral information systems. I don't do that job, and I haven't done it for quite some time. But the National Collaboration Programme. Now, the National Collaboration Programme has probably been mentioned 15 dozen times since the beginning of this NCP, and it's becoming a more and more visible component of C3S. But I don't think there's anyone really actually introduced the NCP in any meaningful detail, talk about what it is, what it isn't, what it aims to be. So the NCP is there to support countries with policy-making decisions, planning, climate adaptations that really do take place on the local scale. Whereas the C3S is there to develop operational, high-quality climate information. And the NCP is there to translate that information, bring it into their national ecosystem, combine it with national data sets, expertise, know-how, links with partners, and build upon C3S. And the idea of the NCP is that we bridge C3S data to local applications and make informed decisions. And the NCP is really a collaborative program. It's not just C3S telling you what you should or shouldn't be doing. We learn from the community. We understand, hopefully understand the needs and requirements and respond in calls, workshops, forums, and make sure that we really do understand each other and rise at a common understanding and have a mechanism in place to realize progress. And I think member states are far better positioned to go the last mile and deliver local services than European service providers. Again, as I mentioned, they have better relationships, understands national priorities and gaps in current provision. They have the relationships with end users and key stakeholders that make these applications viable. And they have the ability to use local languages and communication channels to increase uptake of climate information. So the first slide. And this is supposed to be an image of Carlo, which I think is a little bit more useful than perhaps it quite is now. But anyway, it's really a visual representation of what AI thinks the National Collaboration Programme is. And it's really a handshake between C3S and national service providers to enhance the usability, increase the usefulness, and promote the actual use of C3S products and data services. But the National Collaboration Programme is also there to promote the C3S brand, make sure that it's visible not only on the European scale, but at the local and national scale. But the NCP is far more than a funding mechanism. We organize NCP forums, which are half-a-day workshops. We have expert workshops. We run bilateral meetings with member states, but we also fund projects. At the moment, we've had 5 NCP forums, and the last forum that took place yesterday had over 95 registered participants, which is fantastic. And as of today, we have 28 funded projects as well. So I'm going to dive into these in a bit more detail. So as of this month, we've just launched 17 new projects. And these are a result of the first round of open grants that ECMWF released. And these are designed to allow users, the member states in this instance, to develop their own IPR and keep their IPR. And it's a much more appropriate funding mechanism than the contracts where we keep the IPR and the results. So the blue is the NCP status of the map of the projects of 2024. And the nice burgundy color shows the proliferation of the number of projects across Europe. And you will notice, you know, an increase in coverage. What is important to say is that the NCP is not a geo-return mechanism. It is based on excellence and realizing impact to develop solutions for the local scale. And this 2026 call was based on the needs and requirements from the member states, as gathered through the bilaterals and the NCP forum. And we introduced 3 new actions. So an action on transboundary cooperation, where more than one country can work together with their neighbors to address transboundary challenges. Action number 4, transnational capacity building through twinning, where one country with mature climate services can develop ones to support another. And here we can impart knowledge from one partner to another country. And this really does develop the ecosystem of climate services at European scale, and it allows countries to improve their climate resilience through working together. And the 5th and final action is learning and education. And this is where we inspire the use of C3S products to inform the next generation of climate practitioners and climate literacy. So the NCP is underpinned by 4 universal pillars. These are promoting communication and outreach. That's with stakeholders, it's with users at the national scale. All C3S NCP projects should promote the use of C3S services, which is very obvious. But the third pillar is impact. All NCP projects should realize and impact. And this is impact over the status quo of what was previously possible. And the 4th important pillar is sustainability. We're not aiming to just fund research. The idea is that we fund operational services, or at least have a vision to develop operational services at the national level. So before this, a few weeks ago, we thought it'd be a good idea to actually send out a survey to the first round of NCP projects, with the idea of actually realizing to see if they're actually developing impact, improving communication, improving uptake of C3S products at the national scale. And the results are really encouraging. So we've got a very strong signals that the NCP are actually meeting the needs and requirements of the program. So they are improving communication at the national level. And we have many of the projects actually significantly improving communication at the national level with stakeholders to improve making nationally relevant applications. And for us, it's really important is to show that 63% of the projects actually show significant uptake in C3S data. The other important aspect is to make sure that we're funding sustainable services. So 88% of the projects, 7 out of 8, are expecting to be sustained beyond the periods of the funding, which is fantastic. But obviously these depend on integrating with national infrastructure and making sure that the member states have sufficient resources to continue. So it's a very nuanced picture, but the signs are really encouraging. And the next couple of slides will be me talking, but after that, there'll be some case studies from SMHI, and we really want to show how the NCP is promoting excellence in terms of communication and outreach. And then we'll have an example from Vito looking at innovation and impact that's being realized. And the final NCP presenter will be Kinga from Poland, who's going to be introducing the transnational aspects of the NCP. So a few takeaway messages. The NCP so far is proving to be a valuable vehicle for actually demonstrating sustainable, long-term, user-orientated applications that really are tailored and specific for the local environment they're intended. And this is fantastic. And I think this is really encouraging news because we've just launched 17 new projects. So if we can replicate this 28 times across Europe, it will create really tangible impact going forwards. Okay, so Peter, the floor is yours.
Thank you very much. And this is not my talk yet. So, we start with a bit of a Swedish lesson. I'm going to present klimatläget, which essentially translates to state of the climate. And this is a small contract where we have been working with our climate communication at SMHI. And as national authority, we are producing climate information for Sweden. And when communicating climate change, it's important to have a broader context of this. And with only data for Sweden, it is very difficult. So here we wanted to make use of C3S data and the nice graphics and applications there to kind of give that context together with our national data. So we have created a set of web pages where we present key information about climate change and build in these interactive graphs and make it more attractive and approachable. So we are writing explanatory texts about what's the climate situation and different aspects of it, and mix in different videos where we have our professors and experts describing different aspects of climate change. And then we build in these interactive diagrams like the climate pulse and so on. And then we promote it through social media to keep active and highlight different aspects of it, to get people to join and look at our pages, of course. And we also have different user feedbacks and surveys to build our service to make sure that we reach the ones that we want to reach. So examples of the content we have built in. So we have, for example, the diagrams from climate pulse of the global mean temperature, which we have then taken the information behind the apps and we need to rebuild it to have Swedish language and to make sure we have the accessibility that we need for our national requirements. And then we have also the globe to have the maps of anomalies of precipitation, temperature, and sea surface temperature, which is a very powerful way to show a better context of the current climate situation. So if you have a cold summer in Sweden, then some people will directly start saying that, oh, there's no climate change. But then we show that all Europe is very warm, and that's much easier. If you only have diagrams of Sweden, it's very difficult to tell that story. And of course, we use the C3S Atlas as well to show future projections and explain the different emission scenarios and what needs to be done to fight global change. And then we also have monthly, the last month in review. So we look at, so our forecasters are presenting a bit what happened in the last month, and they also use these kind of diagrams to give a bit of context and some international outlook also on the current situation. And then we pick up things that are happening and put social media posts and link to different parts of these pages to learn more about that topic and so on. When we launched this, there was a lot of interest from media. We got, I think, because of the nice graphs and the visual content, it was picked up in TV for the main news networks, and we got a lot of positive feedback also from other national agencies that, well, finally you're presenting this clearly and interesting and really enthusiastic about this, these pages. We got a lot of, in Facebook, a lot of positive comments, and as you can guess, a lot of negative comments, a lot of skeptical comments that we need to deal with as well, spending hours and hours answering these topics, which also made us add extra pages of presenting common misconceptions about climate change, that we can more easily point to those and say, but we don't have to answer from scratch every time, but we can show those pages. Also a lot of positive feedback when we launched those pages, and also a lot of negative feedback. Before, when we presented our main messages about climate change, a lot based on IPCC reports, there was, I admit, quite dull pages, and we had maybe 45 visits per week to look at those. So, but with this contract and with this new revamping of the web pages, we got a lot of attention, of course, in the beginning with the launch, but we also stayed at 1,000 visits per week, and we're increasing also by pushing through social media and having the interactive graphics where you can come back and see how weather climate is developing. So we have now we are now at the end of this contract, but we have brought this into our regular maintenance at SMHI and planning to also build further on it. So you can look at the web pages on this link and learn some more Swedish there as well. Thank you.
And hello, I'm back. So that's fantastic, and I think it's really good how we're building upon the climate intelligence activities and the approach that C3S has done and contextualize it in the national languages. And I think the increased outreach and the audience and visibility of C3S is really tangible there. So thank you very much. Is there a question from the floor before we move on to the next presenter? You're off the hook. Thank you. Thank you. So next up, we have a case study from Belgium. So Nelle from Vito will be presenting the Belgian case study, so how they've developed I won't go into it because actually it'd be a spoiler, but anyway, it's developing and building upon excellence that's being realized in innovation, but also making sure that the NCP output is sustainable after the project ends. So thank you very much.
Thank you. Okay, good afternoon. I will present in the coming minutes a climate service developed for Belgium that is integrating high-resolution climate information into health surveillance systems, more specific in systems that, that are aimed for monitoring and managing vectors and vector-borne diseases. Climate variables such as temperature and relative humidity really strongly influence the ecology of vectors such as ticks and tiger mosquitoes. These vectors affect the survival of these vectors and also the vector activity such as reproduction. and also the transmission of pathogens such as Lyme disease, chikungunya, dengue, all things currently known as tropic diseases. And the climate change is expected to increase vector activity and to expand the risk areas. Therefore, public health authorities like Cienzano, the Belgian Federal Institute for Public Health, urgently need timely, high-resolution climate information to support their surveillance systems and to also be prepared. Currently, the available data sets quite often lack the spatial resolution and also the timeliness in order to be used in an operational way. So there is really a gap between climate science and public health decision making. And in the project, we try to close this gap by collaborating with Belgian Climate Center and Cienzano, the Health Institute in Belgium, within the Copernicus Climate Change Service framework. And the ultimate goal of the service, the project we wanted to create, was to in the end, to deliver operational climate indicators that could support these public health authorities. In this slide, I have an overview of the architectural design of the service that we developed, and essentially exists in two workflows. And together, these two workflows, they provide daily high-resolution climate maps at a 100-meter resolution across Belgium. So together, they provide continuous coverage at a high spatial resolution and with operational reliability. So let's dive a bit deeper in the top row, in the first flow of the service. This flow uses Copernicus Era 5 data, and it combines these data with AI-based downscaling. The AI model that is behind is a 2D neural network that is trained with URBClim simulations. URBClim being an in-house, in vitro developed urban climate model that is fast, physics-based, and well-validated. So by combining this AI-based approach based on URBClim simulations with ERA 5 data, we can generate a daily map of relevant climate variables at a 100-meter resolution across Belgium. And then, as you probably know, the ERA 5 data come with a 5-day latency. So the Public Health Institute, they really need data until today, till yesterday. So they really want us to close the gap for these last 5 days. And that's why we developed this second flow. This second flow, as there is no ERA 5 data available, it doesn't start from ERA 5, but it starts from observations from the RMI, which is the Royal Meteo Institute in Belgium. So it uses observations from the Automatic Weather Station network in Belgium. And it uses these data to apply a regression-based approach. And this approach is nothing else than trying to identify a date in the past for which the meteo conditions were most similar to the day you're looking at, to today, to yesterday. So essentially, the output of this flow is a date. And what then happens is that we will run in the operational model chain, we will run this first flow again, making use of ERA 5 data for that specific day. So in that way, we can close the gap for the last 5 days, and we have a service, an operational service that ensures continuous real-time climate monitoring. So by combining these two flows, we create on a daily basis temperature, minimum, maximum daily mean, also relative humidity, minimum, maximum daily mean, precipitation, wind speed, wind direction. And that is the service we developed at Vito in collaboration with Belgian Climate Center and Cienzano. And there it actually stops for what we did. But then we handed over to Cienzano, and now it's operational in their infrastructure, and they run it on an operational way on a daily basis. And for them, the output this service creates is input for the services they already have in place to produce climate-driven indicators for vector activity. So before, they already had these services in place, but as an input, these relevant parameters on temperature, relative humidity, and so forth, they were taken from ad hoc projects. They were spatially low resolution, so now they really have it in a better way. So I think this is a clear, it's fair to say that the service really helps to translate climate data in decision support, because it helps health authorities to strengthen their surveillance systems, and it really improves preparedness for climate-sensitive diseases. So in terms of innovation, I think the most innovative aspects here are this AI-based downscaling, but for sure also this hybrid operational flow combining Copernicus data on one hand and observations on the other hand, and the fact that we made it as something that could be transferred to their operational service. So it really bridges climate and public health communities due to this direct integration into existing systems. Also important to mention, it's the last slide, is that this approach, it's now operational at Cienzano, but it's highly transferable. So we see a lot of options. We could easily apply it in other countries. It could be used for other vector-borne diseases management, but also for other heat health issues and other sectors as well. So thank you.
Thank you very much, and it's a really good example to see an operational service coming out of the NCP so early on. So is there a question from the floor? Carlo.
Thank you for the presentation, really interesting.
Thank you.
My question is about this combination between the model and the observation. And if I understood correctly, you do it to cover the last 5 days because the reanalysis is not available. Have you considered using the forecast from the ECNWF to fill that gap?
No, we didn't. For now, we really used it with the observations, because also it was about the connection with the National Institute, and that's the way, that's how BCC, the Belgian Climate Center, is involved. But it's indeed, so far we have, I didn't focus on validation here, but so far we have focused our validation on the first flow and the AI-based model. But now this, for the first tick and mosquito season, it's operationally running, and once we have quite a database, we want to compare the second flow as well, how good is it working, and if needs to be, we will adapt it, and then this forecast is a good way, yeah.
But the forecast is a really good opportunity for the forecast of ticks as well, so maybe that's something to explore in the future. Fantastic. So the last presentation in the NCP section of this block will be Kinga. And Kinga represents the Institute of Environmental Protection in Poland. And this is one of the first transboundary activities that we've been funding within the NCP. So, Kinga, over to you.
Thank you. Yes, hello, I'm Kinga. I'm from Institute of Environmental Protection, and as an example of international cooperation within the NCP projects, I'd like to show you the Carpathian Sudetan Transboundary Climate Assessment, which is the project that has already just started. We are in the month 1 under the Action 3, Transboundary Cooperation to Address Common Challenges. And we have a consortium of 4 partners, with us being the leader, Institute of Environmental Protection, and we also have 3 other institutions, and they are the National Weather Services from Poland, Czechia, and Slovakia. So why Kaszut? What's the climate challenge that we are dealing with? So first of all, there is a strong topographic variability in the mountain, and climate changes over short distances, obviously. But global and regional data sets are often too coarse and fail to represent properly complex topography or local climate extremes like convective precipitation and so on. But on the other hand, we have fragmented national databases across borders. So yes, river basins, forests, tourism areas, national parks, they all cross borders. But countries use different operational workflows, different operational grids, and different methodologies. So the three main challenges that we want to address in this project is that climate impact ignore borders, but data and adaptation systems are still fragmented. And also mountain regions face climate risks that exceed current analytical capacity, and this is both in terms of spatial resolution and range of national-only research. And decision makers need local scale validated climate intelligence, which we want to give them to prepare for them. So our response is to develop the harmonized high resolution climate data sets tailored for our mountain regions. And thanks to the international cooperation within this project, we want to prepare shared data sets, common methodology, and comparable risk indicators. How we works. So at the bottom of this slide, you have the project pipeline. And first of all, we, of course, use the C3S data. And in this case, it will be ERA5 land, SERA, and CMIP6 projections for future projections of the climate. And we want to validate it against national observation data set provided by national providers, which are our consortium partners. Of course, we want to validate with national observations, with satellite data, bias corrected, in order to produce some harmonized historical climate data sets together with extreme events assessment. And the second thing, having this, we will prepare a downscaling methodology, two approaches of the downscaling methodology in order to produce the high resolution future climate projections for our region. And having these two inputs, we will prepare the user-ready climate products, climate indices, sector-specific vulnerability assessment, which will support the adaptation planning. So we'll prepare the foundational data, and this will be the current historical data set and future data set. And also, alongside the data set, we'll prepare the downscaling methodology to refine the C3S data climate projections for our region, and advanced climate intelligence, which will be the sector-specific assessments and risk maps, which will support adaptation planning in those three sectors for tourism, biodiversity, and infrastructure in our Syden and Carpathian mountain region. So what we expect within the policy communication and outreach, we have defined the target users. We have already 2 ministries interested in implementing the results of our project directly into the national adaptation plans. These are Polish Ministry of Climate and Infrastructure and Slovak Ministry of Infrastructure. We have already also 10 NGOs and organizations interested in our project results. The numbers are written in brackets. These are municipalities, NGOs, national parks, and so on. We will prepare the multilingual communication, which is, I would say this is core, because the communication will be in 4 languages, in Polish, Slovak, Czech, and English. So it will be accessible for all the regional stakeholders, and prepare plenty of workshops and newsletter, online dissemination. This is all for our regional stakeholders to use and to adapt and to incorporate into their adaptation strategies, adaptation planning. We are quite confident that the operation legacy, let's say, of the project will be significant. And that is because, first of all, we have two ministries that has already showed their interest in implementing the project results into the national adaptation plans. And we also have 3 or 4 consortium partners which are national weather services, so they will implement or incorporate the project results or develop methodologies into the operational practice. So here is the list of all projects and adaptation plans and strategic adaptation plans of all 3 countries that the project results will be incorporated. At least that's what we know so far. And as about the scientific and institutional legacy of the project, CASUD is expected to enhance the scientific standing of the partner institution to reinforce, I'm going to the end, international collaboration and build capacity for future joint initiatives, and it will be made through these 4 main aspects: scientific legacy, institutional legacy, stronger collaboration between our institution and regional stakeholders, some future cooperation pathways, maybe by some future calls and bridge between users and Copernicus, and that all leads to a conclusion that CASUD will be a replicable model for other transboundary regions. Yes, to end with, so our region is climatically, environmentally, and socioeconomically interconnected. So together, we create not only data set and projections, but a lasting network working together on climate resilience. And all this wouldn't be possible, of course, without the transboundary cooperation. Yeah, thank you for your attention.
That's fine. That's fine. And it's one of those, it's brilliant. We could have talked a little bit longer, and I think it's great to have this transnational approach included in the NCP. So we've finished the NCP section now, and I would like to introduce Rutger and Natalia up to the stage, and we'll be from Wageningen Research, University of Research. And I do apologize for my Dutch. My colleagues have tried to get me to work on Wageningen for quite some time, but apologize, but over to you. Thank you.
Thank you. So yes, I will start and then Natalia will take over. So my name is Rutger Dankers. I'm from Wageningen Environmental Research and Natalia is from Wageningen University. I'm assuming that most of you are familiar with the concept of a climate services value chain and the notion that climate data and climate information only have value if they're being used by users and add value to the users and being used in policy or decision making. And often this then comes with the recommendation to do co-creation. But for a key climate service like C3S, this is also a challenge because C3S just doesn't have one user. It has hundreds, if not thousands of users. So you could also say it's not just one climate service. It's a collection of climate services or a community of climate services. So there's an opportunity there to add another C to C3S if you want it. So it's still important to listen to these users and see what they think is important and what are their needs and also the challenges that they encounter. That's why C3S has a user intelligence component or part where we collect user requirements. So what is a user requirement? So there's a definition there, but it's important to remember it's not just about technical issues, it's not just about data, it could also be about tools, it could be about guidance that people may need or changes to existing data sets as well as new data sets. Really with the aim of making C3S a user-driven service that takes the needs of its user into account in the evolution. So what's happening with these user requirements? So they're being collected in different channels, so more about it in a moment. And then they're being fed in a database. This is the user requirements database, where these requirements are being stored, analyzed, and then on a regular basis being reported to C3S and to the board, and then considered for further development or implementation And some of them will also be out of scope and then being left out. So it's hard to show a picture of a database, but this is how the interface looks like. It's a system where details on the user requirements are being stored and where they can be analyzed and reported. And we do actually try to collect quite a good number of details. So we also try to get an idea of who is actually making the requests, what does it relate to, what is the sector that it relates to, what's the sector that the user comes from, what's the geographical origin of the user or the geographical scope of the requirements, and so a few more aspects more. And this is very useful if you then later want to analyze and also group these requirements into sort of recommendations. So where do these requirements come from? We have a number of channels. The most important in terms of volume of requirements is the C3S user support. So this is the help desk. They are often approached by users, and if they see something that could become a user requirement, they report it to us. And the second most important is user interaction sessions. So these are workshops that we organize, and we had one yesterday with the Hungarian users. But requirements can also come from other sources, including the ECMWF forum or user surveys, and also in some of the contracts that you guys may be working in, you do surveys or you interact with users, and some of these requirements also are being fed back to the user requirements database. So this is just a picture of the user engagement session we had with the Hungarian users yesterday, which was a very nice event. And we had something like 50 participants, so it's quite a good number. But we have been organizing a number of events over the past few years since our contract started in several countries, including in Belgium, Poland, Spain, Czech Republic, Finland, and, well, this year in Hungary. We have also been organizing one transboundary session so far. We did that together with the Alpine Convention. And we have been having 2 workshops with DG Klima. So this is sort of a timeline. And just to note that we are still planning a few more events. So next week there will be an online session with the Drought Management Center in Southeastern Europe. So this is a collection of countries in Southeastern Europe focusing on drought. So that's happening next week. And then we're still hoping to organize a session with the Union for the Mediterranean at the end of this month. This is just a few numbers. Most of these events have been physical workshops, but a few of them have been online. And you can see there's actually a difference. So if you have an online workshop, you can attract a larger number of people, but as you can imagine, the interaction with users can become a little bit more difficult. So it's not necessarily so that if you have more participants in your event that you collect more user requirements. It can actually be more difficult to do so. Yesterday we had over 60 registrations, but in the end something like 45 to 50 participants showed up. And in each of these sessions we also try to ask a few people from the country or from the region to present a few use cases, so where they have been using Copernicus data for their own applications. And at the bottom you can see some numbers of user requirements that have been collected at various events, as well as the number of participants that we have engaged with in these events. So we have engaged more than 400 people, which I think is quite good. So who is actually coming to these events? We try to collect some information about the background. As you can imagine, there's quite a strong representation of what we could call expert users. So these are either people who themselves produce climate information or are using climate data to translate it into, for example, sectoral data or information. But we do actually see participation from across the value chain. So we also do see people who are working on, for example, dissemination in the media, or even from policymakers, etc. At the bottom pie chart shows the participants, the sector where the participants from yesterday's event came from. So it's a good mixture, most of them coming from research and education, but also from government, private sector as well. And we even had one registration from someone from the defense sector. So I don't know if that's a new market for C3S, but it's interesting anyway. Just a few examples of the sort of, well, it's not really user requirements yet that we collected yesterday, because we still have to analyze them. Not all of them may make it into the user requirements database, but quite often we will see people demanding or requesting things related to, for example, the access to data and the downloads. So again, that's also something that came up yesterday. People requesting new parameters to existing data sets, for example, snow water content or daily maximum wind gust information. People requesting more user support or training, especially for new users. It's very important that they get guided into the different products that are there, but also how best to use it. And again, a theme that often comes back is about ability to do spatial subsetting. Well, that's fortunately now available for many data sets. And often people also would like to see better resolution. So yesterday there was someone working on ecological applications, and they said it's really important for them to link vegetation patterns at a very high resolution to climate data. So they said something like 1 kilometer really is like a minimum for them, even if they would like with better resolution than that. And now Natalia will take over and tell a little bit more about the requirements that are currently in the user requirements database.
Okay, thank you, Rodger, and I'm very pleased to be here today and talk on behalf of our team at the Air Systems and Global Change Share Group at Wageningen University. So far, we have heard about how we collect user requirements, but then I'm gonna try to answer this question. When we bring all this feedback together, what are users consistently telling us? To answer that question, we're gonna have an overview of recent user requirements that we have collected from October 2025 till May 2026. In total, we collected 124 user requirements that were coming from multiple sources, highlighting the importance and relevance to merge and to have this multiple sources approach. So we got like a large contribution from the water service, which was presented from our UKCH colleague before. Also, very relevant sources for us, as Rodger already mentioned, are the workshops and the C3S user support. And we also get very important user requirements from the ECMWF forum and email. So we constantly monitor the forum in case there is any user requirement. When we look at the topics, we see the new data requests or requests for new parameters, new variables is the most common. We also get some requests related to other topics, such as the Copernicus integration or the restoration of deprecated data sets, as well as some user requirements related to the temporal spatial data coverage, communication, or usability and user satisfaction requirements. We see, based on this sample, that we have a diverse and international user community engaged across the climate services value chain. We see a strong representation of climate experts, as Rodger already mentioned, who use C3S data to create new climate products or to do some research or also for climate analytics. And then we also see a high representation, a strong representation of users from national institutions and research and education organizations, highlighting the importance of C3S for the national public entities, but also for the scientific community. In addition, we have an active participation from intermediaries, those users that use climate data or C3S data for sectorial decision-making and sectorial activities or operational activities. And we also found a good representation of commercial users, ranging from small, medium enterprises to large private sector companies working in energy, tourism, security, and innovation. Finally, in terms of geography, users come from across Europe and beyond, and with representation from multiple countries. And now going to the themes emerging, we might have different individual user requirements, but we group them in 4 topics or 4 main themes. One very common theme is related to data access and download. Same as Rodger already mentioned, users want multiple variables or datasets downloads. Users also have requested data in CSV or SAR format, which is great because in one of the previous presentations, the speaker mentioned that this is already happening, so that's amazing. Also, users would like to have access to the data via WMS or WFS, or GIS and Google Colab compatibility. And one of the most common user requirements that we collect is related, well, users always want easier access and the integration of the Copernicus data. In terms of the second theme, users constantly request for new parameters or data sets. Examples include radiation measurements, heat index indicators, drought-related products or indicators, and additional parameters in the ERA5 time series dataset. And the third topic relates to improvements in the API and the CDS interface. Users request aspects such as clearer error messages, local time conversion, the control over the output file name, and the file integrity verification. And the fourth topic is related to the spatial subsetting and resolution. Very popular. Users want the capability of data subsetting, the ability to extract small geographic areas, or the location-based data over all years, and the availability of data at the Node 3 level. And besides or beyond the themes that we already discussed, there are also some themes that are related to how users interact with the data. So the first theme is related to user support and training. Users request visible contact user support, a chat-based help desk, also an easier navigation in the ECMWF forum, or AI-friendly documentation. And a very popular request is related to beginners, tutorials, and Jupyter notebooks, which is something that is applicable to all the C3S tools and applications. And users also requested a learning tool that can serve for educational purposes. In terms of communication, users have requested better service update notifications, dataset lifecycle updates, and better visibility of dataset status and reliability, and better visibility of newsletters. And other themes that we have collected are related to reduced latency of some of the datasets, which is also something that was mentioned yesterday, and some restoration of datasets or ERA Explorer improvements. And to finalize, to conclude, I'm going to share 5 main takeaways from our project. First of all, well, C3S has a diverse user community across the climate services value chain. Second, listening to the users is essential, but not always straightforward, so that means that we need continued engagement and also better communication with the users. Users' needs range from very specific, detailed technical requirements to broader expectations that may fall outside the current scope of the C3S, require detailed evaluation. Fourth, we need multiple channels and innovative ways to capture diverse user needs. And the fifth one is the URDB, or the User Requirements Database, allow us the structured collection, tracking, analysis, and report of user requirements. The user requirements should remain at the center of how C3S evolves, improves, and delivers, so it can better respond to C3S user needs. And to conclude, we want to hear from you. So if you have user requirements or user needs, please scan the QR or also visit us at the booth. And if you are NCP focal point or a C3S contractor, we will be very happy to collaborate, to insert your user requirements into the URDB, so to contribute to continue developing the C3S as a user-driven service. Thanks a lot.
Thank you very much. That's fantastic. So in the interest of time, I suggest we park the questions. And the next presenter is Niels. So in his another hat, he works in the user intelligence activities, and he will be presenting user requirements, user stories, and future vision. Niels, over to you.
Somebody forgot the laptop here. Okay. Thanks a lot. That, yeah, another hat. That now I'm speaking on behalf of well the team. That it's not only me. That there's also Annabelle Menashe, and then there's André Obregon as well. That we are working all together on kind of picking up what the contractor is delivering to us. And then, so this is kind of the interface. So you have heard a lot about the user requirement database, where the user requirements being collected and being fed in, and here from there we are picking it up and bringing it into the systems to realize then the improvement of the service. You have seen that as well, and kind of this is how it looks like in detailing that by sources and subjects, and that what is in the user requirements database for the moment. This is kind of floating, that it's changing right now, since we are gathering user requirements here in the General Assembly as well. So once we are at home and feeding that into the URDB, these numbers will change, so that it's on a floating system. And then here, just for a bit of an example, a realistic example, that there are user requirements concerning ERA 5, and then after checking that, you are getting the implementations according to the needs of the users. And how does it work? Then internally, that we are selecting we are kind of analyzing the user requirements, where there's going to we're having a triage, and then or a clustering of that, and then we have monthly board meetings where the directors of C3S and service directors, and as well as also the representatives of the various sub-services are meeting together, or if there is a need for technical officers, that they are we are gathering together once a month and talking about specific user requirements or user requirement clusters. And then, depending on the user requirements, we're making decisions how to move forward with that. This is also not being made kind of out of the blue, but there is a kind of a concept behind, or a systematic behind, that if the user requirement is in scope or out of scope, or if that's possible to do, or it's not possible to do, so there is a decision tree in the background, and also kind of it's not only one person who is deciding that, but is a team effort and a discussion which is standing behind. And then based on that there is then the decision being made if the user requirements is going to be implemented. How also, that is it quickly, or takes it longer time, or is it kind of a long-term strategic implementation, etc., or we need to reject it and saying this is out of scope, or we can't do that. And just to give you a bit of an example of how it is looking like, that these are some examples, that a lot of that demands for data for sure, but then also it can be features, and all kind of requirements are being collected. So there is not really a limit on that. And just to be kind of very, very quick and saving a bit of more time, that is, we would like to extend that. So currently this is all within C3S, but we would like to extend it further. So here these are plans, or it's ongoing already, that we are extending that across ECMWF, so probably also having requirements which is touching the atmospheric monitoring service, or which is touching the ECMWF core services. So that is going to be built upon all the lessons learned that we have made, and extending this approach. Right, so that's what we are currently setting in place and building upon what we have achieved so far. And here again, that's not kind of just by nicely done, that we learned something, that we're doing that, but it is also embedded within kind of the European discussion. And currently there is an workshop agreement on co-production in place, a workshop agreement from CENELEC, it's the European standardization body. We are going to hear much more about that in the next talk. A workshop agreement is something like a pre-standard, to have a real protocol behind how to set co-production in place, and then user requirements is a part of co-production. All right, this has been done, or this is currently ongoing within a project which is called Climate Europe 2. We are going to hear more about that in the next talk. And then once the workshop agreement is being set in place, we are operating accordingly to that. And if you would like to put your own handwriting into all of this process, then I'm welcoming you to the workshop tomorrow. We are touching upon a couple of recommendations, also on co-production, fit for purpose data sets, a lot of aspects that we have been already touched upon. And yes, you are very welcome to join, to bring your own ideas into that workflow. And with that, I would like to hand over to Astrid. Thank you.
Thank you, Niels, and you've caught us back on time, so that caught me off guard that you were 5 minutes shorter than we expected, so brilliant, thank you. Next up, we have Asson Sinclair. So Asson works for DNV and is also principal investigator, principal researcher at Barcelona Supercomputer. And we'll be hearing about standardization of climate services in the context of Climate 2 and C3S. Asson, thank you very much.
Thank you very much, and I'm your last speaker today, so hang in there just 5 more minutes. Very good. So I'm going to explain a little bit what the work that is being done in Climate Europe 2, just one specific set of presentation of the general things that we are doing on standardization, and then I'm going to share with you some insights of a case study that we actually did of C3S. So Climate Europe 2 is a Horizon Europe 2 project, a CSA that focuses on identifying recommendations for standardization of climate services, and it also works for supporting the climate services community and for enhancing uptake. One of the important things I believe we did in this project, which has many partners, many of them in this room, including ECMWF, is to start thinking very broadly as to what is it that climate services really are. Not very straightforward, a very complicated term, and we came up with the idea of these 4 components to make sure that we are not forgetting any of the very critical aspects of climate services when we start thinking about recommendations for standardization. So we need to start not from the climate data and information, which is fundamental, but we need to start from the decision-making context, think about the ecosystem of actors and the co-production and engagement with those actors, think about knowledge systems, all the different types of knowledge systems with which climate data and information needs to speak with and relate to, and lastly, also the delivery mode and the evaluation and feedback and mechanisms and monitoring and evaluation that we need to have to assess and to improve the service. Now, this framework for understanding climate services and the standardization of climate services has been, it was a coincidence in time, if you wish, or this is the right moment in Europe to really do this. We were called upon by DG Clima colleagues who were actually working on what is called a standardization request. So it's a policy mechanism that the Commission uses to implement policy. So they were building up a standardization request thinking about adaptation to climate change and priorities for Europe. And we brought to this standardization request these ideas about climate services. And now we have it, it's published, and it is actually a public document that you could consult. And what it asks is two things. It asks to evaluate whether existing standards for critical infrastructure in Europe that have a long life cycle should be revised to use, so they are able to use not only past data and historical data, but also climate data looking forward. And it also mandates the standardization of climate services. Now, Niels has talked about Sense and Elect. Sense and Elect is the standards body at the European level that interacts with all the national standards bodies in the EEA countries. And the Technical Committee 467, which is the one on climate change, got a mandate to execute this standardization request. The project Climate Europe 2 has a liaison agreement, so we are totally embedded. And as Niels also said, we are working on a SEN workshop agreement, which is a pre-standard. And this has led to two very important things. One is that the execution of the standardization request, it's already having two standards. The first one, which is a basic framework standard on principles, requirements, and guidelines, should be ready by 2028, is led by Norway, and actually I am the project lead of this standard. The second, we just kick it out, is focused on management and processes, and is actually going to be led by Meta Iran colleagues from the Irish Standards body. And in addition to this, the project has produced the suggestion, which has been uptaken by the SEN committee, of considering the importance of having an additional technical specification standard that focuses more on the data quality, traceability, robustness. These are just suggestions emerging from the project, and also to have a technical report or another type of instrument that really summarizes key indicators for service quality and performance. All right, so that was the update on standardization. And what I wanted to share with you, which is very interesting, after sitting with you here all day, none of the insights that I'm going to share are actually so strange. I think it's exactly what we are seeing in C3S being done. We did a case study, and what we did was to interview and do document analysis colleagues in ECMWF and in C3S, and we went through these four components, doing quite an in-depth analysis of the work that is being done. We have a very long document. We created what is called a narrative, where you have the summary of the material and the interviews, and then we had all the colleagues, all the different work packages in Climate Europe 2 sort of reacting and reflecting on what our C3S colleagues told us. And that gave us a sort of like a bird's view of what C3S is and does. And the key insights that we got is clearly C3S is an upstream climate service, and it plays a fundamental role in Europe. And it shows this value, the strong value of synthesizing Europe's complex climate data landscape into quality assured, standardized, and policy relevant information, even though it doesn't directly engage with downstream users and with non-technical decision making. It does so through intermediaries and through partnerships. Now, user-driven at this upstream level is primarily reflects the policy and the institutional priorities of those with whom they are being interacting. So in practice, basically the alignment is strongest with EU and member state agencies. And this has to do with the sort of institutional mandate that C3S does. So again, it's neither good nor bad. It's just the way in which the institution has developed, but it's important to sort of see that. So what we lack is that the locality and the place-based, or the users that are not prioritized by European and by national policymakers. So intermediaries, partnerships are absolutely critical for C3S in order to translate the outputs, the products, the data into actionable insights and specific, that are specific for users and for decisions. Also, quality assurance. We heard in Andre's panel previously the great work that is being done in this, but it's very focused on the climate data and the climate information, less so on the co-production side. And I think this is true of most actors, and one of the reasons why we have chosen the co-production as one key topic. So my last two insights here with you are also obvious, that the long-term sustainability depends on the public value recognition and the adaptability of C3S. And this means that C3S needs to continue funding, because doing all this work, and especially the engaging and the partnerships, takes time and it takes funds. So continued funding and policy support is necessary, along perhaps with the flexibility to address those more emerging, perhaps less prioritized user needs or sectors and non-policy demands. So I leave it there. That's our announcement for tomorrow. If you want to know more, please go to the QR code.
Thank you. Thank you very much. And I wish we had a bit of longer time, because I think there's some fantastic insights coming from us and related to the evolution of climate services and what we can do to develop, co-create climate services together. So for the remainder of this session, I think we've got a quarter of an hour left. We'll have a very quick roundtable. I know everyone's itching to get back, have a refreshment before we go out to spoon the boat. So I've just got a little reminder while Carlo, Kinga, and Rutger come to stage that, yep, Carlo, sorry. So spoon the boat, 7 p.m. At the end of this quick roundtable, there will be a quick QR code being flashed up, and it will show you where the social event will be taking place. So we've had a lot of really insightful insights into how we gather user requirements, but this session is also related to gaps, bottlenecks within C3S climate, within the C3S service as well. So, Kinga, I'm going to pick on you first. As a user, as a core user in the NTP, what can we do more as C3S to support uptake or support you to derive meaningful information to serve your user needs at the national level?
Well, we have actually made a small brainstorm within our team to answer such a question, and we came to a conclusion that the plenty of data sets that C3S produces is both the advantage and disadvantage, because a simple user, an experienced user, can easily get lost. And it is crucial that we have the national hubs that translate somehow the plenty of data, which comes in English, of course, into the national needs, into the national languages. And this comes, well, with such a problem that, of course, we have no grants, and this is fantastic because we can focus on a specific problem and specific outreach and communication. But on the other hand, I think it would be also necessary to have some, in the long term, financing possibilities that we sustain the national hubs that provide the data to the end users in national languages. That's, yeah, that's crucial. And also the second thing, maybe rather a challenge for C3S, is that the current spatial resolution of all the reanalysis is made for, let's say, country scale analysis. And when it comes to specific regions like coastal or mountain, which is, for example, our case, this is not enough. Well, we are of course happy that we can do it within our grant right now, but still there is no such a product in C3S right now. And also the extreme events that we speak much about this. So the minimum and maximum values of many parameters is not as accurate as we would probably like them to be. So we see those two areas that maybe some new products could come. The regional products, like for coastal and mountain regions, and the extreme or extremes, yeah, some products for extremes.
Okay, thank you. It's really useful insights. And Carlo, I think there's probably a lot of information there for C3S or you to digest and respond to. So I'll give you the opportunity to respond briefly.
Yeah, I'm trying to organize my thoughts. A lot of things comes to my mind. Well, first of all, thank you. This is really the kind of feedbacks we need, and so we will be responding to this requirement. And in a sense, I think it's difficult to think in the abstract, right? For instance, it is often said that reanalysis has a poor precipitation field, which is a correct statement. And still, in many parts of the world, I would argue that's probably the best you can get because you don't have a better data set. So rather than thinking in terms of resolution or accuracy in the absolute, I think it would be useful for the dialogue to characterize what is needed and why, because there are solutions, and we heard this morning in the AI setting, new tools that may allow us to go beyond what is available now. But it's important to characterize, I mean, I guess is linking directly to what Hassan was saying. There is this last mile, and that last mile is very specific. It's user-specific, it's site-specific, it's context-specific. And the more we understand, even at the upstream level, the more we understand of the nature of the use case, the better we can respond to that challenge.
Thank you, Carlo. Thank you. And Hassan, I think Carlo brought you into the discussion there, but I think C3S, obviously, it provides high-quality, accessible climate information. But what extent does this translate into decision-ready information? And where can we address these, and how can we address these gaps?
So my initial thought is it's not really a gap. I think it's more the awareness of the complexity that climate services entail an interaction across an ecosystem with many actors. So the climate service is a complex animal. It's not just one thing. So I think it's this awareness and perhaps trying to understand what is exactly the optimal role to take on this as an upstream European level organization. But I think there are perhaps two things that might be interesting, and I understand that they require, again, support, funding, and planning, and the skills of the staff to do it. So one is more of the looking into the last mile, and particularly of users who might not be, or cases that might not be prioritized by the European policy level or at the national policy level, to look at, I don't know, sectors that are extremely vulnerable, areas or groups that are extremely vulnerable. And then perhaps the other interesting thing that is perhaps missing is that there is an enormous amount of private providers out there, all doing things differently and taking things from different places. It would be absolutely ideal if C3S were to have a set of partnerships or a way to channel or to interact in a much more formalized way with private providers, at least to start with the dialogue. I don't think that exists, but yeah.
Carlo, I'll let you respond.
On this last point, I think that the event that Climate Europe to organize in Barcelona for the private sector was very interesting in that respect, to understand the landscape, but also to engage with some of these private sector players. I think we are at the infancy of that interface, but it's potentially a very powerful one.
Excellent. Fantastic points. And Rook, I'm going to bring you into the conversation now. As you're very aware of the feedback loops and how we gather the requirements through the help desk, through the NCP, through workshops, through the URDB, are they working effectively? If not, what more can we do?
Well, as I think we mentioned, I think it's important to use different channels, and we have quite a good number of channels. But following on what Kinga said earlier, I think if you especially want to reach these new users, underrepresented user groups, you often come across the challenge that it's sometimes bewildering for them to learn about C3S and the different data products, and they really need guidance on what is useful for them, what would be the best data set to choose. And I was actually quite inspired by the session earlier today where we saw all these tools that are being developed, like a chat-based guidance into the CDS. I think there's a lot of opportunity there, but we still need to implement it. And I think the urgency is quite high. We heard this morning about the urgent pressure. So I think there will be an increasing demand for climate information across multiple sectors, and people really need to start using it. But it also means you need to invest in capacity building and ensure that people use the data in the right way. It's not straightforward, but there's also a lot of opportunities there, I think.
Yeah, it's certainly not straightforward, but it brings opportunities. As technology evolves, then they may help address some of these. So I just wanted to bring in thoughts from the floor. So if anyone's had any thoughts, any suggestions, any questions that could be... Peter.
Oh, you were happy there for a while because you were concerned I was going to ask a question. So, as one of the contractor who has a data set that has been sitting for a long time waiting to get published, I know there's a backlog to get data sets published, but my question is to Rutger, for example, when you have workshops, are you aware of all the data that has been produced by contractors? And to also directly answer users that, well, this data is in the pipeline and coming, and to be direct in communication about requirements that can be fulfilled and help prioritize the queue to getting data sets published.
Quite honestly, I don't think I'm aware of all the data sets, nor of all the details of all the different data sets. I mean, there's some data sets I use myself, so I know them quite well, but others I use never or hardly ever, and then I'm also not familiar with the details. But it's not just a challenge for me, and obviously an event like this is also very helpful for us to learn about all the plans. It's also a challenge that users come across, so they're not aware of new developments, or if something is being implemented that may actually address their needs, how do they know about it? I think unless they follow C3S social media channels very actively, they may not learn about this. And something we have been having in the planning for a while now is to have sort of a user engagement communications webpage where people can actually look back at some of the events we've been organizing, but where we can also show some of these success stories that Niels presented, like people have been asking for an extension, back extension of AR5. Look, now it's actually available. But that communication bit, I think, can be a little bit stronger sometimes, so that people are more up to date with all the developments, because C3S is constantly in development.
I mean, it's certainly constantly evolving, but Carla, I know you probably would like to respond here.
I think you have a point there, in that actually has been identified in one of the recent dataset board meetings, saying, we should ensure that the people who attend this workshop are fully aware of what's on the list. And it's it's an issue of complexity. But we are aware of that issue, and we are trying to tackle. And in a sense, the risk is to collect a requirement that is already addressed, which is a risk, but it's not a dramatic risk. So it's a bit of a waste of an opportunity, if you want, but it's not a damaging risk. So we are aware, we are managing that, but yeah, you have a point.
Just one, also between contractors, we are meeting here and finding out what others are doing, and how we can connect better. So it's good to have more awareness of what has been produced or what is being produced. So to have those connections is also very useful for us to develop our own data sets.
I think in Copernicus 1 we used to have a roadmap of what was coming published, and that's potentially something we could revise.
Yeah, I guess it was simpler when there were 10, 12 data sets. I think we are on 147 now or something, and it's a bit more complex. But yes, as I said, it's something that we are aware of and we are trying to improve on.
Hugo, did I see you were wanting to ask a question? I think it'd be very fitting for the last question to come from the European Commission on this topic.
Yes, thank you. Well, it's not so much a question, I would say. It's more commenting on some of the elements we have heard. So, first of all, I would like to congratulate you to the achievements within this NCP program. I think that's really great. I enjoyed a lot the presentations from the different And so this is a mechanism which has proven to be, in my view, quite effective. I think it's true that it's a grant. It's in a way it's a one-off. It's not sustainable financing, but frankly, that's not meant to be like that. Also, so we hope that through these activities we can stimulate new workflows, new resources, maybe as well in member states that indeed takes this then over and implement that in the national framework. So on the user requirements as well, that's an extremely important exercise. It's sometimes a bit mechanic or boring even or something, but it's nevertheless, it's important, the engineering of these requirements. I was just having a comment there, which is not specific to this service. It basically covers all the different Copernicus servers, so the issue is more or less everywhere the same. So of course you are doing these requirement exercises. There's very little connect back to the program level, so to kind of aggregate these in a way at the with less granularity, of course, but at the program level. Also, that's a common thing which follows us since a decade or so at least. That's just a comment. No? So we don't need to find the solution right now before dinner. Yeah, but then on this last mile, I mean, clearly the last mile is critical. It's without this last connection of this last mile, we don't go anywhere. But here as well, I have to say, this is a European program. There are different reasons why we stay at the moment at a certain level. We don't go too deep into the national realm, or let alone regional and so on. We don't, simply politically, we don't have necessarily the mandate to do that. So it's our interest is more to stimulate the development of these things, no? Because I feel that if we go everywhere and all this, so we mentioned that that's very specific in terms of language, in terms of country-specific regulation, maybe, or all sort of things, no? So we really risk to dilute our activities and to lose a bit the focus of what we are doing really good, no? And that should be at the end in the center, no? But that's not at all to diminish what these NCPs are doing, but just to explain a bit why it's built in the way which you may find maybe a bit unsatisfactory or insufficient. But there are reasons why it's like that, no? So, and we can still try to think together with our partners to see if there are ways to improve the overall situation, no? Thank you.
Thank you. Thank you. And on that note, I'd like to draw this session to a close. I'd like to thank all the panelists. I think we'll have to park the question, I'm afraid, and we can talk afterwards. But I'd just like to close this session. Thank you all for bearing with us. I think we've done pretty well on time, considering I kept really bad time at the beginning. Thank you all. And again, a reminder for spoon the boat? Spoon the boat? Spoon the boat? Yeah. Anyway, there should be a QR code. I was told there would be a QR code on the screen. If it's not there now, it should be forthcoming. But and it should be 7 p.m. tonight, the social event. So I look forward to meeting you there and having continued discussions if necessary. But thank you very much. Thank you, Kinga, for staying around. Thank you.